എനിക്കൊന്നും ഇഷ്ടമാണ്. കല്യാണമൊക്കെ കഴിയും.
Good morning, sir.
Hello, sir. Good morning. I hope you can.
Can we start the session by 10?
Yeah, fine, sir. 10 o'clock can start. Yeah. Sir, any idea about the participants, like a number of participants and then their background?
Sir, we have selected about 100 participants, but about 70 participants used to join,
Okay.
and participants are from different backgrounds, sir. Some are at beginning stage of research, and some are about at the stage of completion. And we have also selected part-time scholars who are faculties at various colleges.
Okay. So basically, this crowd is research scholar group.
Yes, sir. It's for research scholar. Assessor sir, research methodology courses for MPhil, PhD, and PDF scholars, sir.
Okay. Fine.
Okay. So, can we start?
Yeah, I could see only 24 participants.
Okay. So maybe we shall wait for
No, it's
2 or
up to
3
you.
minutes, sir.
I'm fine with anything.
Okay, sir. Then
So
I think we
I
can
should
start.
not do something for the sake of doing. It should reach the participant ultimately. Then there is no point in spending the time, This is my
Uh,
philosophy. No, it's up to you. For
yes,
the organizer, you can take it up.
okay, sir. Then in 1 or 2 minutes we can start, sir.
Yeah.
Sir,
Yeah.
a
Shall we
warm
start?
good, yes, sir. We should start.
Yeah.
A warm good morning to one and all present here. Today, we are moving to the eighth day of our ICSSR research methodology course. Today, we have an eminent resource person with us, Dr. P. Murugan. To give a brief description of him, Dr. P. Murugan is working as an assistant professor at Indian Institute of Management, Shillong. Previously, he was with the University of Hyderabad, Australian Council of Education Association of Delhi, National Institute of Technology, Trichy. He has a passion for research and he has been a resource person for more than 190 workshops and FTP programs, held many universities and B schools in India like IIT Bombay, SPJMR Mumbai, and NIT Trichy. His expertise lies in the areas of multivariate data analysis techniques, mediation analysis, moderation analysis, structural equation modeling, latent profiles, and item response theory. He is also familiar with data analysis software such as MS, Python, R, JSP, SPSS, Concurrent, IRT Pro. His papers are published in SSI, ABS, and ABDC listed journals. During the COVID-19 pandemic, he has started to offer online workshops in the area of ICT tools in education, operational resources, MOOC development process, HR analytics, and interacted with more than 10,000 participants. He has developed online lecture videos for 3 of the courses offered to the platform. Sir, we are happy to have you at our ICSS technology course, and I'm sure that participants will be enriched with your knowledge, sir.
Thank you.
Today, we
Thank
have
you.
Thank you, sir. Today, sir will be discussing analysis of variance and covariance and multivariate data analysis, structural equation modeling. Uh, Thank you, sir.
Thank you.
So,
Thank
session
you,
is all.
Amal sir.
Yes, sir.
Yeah, yeah. Thank you. Thank you, Amal. And thanks to Velmurugan sir for the warm invitation. Formal good morning to everyone. After a long time, I'm doing some online session. No, I do have another window, I mean, another screen. So you can show your face, no issues. And you can, then and there, I mean, if you have any questions, then and there, you can also ask your questions. Either you can post it in the chat window or you please come to the live chat. So I'll try to answer your questions. So today, what I'm planning to do is I'm going to do two different activities. One is just the demonstration of understanding one-way ANOVA and then one-way ANCOVA analysis. Then later, I'll start with the same. Actually, I asked for 2 hour, sorry, 2 session um, for covering structural equation modeling, but due to some reason, maybe part of the, I mean, the entire program mandate, they just allocated only one session for SEM. So honestly speaking, covering the entire structural equation modeling topic within 1.5 hours is really impossible. Impossible in the sense, either I can touch upon the conceptual part or I can do the analysis part. Both may not be possible. But today, I'll try to cover as much as possible. So I need your support for that. So initially what I'll do is for the first 30 minutes, I'll give you some overview about understanding the entire ANOVA family of technique. Then after that, I'll show you how to perform the analysis using SPSS. Since SPSS was mentioned in the session plan, I'm going to stick with SPSS. Otherwise, you can also use some of the open source softwares, maybe or RStudio or R Commander or Zamovi, AdZasp, or Blue Sky Statistics. These are all like open source packages available in the literature. So with the help of those softwares also, you will be able to run the analysis. So if time permits quickly, I'll also repeat the same analysis using any one of the open source software. If time permits, I'm not committing anything here. And now the time is approximately 10:05. What I'll do is up to 10:40 or 10:45, we'll have some discussion about ANOVA family of technique. And then I'll also show you how to run the analysis using SPSS. Then later I'll start with the structural equation modeling. And in terms of covering the SEM analysis part, I'll be using R software. And parallelly, I'll also show you, if time permits, one of the open source software like JASP, how you can also run the analysis using JASP package. So this is what I'm going to do now. Okay, first let me start with the independent sample t-test. I hope you can see the whiteboard, right? I hope you can see the screen as
Yes.
well as whiteboard. So basically, in independent sample t-test, for example, if you have some y variable, and that is measured using metric data points. So hereafter, I'll be referring metric data as well as non-metric data to refer four levels of measurement. Metric data is related to two types of measurement. One is continuous type of measurement and then ratio type of measurement. I hope you have some basic understanding in terms of understanding the four levels of measurement. And then whenever I say non-metric data point, that is NON, non-metric data points. So I would be referring either nominal type of measurement or ordinal type of measurement. So this is what I'm going to do now. So even for SIM as well as ANOVA family of techniques also, I'll be referring or I'll be using only metric data and then non-metric data to refer your levels of measurement in terms of measuring your IV or maybe dependent variable. So this is how I'm going to refer. So if you look at independent sample t-test, I have some y. This y is nothing but my dependent variable. This y is nothing but my dependent variable. And then I do have some x. This x is measured using non-metric data points. So non-metric in the sense either it could be measured using nominal type of measure or maybe ordinal type of measure. So what I'm trying to understand here is this y is measured using metric data point. This x is measured using non-metric data point. Basically, I'm trying to understand the mean differences between these two groups. For example, when I say non-metric data, let us assume that here I have a variable called gender that is measured using two different categories. One is male and then another one is female. And this is coded as 1 and 2 or zeros and 1 or ones and 0. It can be anything. Whatever may be the way you want to code it, you can code it. There won't be any issue. But in SPSS, you try to fix your type of measurement as nominal before you do the analysis. Otherwise, system will treat this ones and twos as a metric data points basically. So that is how you can understand the way in which how you can do the analysis. I'll also show you how to fix this particular type of coding as nominal type of measurement and so on in the SPSS variables option. So basically here what I'm trying to do is, for example, here I have salary and I do have some 1,000 data points with respect to gender as well as their corresponding salary. Basically, the research question here is I'm trying to answer, are there any mean differences? Are there any differences with respect to the salary paid by the organization among the employees? I mean, in terms of the gender, I'm trying to understand this. It can be anything, gender or maybe or maybe the kind of educational qualification they have. It can be anything. It can be anything. So basically, the primary logic of understanding independent sample t-test is whenever you have nominally measured independent variable and then you have a metric data point that is dependent variable. So in those cases, what we are trying to do is we are trying to understand the mean differences between these two groups, I mean, male and female groups available in our data set in terms of understanding the mean differences or maybe salary differences. This is what we are trying to do in the case of independent sample t-test. And traditional researchers, they say that when I have less than 30 sample, we can use t-test, and more than 30 sample means you can use ANOVA and so on. There is no, I mean, if you dig the literature deeper, there won't be any citation which will say that 30 means small sample and then above 30 means larger sample. So those things are like, I can't say it as a myth, but in traditional textbooks, I mean, statistics books, there are cases where they have cited those sort of information. So that's the reason even now people are referring. But according to me, the sample size criteria and then how many responses you are going to keep it in your data set, everything is purely dependent on your hypothesis and then your research question. So here, if you have more than two groups, basically when you have a y and x is measured using group 1 and group 2, this can be solved with the help of independent sample t-test. Suppose if you have a y and which is measured using, I do have a x which is measured using three groups, that is group one and then group two, group three. So here you can't apply independent sample t-test. So here independent sample t-test is possible, but here this is not possible. Then what is the way out? What else you can apply? Any answer from your side? Still, I have the same information here, that is salary. This is what my dependent variable. My independent variable is educational qualification. This group one is referred as UG, group two is referred as PG, group three is referred as PhD. So basically, with respect to my educational qualification, I have three categories. Now I'm trying to understand, are there any salary differences with respect to my three group of information available under my IV? I think somebody has posted the answer. The answer is ANOVA. Yes, you are right. So when you have more than two groups, for your independent variable, that time you are not supposed to use independent sample t-test. You can't use basically independent sample t-test. What else you can do is, either you can use one-way ANOVA or any form of ANOVA family of technique can be applied here. This is the way how you can run the analysis. Fine, makes sense? Now, if you have a y, hereafter, whenever I say y will be measured using metric data points. And for x1, x2, x3, and all those things, I'll also give you some additional information. So I do have x1 and then x2. Now, this x1 is measured using group 1 and then group 2. This x2 is measured using three groups, group 1, group 2, and then group 3. Can you suggest some technique, appropriate technique in terms of analyzing the data? So still my research hypothesis or maybe research goal is I'm trying to understand the mean differences with respect to this y on the basis of this x1 as well as x2. Maybe this x2 can be referred as educational qualification level of the people, and then this x1 is referred as gender. Now, can you tell me which technique we can apply here? Any idea from the participant side? Any idea? Which technique we can apply? Ankova, are you sure, Bala Aishwarya? Sure. Okay. Any other guesses? Any other guesses? Any other guesses? Not sure. Chi-square. See, try to understand when you can apply chi-square. You have a dependent variable or maybe variable one, and then you have another variable, that is variable two. When you are trying to understand the association of relationship between two different non-metric data points, that is categorical in nature. For example, your x is categorical in nature, your another variable is also categorical in nature, and most probably you might have measured your x using group based measurement. So if that is the case, there you can use chi-square test. Please try to understand that. Chi-square test is one of the non-parametric tests. Here we are trying to understand some of the parametric family of approaches. Two-way ANOVA. Yes, very good, Vishal Krishnan. So this particular model is referred as two-way ANOVA basically. Able to understand? So when we say, when we can say it's a two-way ANOVA or one-way ANOVA, when you have only one independent variable and that is measured using categorical data point, that is nothing but one-way ANOVA. When you have two categorical variables on your x side and still you have a metric dependent variable, so in that case you can refer this particular model as a two-way ANOVA. This logic is clear? So this analysis is referred as two-way ANOVA. Basically, I have, for example, you think it from factorial design point of view. In experimentation, we have a design called factorial design. So when we can say a particular design is referred as a factorial design, when you have two independent variables, the manipulation conditions could be different. Like you might be having two conditions or three conditions, it can be anything. But when you have two independent variables and when you're trying to see the combined effect of those two independent variables on your dv, so in those cases we employ this particular two-way ANOVA technique. This logic is clear? Fine. Okay. Now let me move on to the next part. I have a y and then x1, x2 and then x3. Now you tell me all of this x1 to x3 are measured using non-metric data point and this y is measured using metric data point. Can you tell me which technique we can apply? Sir, in two-way ANOVA, there can be two subgroups. No, it can be anything, irrespective of the groups. For example, your X1, Bala Aishwarya, I'm answering your question. For X1, you may be having two groups. For X2, you may be having three groups or four groups or five groups. It doesn't matter. Basically, you have two independent variables. So that particular model is referred as two-way ANOVA. Nothing to do with the group size. Okay. Now come back to this page. Can somebody tell me which type of analysis you can run here? So one side we have a metric dependent variable, and then another side we have x1, x2, x3. Everything is measured using non-metric data points. So basically, my x1 is having two groups, that is group 1 and then group 2. X2 is measured using three groups, group 1, group 2, group 3. And then x3 is measured using group 1 and group 2. This is the kind of groupings I have. Now, can somebody suggest some approach which we can use in terms of analyzing this data? Manova, are you sure? Thanks for your guessing, Aarti. No. So this model is referred as three-way ANOVA. Logic is clear. Since we have three independent variables, so this model will be referred as three-way ANOVA. That's the way how we refer the ANOVA family of techniques up to NV. For example, another model, I have a Y which is having x1 and then x2 and then x3 and then x4. So basically I have four independent variables here, and everything is measured using non-metric data points, and Y is measured using metric data points. Now, can you tell me which type of analysis we are trying to use here? Any idea? I could see a lot of laughing faces. Yeah, any answer? What, Vishal? Any answer? No response in the chat window. Can somebody quickly guess the answer?
Four-way ANOVA.
Sorry?
Four-way ANOVA.
Sorry? Yes, that is what I'm asking. So this model is referred as four-way ANOVA. Logic is clear? If I have one more IV, that is XY, this is referred as five-way ANOVA. But explicitly in the literature, while reporting the results, they never say that it's a three-way ANOVA or four-way ANOVA and so on. Usually, they say that it's a one-way ANOVA or one-way ANCOVA and so on, but they never disclose. If it is going beyond one variable or maybe two variables, maximum I have seen some papers where they have explicitly mentioned it's a two-way ANOVA, three-way ANOVA and so on. Beyond that, I have not seen any paper. Same model can be analyzed. Same type of equation can be analyzed even with the help of one more technique, that is nothing but dummy variable regression. So you create the dummy codes for your x1, x2, x3, x4, xy, and then still you can do the analysis with the help of OLS. But whereas in the ANOVA family of technique, we use the estimation technique called maximum likelihood estimation. That's the difference between your OLS regression and then MLA. Apart from that, the coefficient values, the results are almost the same only between your regression as well as ANOVA. Okay, now I'll introduce one more interesting topic. I have a Y that is measured using metric data point, and then I have a AX, X1 is measured using non-metric data point, plus I have a X2, this X2 is measured using metric data point. So metric means this x2 is a kind of metric variable measured using interval scale type of measurement or maybe ratio type of measurement. For example, I have here expenditure. This expenditure is nothing but my dependent variable. And then this x1 is nothing but gender. And then I have a x2. This x2 is nothing but family income. Now you tell me which technique we can apply here. X2 is metric in nature, Y is metric in nature, X1 is non-metric in nature. Any quick response? Yeah, Bala Aishwarya, you're right. This model is referred as ANCOVA. So basically, this X2, metric X2 is nothing but covariate. This X2 is nothing but covariate. And practical meaning of understanding covariate is nothing but another metric independent variable that is sitting in your ANOVA model. So basically, the role of family income here is this family income will partial out certain effects on expenditure level of the people. Then after that, whatever may be the leftover difference that is existing with respect to gender of the people, that is male and female, that difference will be seen with respect to this gender. That is what we are trying to do here. For example, I have some level of family income and I do have some expenditure. Definitely family income will have some role in terms of determining my expenditure level, right? Over and above, are there any differences with respect to the spending pattern of male as well as female? That is what I'm trying to understand here. So this is how we do the ANCOVA analysis. This logic is clear? Able to understand? Now I have a y, x1 is non-metric, x2 is non-metric, and then x3 is metric. X3 is metric, x1, x2 are non-metric, y is metric. Now can you tell me which technique we can apply? Balashurya, any response? Any response? Don't know. Okay. Your previous answer is correct. Even your previous answer holds good here also, which means that this model is nothing but two-way ANCOVA model. That's it. Basically, we have two independent non-metric variables and then one metric variable. So still this model is referred as ANCOVA only. Analysis of covariance. Basically, this X3 is a covariate here. This logic is clear. Now, I have a Y x1 plus x2 plus x3. These three variables are measured using non-metric data points. And then I do have a x4. This x4 is measured using metric data point. Y is metric. Can you suggest some technique? Again, I could see a lot of smiling faces. Three-way ANCOVA. You're right, Maithili. Correct. You're right. Same answer. So still this model is referred as ANCOVA only. We never call it as a three-way or two-way ANCOVA, but still this is referred as a ANCOVA model only. This logic is clear. There are designs, experimental designs, where we measure certain things before we conduct the manipulation. And then after the manipulation also, we measure certain things. So that before measurement is referred as pre-test score, after measurement is referred as a post-test score. In most of the analysis, pre-test score will be acting as a covariate in their analysis. Basically, the pre-test score will partial out certain effect on DV, and then whatever may be the leftover effect available, that will be explained, or that particular difference will be seen with respect to their manipulation condition. So this is how they do the analysis, especially in experimentation. This logic is clear. Now I'll bring some more complexity here. Now I have y1 and then y2 and then x1. This x1 is measured using two categories, that is group 1, group 2. This y1, y2 are nothing but my two dependent variables that is measured using metric data points. Now can you suggest some technique? Still my interest here is I'm trying to understand the group differences with respect to both of my DVs. Simultaneously I'm trying to understand this. Can somebody suggest some technique here? Any answer? Yes, Bala Ishwarya, you are right. This model is referred as MANOVA. Whenever you have more than one dependent variable, that time you can approach your analysis with the help of multivariate analysis of variance, that is nothing but MANOVA. Still, this particular model can be analyzed with the help of two different ANOVAs. For example, y2 on x1 and then y1 on x1. This is possible. When it is possible is when you say that there exists a orthogonality between y1 and y2. Orthogonality is nothing but there exists a nil correlation between y1 and y2, or sometimes the correlation must be really lower. If that is the case, still this particular analysis can be done with the help of two different one-way ANOVA analysis. That is possible, very much possible. Or even still you can apply two different independent sample filters, since we have only two groups in our IV. But in most of the cases, in especially in management or maybe social science research, we do see some level of correlation between both the DVs. So if that is the case, the better approach is applying MANOVA, that is multivariate analysis of variance. This logic is clear? Now I have y1 and then y2 and then x1 and then x2. This x1, x2 are measured using non-metric data points. Y1, y2 are measured using metric data points. Can you tell me which technique we can apply here? Any idea? Any idea? Still, this model is nothing but MANOVA only. You are right, Balaman. You are right. Still, this is MANOVA only. Okay, now I have y1, y2, and then x1, x2. These two independent variables are measured using non-metric data points. Plus x3. This x3 is a metric data. Y1, y2 are metric. Which technique we can apply? X3 is metric. X1, x2 are non-metric. Y1, y2 are metric.
Vancouver.
Yes, you are right. This is nothing but Markova model. Able to understand the differences between independent sample t-test to MANOVA, Markova, and so on? Make sense? Of course, here I'm not going to show you how to run MANOVA and Markova analysis, but I'll be showing how to perform independent sample t-test and then one-way ANOVA and then one-way ANCOVA. So this is what the scheduled agenda. And here I would like to make one more disclaimer statement. I'm not covering the background theoretical aspect of understanding ANOVA, like how the estimation is happening in the software, and then how you can also compute the mean differences, and then on what logic we are also arriving the p-value. So those things and all I'm not covering here. So straight away I'm going to use the software in terms of explaining all those approaches. Make sense? Any questions at this point of time? Sorry. Okay. Now, for this purpose, what I'm going to do is I'm going to use a data set associated with one of the experiment-based study. So this data can be obtained from this particular source. Let me show you the source from where I have downloaded this particular data set. Sorry, just a minute. It's taking some time to locate the source. This is the source where I have downloaded this data. So let me give you some explanation to understand the data nature. So basically, this study is a 2 into 2 factorial design. 2 into 2 factorial design means they have two independent variables, and each independent variables are manipulated using two different conditions. So this is what the design they have used. So the design is like this. One is leadership style, Another one is leadership order, and which is having two different conditions basically. So here the first condition is servant leadership and then transformation leadership. So here you have before crisis situation and then after crisis. These are the two conditions basically. So basically here we have cell 1, cell 2, cell 3 and then cell 4. So basically these are the four conditions we have. So in leadership style, we have two categories, that is two levels or two treatment levels. And then in leadership order, again, we have two treatment levels. So basically 2 into 2, you will get 4. So basically we have four conditions here. And they have used 164 university students in terms of creating these four conditions, and 164 students were divided into equally divided into four components. In each group we had about 41 participants, and just look at this explanation. The first experiment described the data of 164 university students in a 2 into 2, that is leadership style manipulation, servant leadership versus transformation leadership, and the leader presentation order manipulation before crisis versus after crisis design. Organizational reputation, servant leadership, and transformation leadership were measured as experimental checks. Workplace deviance was the dependent variable. So workplace deviance is measured as a dependent variable in the study, and the rest of the two independent variables are manipulated with the two different conditions, that is servant leadership and then transformation leadership, and then before crisis and then after crisis. So when you look at the data, this is how the data is looking like. So here we have the dependent variable, that is organizational deviance. So here a student age is measured basically using metric data points, and the gender is coded as 1 and 2. So here you have the variable called leader style manipulation. This is having two conditions basically. This is coded as 1s and 2. And then leadership manipulation, sorry, leader order manipulation. This is coded as after crisis and then before crisis. Basically, we have 2 into 2. Now, when you do the cross tab for this particular two variables, I mean manipulation variables, rows and columns, you will get exactly 41 frequencies in each cells. Able to understand? So the total student size is 164. Now able to understand the data nature? Now what I'm going to do is here in terms of running the one-way ANOVA, I'm going to consider this leadership condition, that is leadership style, as one of the independent variable, and then organizational deviance as dependent variable. So here my hypothesis would be, I'm trying to understand whether leadership style is helping the people to reduce their organizational deviance level or not. That is what I'm trying to understand here. So this can be still analyzed with the help of independent sample retest. Either you can use one-way ANOVA or independent sample retest. Both will give you the same picture. I mean, a similar kind of result only you will be getting. Now I'll show you first how to run the independent sample retest, and then I'll show you how to run the one-way ANOVA analysis for this particular variable. So practically speaking, so I have a variable called organizational deviance, that is dependent variable, and then I have leadership style. So this leadership style is my X. This is having group 1 and then group 2. Group 1 is nothing but servant leadership. Group 2 is nothing but transformation leadership. And then organizational deviance, it's a metric data point. So it's a non-metric variable basically. Now able to understand the logic of this equation? Now, how do we do the independent sample retest in SPSS? So you go to analysis, you go to analyze, and then you just select this compare means. You just select this compare means, and then here you have the option called independent sample retest. You just select it, and then in the grouping variable, you just add this leader style manipulation. Here you give the coding values. Group 1 is 1, group 2 is 2. Click continue, and then my dependent variable is organizational deviance. You just drag it to test variables. Just drag it to test variables, and then click OK. Here you will be able to get some output. So basically in the output, what I'm getting is, you just look at, in the first condition, servant leadership condition, I have 82 participants. Basically, if you look at this particular design, so in the servant leadership, in each cell we have about 41 participants, right? 41 participants, right? So in the servant leadership, with the before crisis and the after crisis, totally how many responses we have? Here 82 responses. Total of this column 1 is 82. Total of column 2 is 82. Similarly, here also 82, 82. Total of everything is 164. This logic is clear, able to understand the reason why we are getting 82 numbers in each category. Make sense? So for the servant leadership condition, the mean value, that is organizational deviance mean value is 2.99. For the transformation leadership condition, the mean value is 3.64. So basically what I'm trying to test it here is, I'm trying to test, are there any mean differences? Are there any mean differences with respect to these two different mean values are concerned with respect to these two groups? So that is what I'm trying to understand here. And at the end of the day, by looking at this p value, whether the variances are equal or not equal, I mean, irrespective of that, in both the conditions, I'm getting significant effect, which means that both the mean values are statistically deferred. Statistically deferred in the sense, actually, leadership style. One of the leadership style is helping the people to reduce their organizational deviance level. By the look of it, when you look at the mean value, I can make certain conclusion here. The conclusion is actually servant leadership style is helping the people to reduce the organizational deviance over and above transformation leadership condition. Reason is, for the transformation leadership condition, I could see 3.64 as a mean value. This is pretty much higher than the servant leadership condition. This is how you can make the conclusion. Able to understand the logic? And here in the 11 test, at a 99% confidence limit, if you see insignificant p-value at 99.99% confidence limit, it's a insignificant p-value. At 95%, yes, it is significant, which means that basically we are trying to fulfill one of the key assumption in terms of running this independent sample t-test. The key assumption here is whether the variances for both the groups are similar or dissimilar. If it is similar, then only you can apply independent sample t-test. If it is dissimilar, you may see some difference that is happening because of statistical fluctuation, not because of your two different conditions. That's how we make certain conclusion. So here, basically, the overall conclusion of this particular analysis is, I could see significant p-value here, and I can say that both the groups are deferred. Basically, both the mean values are completely different from each other. And another practical implication what I can make here is, actually servant leadership condition is helping the people to reduce the organization deviance level over and above transformation leadership condition. This is how I can make the conclusion based on this particular analysis. Any questions? Able to understand? Clear? Now let me show you quickly how to run two-way ANCOVA. Sorry, two-way ANOVA, not ANCOVA. I'll do the ANCOVA little later. Now I'll show you how to run two-way ANOVA. In two-way ANOVA, you will have two different IVs and then one dependent variable. Two IVs are measured using non-metric data points and your DV is measured using metric data point. Now you just go to analyze. So here you have something called general linear model, right? So there you can select this univariate. And then in the dependent variable, you just drag this organizational deviance. And then what you do is you just drag this leadership style manipulation in the fixed factor and the leader order manipulation in the fixed factor. Now you just, full factorial only I'm trying to do. In the options, you ask for descriptives for leader style manipulation and then leader order manipulation. Here by default system will create the interaction effect also. Now I need homogeneity test result, and then we can also estimate the effect size value here. Okay, and then post hoc test, I don't want to do any post hoc because in both the variables I have only two groups basically. If you have more than two groups, you can apply post hoc analysis. Otherwise, there is no point in applying post hoc analysis. Click OK. So basically here in each condition, I have 82 responses and total response size is 164. And if you look at the servant leadership condition, along with the before crisis condition, what is the mean value? Servant leadership with the after crisis, what is the mean value? Transformation leadership with the before crisis, what is the mean value? transformation leadership with the after crisis. What is the mean value? So this is how you can get the mean values for each and every category of conditions. Here, when you look at this Levin's test, so I could see significant value, which means that the variances are not same across the groups. That much only we can make out here. But when you get really significant value in the Levin's test, which means that the variances are dissimilar across the groups. If that is the case, you can't apply ANCOVA or maybe ANOVA. So that is the logic basically. But there are citations which says that even if you're not fulfilling this particular condition, even if you're not fulfilling this condition, still we can proceed with ANOVA by fulfilling or maybe by checking some of the other other criteria. That is also possible. Now you look at the result here. The dependent variable is organizational deviance. And then for the leader style manipulation, the p-value is significant. For leader order manipulation, the p-value is not significant. Just look at the p-value here, 0.106. For leader style, the p-value is not significant. But for the leader style, the p-value is really significant, which means that leader style is creating the difference, but actually leader order is not creating any difference here. That this is a kind of inference you can make out here. And this coefficient is nothing but the interaction coefficient, that is the combined effect of leader style manipulation with the leader order manipulation. Are there any combined effect? The combined effect is captured with the help of interaction term, that is also not significant. So now the conclusion is only leader style is creating some difference with respect to my DV, but leader order is not creating any difference, meaningful difference. This is how you can conclude the result. And for each condition, you have the estimated marginal mean values here. This is how you can do the analysis. Now, when you can apply post-hoc analysis in ANOVA, quickly I'll show you. I do have a variable called condition. This condition is nothing but, see, this condition is nothing but servant leadership with the after crisis. This condition is nothing but servant leadership with the before crisis. This condition is nothing but servant leadership with the before crisis. This is how this particular column was coded. And here I have basically 4 groups. Just look at the frequency table, you will be able to understand. See, this condition is having 41, this condition is having 41, this condition is having 41, this condition is having 41. So basically here I have 4 groups. Now let me check, are there any mean differences that is existing with respect to these 4 groups on organizational deviance score. Just for the demonstration purpose, I'm doing this. You go to generalized linear model and then click univariate. Now, instead of this fixed factor, leader style and leader order, let me include this condition and then click OK. You will be able to get the result. See, condition is statistically different, which means that I'm getting significant p-value. I can also ask the system to produce post-hoc result for the condition variable. Let me use LSD technique. If you look at this post-hoc comparison, that is multiple comparison, post-hoc analysis result. So between this condition and this condition, the mean difference is minus 0.4695, and this is not significant. Only here I could see some significant p-value. Here I could see some significant p-value. Here as well as here I could see significant p-value. In rest of the all other comparisons, my p-value is not significant, which means that in those cases the mean difference is not significant. In rest of the all other cases, the mean difference is significant. This is how you can conclude the result. Now, quickly I'll show you how to run one-way ANCOVA. So you go to general linear model, click univariate. So here I'm using this leader style manipulation, and I'm going to consider this age as a covariate because age is measured using metric data points, right? Now you just look at the result. So here for servant leadership condition, this is the mean transformation leadership, this is the mean value. And if you look at here, age is not at all creating any impact on organizational deviance because the p-value is 0.656. This is not significant, but still leader style manipulation is creating some difference here, which means that leader style is actually creating some difference, but not, age is not explaining any variations in terms of explaining your DB. That is nothing but your organizational deviance. So this is how you can make the conclusion. So basically this result is nothing but your ANCOVA result. This logic is clear. When you want to do two-way ANCOVA, you just add one more independent categorical variable here. I'm just including this leader order manipulation. So this is nothing but your two-way ANCOVA model. Make sense? So this is how you can understand the differences between an independent sample t-test, one-way ANOVA, and then two-way ANOVA, and then ANCOVA, and then two-way ANCOVA, and so on. For more details, you refer any of the basic statistics books, or maybe any of the standard research methodology textbook. I can suggest Marketing Research by Naresh Malhotra. That is one of the fantastic books. There you can get some level of inferences. Otherwise, there are some exclusive books also available in terms of understanding the entire ANOVA family of technique. There are some text available under the label called General Linear Model umbrella. I mean, Generalized Linear Model umbrella. You can get all those explanation like one-way ANOVA, two-way ANOVA, and so on. For more details, you can also refer any of the exclusive textbooks on statistics or maybe ANOVA family of technique. Yeah, any questions at this point of time in terms of understanding the ANOVA family of analysis? Getting something, at least getting some basic level of confidence. The same analysis can be done. Do you have any idea or awareness about using XASP or Zamovi software? The XASP is one of the open source software, and this software is completely free to the public. Anybody can download it under the open source license. University of Amsterdam is giving this particular software at a free of cost, and I mean, Indian researchers and faculty members are highly addicted with the SPSS because right from our PG or UG education, we were told that using SPSS you can run the analysis. That's the reason even now most of the people are using SPSS even in part of the workshops or maybe seminars. But I don't know how far you can get the access for SPSS. CUTN may be having the licensed version of SPSS, but you may not be able to procure it because per year subscription cost is 72,000 or 75,000. At research scholar level, I don't think so we can afford that much of money. So for more details, you just go to this XASP website. Now quickly I'll show you how to run the analysis using this XASP software. So you can visit this site, XASP site, and then you try to download the software. So once you have installed this software in your machine, you will be able to get a window. So still, I'm trying to open the software. Just a minute. Yeah. So this is the software window. This software is completely free and similar to SPSS, you can do any sort of analysis, including some of the qualitative analysis, including some of the meta-analysis, SIM, mediation, moderation, factor analysis, and then you just look at under the machine learning umbrella, you can, I mean, do lot more analysis. Basically, some of the data mining approaches can be done here. So quickly, I'll show you how to do the same analysis using this SAS software. First, let me open the file. My data file is stored in desktop CUTN folder, ANOVA folder, experiment one. This is a data set. So you can import Excel file format or CSV file format or SPSS file format data into SAS window. In terms of running the analysis, you go to this t-test, click independent sample t-test. So here this leader style manipulation is grouping variable, organizational deviance is dependent variable. You ask for the effect size, and then you ask for the equality of variance check, descriptives, and then descriptive plots. Now on the right hand side, parallelly, you'll be able to get the output. This is how you can run the analysis using this app. This is completely free and really easy and highly flexible in terms of running any analysis. I don't know why my system is taking this much of time, but within a fraction of a second, you will be able to get the output. Just look at the output here. So if we look at the independent sample t-test result, see here the p-value is significant, 0.001, which means that the p-value is highly significant. Both the mean values are statistically different. That much only you can conclude here. See the mean value here. Servant leadership is 2.994. Transformation leadership is 3.649. So basically, both the leadership conditions are creating some difference. I mean, creating some difference with respect to organizational deviance. So the p-value is significant. So here the conclusion is hypothesis is accepted. I mean, your null is rejected and your alternate is accepted, and there exists a significant difference between servant leadership and then transformation leadership condition with respect to their organizational deviance code is concerned. This is how you can make the conclusion. So in terms of running the ANOVA, you just go to ANOVA tab and then click ANOVA. So here my dependent variable is organizational deviance, fixed factor is leadership style. You will get the same result here. Exactly same result. I mean, comparing your SPSS output. So in both the cases, you will get the same output. See, here also I'm getting significant difference. So here also you can ask the system to provide some more additional information, descriptive statistics, and then assumption checks, homogeneity test also you can ask. And then in the post-hoc test, if you have more than 2 groups, you can ask the system to produce post-hoc test. These are the few post-hoc options available here. And then descriptive plot also you can ask. These are the other options available here. Just look at the result. This result as well as your independent sample retest result, everything is same. And one more beauty of the software is you get the output exactly in APA 6th edition format. You just copy this table and then you go to your Word and then paste it. That's it. You start writing the interpretation. Need not to do any other alteration with respect to presenting your table. To run ANCOVA, you go to this ANCOVA tab and then you consider leader style manipulation as a fixed factor and then organizational deviance as a dependent variable. And then you ask for the descriptive statistics, assumption check, homogeneity test. And then here in the covariate, let me include this age. So this model is nothing but ANCOVA model. So this is the way how you can do the analysis. Same result only here also we are getting. So basically the Zamovi softwares are created on the basis of some of the R packages available in the open source literature. I mean open science literature. So based on those R packages only, they have created some graphical user interface based menus in the form of software. So there's nothing but JASP. So there are multiple provisions available here. There's all the different packages associated with the JASP. And here also you can run the R programming. I mean, you can run the R syntax by using this R beta. So here you just type the R syntax and then you run the code with respect to this data set. You can do A to Z analysis using this particular software. Whether this software is accepted when submitting our thesis, sir? Yes, accepted. It's accepted. Using any of the open source software, you can run your analysis. I have seen a lot of papers in the recent literature where they have, along with some of my collaborative researchers, there we did entire CFA SEM using this open source software. Now the paper is under review in Journal of Knowledge Management. That is one of the categories. It is accepted. For more details, what you can do is you can visit this ZAS page or you go to YouTube. So recently I have created some of the useful videos that might be useful to the young scholars like you. My YouTube channel is Murugan Patusami. You just go to this channel. I won't force you to subscribe my channel and all. You just watch the video. If you don't like it, you give comment. If you like it, you give some comments. That's it. I'm not expecting any monetary benefit out of this process. So just for the self-satisfaction purpose, I'm creating all those videos. For example, you have another software called Blue Sky Statistics. Blue Sky Statistics is a commercial software. I mean, commercial company, but they are also giving open source license to the public at free of cost, similar to JASP. There also you can do the same kind of analysis. You just go to this Blue Sky Statistics, playlist. And then if you go to this advanced data analysis playlist, so here you could see some of the videos related to mediation analysis, moderation analysis, CFA-SEM using RStudio, and then CFA-SEM using AMOS, and then JASP tutorial. See, here I have created some 10 minutes JASP tutorial. First you can watch it. Then after that you can see the different software. See, here also I have uploaded a video in terms of understanding independent sample retest, one-way ANOVA, and then Pearson correlation, Cronbach alpha frequency analysis, exploratory factor analysis, principal component analysis, confirmatory factor analysis, mediation analysis using JASP. So these are the few videos available here. For more details, you just visit my YouTube channel. And I would like to suggest one more source of reference here. Let me share this link in the chat window. I don't know how to select everyone. It's coming and going. Aarti ma'am, I could see only your name here. I just messaged this link privately. You can post it to everyone. And you can also visit my site, sites.google.com view Murugan Patasamy. So if you go to this website, so here you have a page called resources page. So you just go to this resources page. So here I have compiled some of the useful references. There are certain editorial comments that is coming from Academy of Management Journal and then Academy of Management Review. I just compiled some of the useful references here. For young scholars, this might be useful. Similarly, for literature review, understanding theoretical contribution, construct clarity, research question, theory building, and then factor analysis, regression analysis, structural equation modeling, PLSM, mediation analysis, moderation, parallel mediation, serial mediation, conditional process model, nonlinear interaction, control variables, common method bias, formative measurement, item parceling, scale development, social relation modeling, and then omitted variable bias, indigeneity problem, other general references, and then why papers get rejected, academic writing resources, and then useful books for the research scholars. Those are coming from commerce and then commerce management and then social science discipline. So there are some plenty of resources available here. You can also visit this particular site. Let me share it with everyone. I don't know, I could not able to select the everyone option here. Again, Aarti ma'am, I'm requesting you to copy paste the same link to everyone in the chat window. The reason why it is not, yeah. Yeah, now you can see the links. So feel free to share all those resources with your fellow colleagues and then juniors or maybe seniors and so on. So definitely those, content will be useful to you. Yeah, with that, I'm closing my ANOVA family of analysis. Now let me start with structural equation modeling. Before starting the session, I just want to ask you a simple question. Do you have any exposure in terms of understanding confirmatory factor analysis and SEM? Did you utilize it at any point of time in your research something related to CFA, that is confirmatory factor analysis and structural equation modeling? Any quick response from your side? You can post it in the chat window or you can come to the live chat. Anything is fine with me. At any point of time, did you use CFA and SEM in your research? No, Vishal. Okay. Anything from others? No. I could see several no's. Okay. Here, before I start the session, I would like to make a strong disclaimer statement. So disclaimer statement is nothing but when you see some advertisements related to mutual fund, in small funds, they used to say that it's too risky to make the investment, something like that. So that's the kind of disclaimer statement I'm trying to make it here. I'm just joking. Don't mistake me. So the disclaimer statement is, if you're completely new to confirmatory factor analysis and the structural equation modeling means at the end of the day, I mean, at the end of this morning session, I don't think so. You will be able to get anything out of this session, and don't feel bad for it. Even if I'm going to sit in my session for the first time without having any prior exposure on at least understanding multiple linear regression and then exploratory factor analysis, I don't think so. I'll be able to understand what is SEM and the CFA, even if I'm attending this session for the first time in my life. But you consider this session as a eye-opening session. I'll share some of the resources, or I'll create some path where you can travel for next 2 to 3 years, and then you can strengthen your skill set and understanding CFA as well as structural equation modeling. And one more strong recommendation is there is a book called Multivariate Data Analysis by Hare, Black, Anderson, and Tatham. It's a 4 author book. So you just buy that book. I'm not promoting or I'm not doing any marketing over here in terms of publicizing this particular Hare book. So that will give you a lot of grip in terms of understanding the entire multivariate data analysis techniques that is coming from the literature. And then another standard text which I can recommend here is this is the book. This is the book I'm referring. Uh, where is it here? Yeah. Hare, Block, Bobbin, Anderson, Tatham, Multivariate Data Analysis, 7th edition. Now I think 8th edition is available from Cengage India, not by Pearson. So you can refer this particular in the Hare book. And then another interesting textbook I could recommend here is this one, Using Multivariate Statistics by Tabakine. So this book is widely utilized in most of the US universities, part of their doctoral level coursework is concerned in terms of quantitative research method, or it can be anything. For example, last term I took a, quantitative research method course for part-time as well as full-time scholars of IIM Shillong. There also I have used this particular Hare book for referring the entire data analysis techniques. Up to same mediation moderation only I have covered. So, I mean, definitely you will get a really useful content from this particular textbook. And then another useful source of reference which I can recommend here is you try to watch my own videos. Apart from that, you visit this particular site. This is a place where initially during my PhD days, I've started to learn path analysis because we had a course called Advanced Data Analysis when I did my PhD in Anna University. So that time I was given a seminar topic that is nothing but path analysis. Even that point of time, I didn't have any standard textbook with me because that time the demand for handbook was too huge. Even in Chennai also, I could not get this particular textbook. In those days, I mean, we never used this Amazon, Flipkart and all. But through some other reference from some other place, I could able to source this book. But before getting the handbook also, luckily I could locate this particular link. This link is managed by, this site is managed by one of the psychology professor from East Carolina University. And here you get A to Z data analysis information. For example, starting from simple Pearson correlation analysis to advanced SEM as well as multi-level modeling. For everything, you get data set, you get some PPT content, you get some 2-page handout sort of interpretation material. So everything you can download it from this particular source. I mean, I strongly recommend you to visit and go through this particular site content. Through this source of reference, definitely you will be able to get a lot more insight in terms of understanding everything. For example, if you go to this place, so here you have a section called path analysis and then structural equation modeling. When you go to this structural equation modeling, here you get some PPT and then how you can also run the analysis using AMO software and then some interpretation handout. So all those things are available from this particular site. For more details, you just visit this site. You will get a lot more content. Apart from this, you can also visit some of the other resources. Maybe if time permits, I'll also share some of the other resources where you can also strengthen your knowledge on SIM. And in terms of strengthening your overall knowledge on data analysis, when I was with the University of Hyderabad, we have created a course content for SWAYAM basically under the ARPIT program. So this is the course basically, data analysis for social science teachers. Maybe next round they might be offering this course to the public. Right now this course is not open to the public, but the entire set of material is available from this particular link. If you go to this Google site link, this Google site link is managed by, I hope AICT India is managing this particular Google site page. So if you go to this Google site page, you will be able to get the entire content related to this course, like YouTube videos and then other related references. For example, starting from introduction to data analysis, inferential statistics, t-test, ANOVA, and then logistic regression, multiple regression, and then MANOVA, ANOVA, ANCOVA, then exploratory factor analysis, cluster analysis, MDS, and then from week 11 onwards, you have really advanced content. For example, I did some session related to teaching this structural equation modeling, as well as the confirmatory fact analysis using AMOS, and then structural equation modeling using AMOS, and then mediation analysis, moderation analysis, moderated mediation analysis. So everything is coming from myself. So you can go through this week 11, week 12, week 14, and then week 15, week 16 content to get more insightful information on some of the advanced topics. So this source is again another good source of reference I can recommend here in terms of understanding the multivariate data analysis techniques. Unless you have some grip on multivariate data analysis techniques, I mean, it's really difficult to understand the paper content, research paper content that is coming from some other top tier journals. Unless you have some grip on multivariate data analysis techniques, I don't think so. You will be able to apply those techniques in terms of bringing novelty to your data analysis. Rigor to your data analysis, or in general to your method section of your manuscript or maybe thesis. And the maximum I could see, I have a habit of referring some of the recently submitted theses to some of the South Indian universities, especially for Tamil Nadu based universities. And even now I could see ANOVA, chi-square test, maximum they are using multiple regression. Beyond that, they are not going. I'm not saying that you should use a really sophisticated technique in your thesis. I'm not trying to say that. For example, if your research is purely conducted on the basis of some experiment, the maximum possible technique which one can employ is MANOVA. MANOVA or ANOVA or ANOVA family of technique. But when you're testing some regression sort of relationship, that is, when you have some relational hypothesis, there are two types of hypothesis which can be tested. I'm not talking about null and alternate hypothesis. I'm talking about relational type of hypothesis or correlational type of hypothesis, and then testing the mean differences sort of hypothesis. So whenever we have relational type of hypothesis, there you can employ regression based techniques. There you can also go beyond multiple linear regression in terms of testing the hypothesis in your theoretical model. So for that, yes, you need to have some holistic understanding in terms of understanding the application of applying certain techniques that is coming from multivariate umbrella, as well as you need to understand the theory development part, as well as you need to understand the research paper content. Basically, before you start doing anything, you just go through the literature evidences, especially those the papers coming from top tier journals. And again, my recommendation here is, I'm not saying this, some of the scholars, those who have completed their PhD from abroad universities, they used to say that you try to refer top 10 or top 15 journal references, don't go anything beyond top 10 or maybe top 15 references. So this is a recommendation given by most of the scholars coming from top tier universities. And yeah, now let me begin my session, structural equation modeling. So the plan is, I think up to 11:30 we have the first session. Then after that we have 30 minutes or 15 minutes break. Any idea? I think 30 minutes break, right?
Yes, sir. 30 minutes.
Okay. Then after that we are going to start our session from 12 o'clock. 12 to 1:30 is our session. So my plan for the rest of the duration is, first, I'll cover the theoretical aspects of understanding structural equation modeling. I may be consuming maximum 45 minutes or 50 minutes or even 1 hour time in terms of covering this particular content. Then after that, I'll show you how to run the analysis using RStudio software using syntax. Then I'll show you or replicate the same analysis using JAS software where you can utilize some menu-driven options in terms of running CFA. And of course, we'll be using little bit of coding in JAS in terms of running SIM. But in the recent version of the Zamovi, they have incorporated a library where you can do the SIM analysis using live, menu-driven options. That is possible. I'm in the process of creating videos for Zamovi software also. Maybe by this weekend, I'll be able to upload the videos in my YouTube channel. For more details, you wait for some more time. Fine. So some history about CB-SEM, that is covariance-based SEM. You have another, type of SEM that is also available in the literature called PLS SEM, that is partial least square SEM, where people use smart PLS software, or even you can run the same analysis using R software. That is also possible. But what we are going to discuss today is CB-SEM, that is covariance-based SEM. So this approach was initially proposed by a person named Sewell Wright, is a genetist basically. And in 1918 itself, he has proposed a method. He has proposed a method called path analytic approach. And later in 1960s and 70s, people like Joe Skagg and all, they just brought the measurement component and then integrated with the path analysis framework. And then they have given a new label called structural equation modeling. So before I start, before I start giving the explanation to understand path analysis and then CFA and SIM, let me give you some overview about understanding regression and then exploratory factor analysis, and then we'll move on to path analysis and then SIM. Because SIM is nothing but in simple sense. If you want me to define what is SIM, SIM is nothing but it is an integrated version of your multiple linear regression model and then exploratory factor analysis. No, Vishal sir, here my objective is running CB-SIM. I don't think so within this short span of time, I'll be able to run PLS-SIM. For more details, there are some literature available in the journals as well as academic literature. You can go through them. And again, one more suggestion is if you're coming from OB, HR, core psychology domain, don't try to use PLS-SIM. Always better to use CB-SIM, because there are some objections, there are some questions raised by the psychologists, I mean psychology researchers as well as some of the psychology top journals editors. So they actually deny the papers that is coming on the basis of PLS-SIM. They never treat PLS-SIM as a SIM basically. That's what people are saying. You can't find not even single reference from Academy of Management Journal as well as Journal of Applied Psychology using PLS-SIM, but you can find plenty of evidences from Journal of Applied Psychology as well as Academy of Management Journal using even simple regression or multiple regression or using the CB-based SIM. That's the reason I'm also recommending here CB-SIM. I may be more biased towards CB-SIM since I'm coming from OB and HR domain. Don't mistake me, but this is the truth. In core psychology literature. Fine. Now try to understand what is regression. So in regression, what we are trying to do is, in the case of simple regression, we have a equation. The equation is y equal to some constant plus bx plus error. This is what our simple linear regression equation. So here this y is nothing but dependent variable, and then this x is nothing but my independent variable. This e is nothing but my residual or maybe error value, and then this b is nothing but coefficient of this x. Sometimes we use beta and then b to refer the coefficient of x. B is nothing but unstandardized coefficient, beta is nothing but standardized coefficient, and then this alpha is nothing but constant value. This alpha is nothing but constant value. This is what your simple linear regression. So in simple linear regression model, what we are trying to do is, basically we are trying to estimate a slope. Basically we are trying to estimate a linear relationship between this x and then this y. So here in this slope, here we have 0 and you will get some constant value. That constant value is nothing but this particular distance. For example, x is my income and then my y is expenditure. I'm trying to understand the linear relationship between income level of the people and then expenditure level of the people. For example, irrespective of the income level of the people, for example, if they have zero as a income, family income, per month income, what will happen? Still, they need to consume some food. Further, they might be using or they might be spending some money by borrowing some loan or maybe through some other sources. Still, they are making some ideal level of expenditure, right? Irrespective of their income, that will be reflected in your constant. Over and above the variations, whatever may be the variations that is explained by your income variable on your expenditure, that will be captured through this linear slope. Basically, your observations will be plotted over here. Using OLS regression, we try to minimize the residual value or we try to minimize the error value. This is how we run the we run the analysis using OLS logic. In the case of multiple linear regression model, we'll have an equation something similar to this: y equal to some constant plus x1 b1, sorry, y equal to some constant plus b1 x1 plus b2 x2 plus b3 x3 plus dot plus bn xn plus error. This is what our multiple linear regression model. So basically here we have more than one independent variable in our independent variable side, and all of these independent variables are measured using metric data point, and this y is also measured using metric data point. So still you can run the analysis using linear regression models. So this is what multiple linear regression. So for example, from the theoretical model point of view, let us assume that I have x1, x2, and then x3, and then x4. There are four independent variables are available, and then I'm trying to estimate this y. So basically, I have a dependent variable. This y is nothing but dependent variable. This x1 is nothing but my IV1, and then IV2, IV3, IV4. And here I could have hypothesis like this: H1, H2, and then H3, and then H4. Hypothesis 1 is there exists a positive or maybe negative relationship between X1 and Y. And then similarly, there exists a relationship between X2 and Y. So this is a way how we propose the hypothesis whenever we are trying to test this model. For example, if you consider this X1 as a job autonomy, this X2 as a job satisfaction, this X3 as a organizational commitment, this X4 as a supervisor support, this Y as a organizational performance. So here my H1 would be job autonomy is positively related to organizational performance. My H2 would be job satisfaction is positively related to organizational performance. H3 would be organizational commitment is positively related to organizational performance. My hypothesis 4 would be supervisor support is positively related to organizational performance. This is how we make certain hypothesis when you have a theoretical model something similar to this nature. Suppose if I have a theoretical model something similar to this nature, I have x1, x2, x3 related to y1, which in turn resulted in y2. How many regressions you are supposed to use in terms of estimating your coefficients to support or reject your hypothesis 1, and then hypothesis 2, hypothesis 3, and then hypothesis 4? Any idea? Any response from the participant side? How many regressions you are supposed to run here? 4 regressions. Are you sure, ma'am? Bala Aishwarya, ma'am? 2. Yes, Janani, ma'am, you are right. So 2 is the correct response. So basically here you will be having two equations. My y1 equation will be a separate regression, multiple regression, where I'll have y1 as a dv, some constant for my y1 plus b1 x1 plus b2 x2 plus b3 x3 plus error for my y1. This is what my equation 1. This logic is clear? Makes sense? And then my y2 equation will be error for y2 plus b4 y1 plus error for y2. this is my equation 2, this is my equation 1. So these are the two regressions you are supposed to run it here. So the problem here is when you're trying to estimate your hypothesis 1, hypothesis 2, hypothesis 3, hypothesis 4 individually. For example, in terms of testing your H1, H2, H3, you are running your first analysis. The first equation is available here, that is your Y1 equation. And then you are trying to run the second equation, that is your Y2 equation. If you do it individually, what will happen is you may not be able to capture the simultaneous effect of x1, x2, x3 on y1, which in turn what kind of impact y1 is making on y2. This particular impact may not be captured when you split your entire analysis into a two different analysis. Are you getting my point? So here we get into a bias called omitted variable bias. So in order to remove this bias, in order to do some robust analysis, people have suggested certain approaches like path analysis, RSEM, and so on. Now, my question is, when I want to simultaneously test my H1, H2, H3, H4, what is the way out? Can you give some clue? Can you give some explanation? Now I don't want to do two different analysis in terms of testing my H1, H2, H3 as well as H4. Instead, what I'm trying to do is I'm trying to estimate simultaneously estimate the coefficients to test H1, H2, H3, H4 or B1 coefficient, B2, B3, B4. Are there any ways available in the literature in terms of understanding this logic? Any idea? Any idea? Yeah, path analysis is better approach. How do we do it from the equation point of view? Any idea, Janani? You're right. If it is an offline session, I would have offered something to you, but now through online mode, I can't offer anything. I can say only greeting messages, or I can transfer some money through GPay. That's it. At least to buy a coffee or maybe cool drinks. Okay, now you tell me, how do you solve this problem from the equations point of view? Any logic? Any idea? No, first of all, I should thank the entire participant group. These days, I'm refusing to accept some of the invitations to handle certain sessions through online mode, because just for the sake of attendance or maybe just for the sake of certificate, they simply log into the meeting and then they will mute their video and they will give a number of answers why you are not unmuting your video. Then simply they will do their job. But at least here I could see some 10 to 15 faces. So thanks for showing your face, because I mean, unless I see the participants, I'll lose my motivation. So it's, I mean, quite interactive. By looking at your face itself, I can understand, I can sense something, whether you are thinking, whether you are listening, whether you are doing something else. Yeah, any answer, quick answer, Janani? Okay. The logic which was found by Sewell Wright in 1980, I mean, not 80, 18, 1918 was. So here we have two equations, right? In the Y2 equation, what you can do is, you can substitute this Y1 equation, because here we have Y1, right? So if you substitute this Y1 equation into your Y2, our equation will be like this. Constant for Y2 plus beta 4 multiplied with constant for Y1 plus B1 x1 plus B2 x2 plus B3 x3 plus error for Y1, close the parenthesis, and then plus error for Y2. So this is what your single equation, where you can run or where you can estimate each and every coefficient simultaneously. So this logic is known as path analysis logic or path analytic logic. Able to understand? Through matrix algebra logic, you can simultaneously, you will be able to estimate B1, B2, B3, everything simultaneously you can estimate it. That is possible. Mathematically, that is possible. Are you able to understand? So this is how the system is estimating the coefficients, on the basis of path analytic logic. So now what I have concluded here is the simple extension to your multiple linear or maybe your regression analysis is nothing but path analysis. Up to this clear? Okay. Now we'll talk something about factor analysis. So in factor analysis, what exactly we are doing? Any idea? In factor analysis, what we are doing? Any idea? Dimension reduction. Yes, very good, Ashik Ali. Yeah, grouping the data. Very good, very good. So basically, in factor analysis, what we are trying to do is we are trying to deduce the latent construct. Basically, we are trying to arrive the latent construct at the end of the day. We may be having 10 different variables or 20 different variables in our model. I mean, in our data set. With the help of factor analysis, we are trying to reduce the columns. Basically, we are trying to reduce the columns. In turn, we are trying to arrive the latent construct. So this is what we are trying to do in the case of factor analysis. This logic is clear. When you want to group the subjects, there you can use cluster analysis. For grouping the subjects, you can, for example, on the basis of male and female values, I can group this entire participants into two categories. One is male group, female group. This logic is nothing but cluster analysis. Here I have height of the person, weight of the person, and then their age, and then their BMI value, that is body mass index value, and then their UG percentage, PG percentage, and then their 10th mark, plus 2 mark. Now, if I have all those variables, I'll be able to get two different grouping here. Academic qualification related, academic marks related things can be grouped under one particular basket, and then your physical characteristics related components can be grouped under another basket. So I'll be getting two factor solution for this particular data set. Able to understand? This is what we are trying to do in the case of factor analysis. Visually, how your factor analysis model will look like. So for example, I have a construct 1 and then I have a construct 2. Each constructs are measured using three different items. Each constructs are measured using three different items. This is nothing but item 3, item 4, and then item 5. This is nothing but item 1, and then item 2, and then item 3. I hope you have some basic level of understanding in terms of distinguishing reflective measurement as well as formative measurement approach. Any idea? What is reflective measurement and then formative measurement? What is reflective measurement and then formative measurement? Any idea? Any idea? Okay, for more details, you can start your reading from this particular paper. This is also one of the essential reference. So the actual reference is I don't know, my internet is pretty slow today. So the paper title is On the Nature, let me locate it. The citation is Edwards and Bagosi 2000. This is the paper on the nature and direction of relationships between constructs and measures. If you go through this paper, if you start your reading from this paper, you will be able to understand what is reflective measurement and then formative measurement approach. So basically, in reflective measurement approach, a construct is measured or a construct domain is captured with the help of proxy measures or with the help of reflective indicators. For example, my appearance can be explained or maybe expressed with the help of my spectacle and then my hairstyle and then my blazer color, or it can be anything. So these are the few indicators you can use in terms of representing my body posture. Able to understand? This is nothing but reflective measurement approach. So in reflective measurement approach, we use similar kind of items to capture the entire domain of the construct. Whereas in formative measurement approach, for example, my entire body posture is created on the basis of two hands, my head, and then two legs and so on. If you cut my hand, what will happen? My entire body posture will get changed. If you cut my head, what will happen? My entire body posture will get changed. Able to understand? But if I change my this blazer with some other coat, it can be anything, still my body posture will be same, but my appearance may change. Now able to understand the differences between reflective and then formative measurement logic. So basically, according to this paper, so in reflective measurement approach, your construct will look like this. Just look at this picture. Your construct will look like this. So this is the construct. These lambdas are nothing but your loadings basically, and this delta is nothing but your error values. So here you have x1, x2 and x3. These are the three items used to measure this particular construct. Able to understand? So here your construct will be caused by your construct will cause the item. Your items are considered as a manifestations of your construct, and your items will represent the entire construct domain. This is what reflective measurement approach. Whereas in the formative measurement approach, what will happen is, just look at this. This is what your construct. Your construct domain is captured with the help of your three items. Basically, those three items are forming your construct domain. Are you able to understand the differences? So here items are causing the construct, whereas there your construct is causing the item. So in the reflective measurement approach, the item correlation will be really higher. That's the reason we use Cronbach alpha value. When do you get a higher Cronbach alpha value? When you have higher correlation among the items, we tend to get higher correlation value. Sorry, higher Cronbach alpha value. Reason is the entire Cronbach alpha value estimation is done with the help of split-off reliability procedure. In split-off reliability, what will happen is your entire set of items will be split into two baskets, and then system will establish the correlation between basket 1 and basket 2. Likewise, system will do as many as possible iterations. Finally, you take the average of entire split of correlations, you will get some measure, you will get some value. That value is nothing but your Cronbach alpha value. This is how the system is computing or estimating the Cronbach alpha value of your construct. Able to understand? So Cronbach alpha value estimation is highly possible in the case of reflective measurement approach, whereas in the formative measurement approach, this is impossible. Reason is here we sometimes get even nil correlation, sometimes we may get negative loading also. Even item deletion is not possible here, whereas in the reflective measurement approach, item deletion is also possible. For more details, you just start your reading from this paper. And in terms of understanding formative measurement approach also, in my web page, I have given set of references. You please, go through those references. Probably you may get better understanding. And for more details, you can also refer this particular paper, Jarvis et al. Paper, 2003 reference. That is also another standard reference you can refer. And then another reference is, let me show you. You can also refer some of the citations of this particular professor. He has done quite a bit of work, really good amount of research in terms of researching formative construct domain, formative as well as reflective measurement domain. You can also refer this professor citations. See, index construction with formative indicators and alternative to scale development. Uh, this paper alone has obtained 6,019 citations. You can imagine the impact of this particular paper. So he does a lot of research related to this particular logic. Probably you can also go through this paper. Fine. Now, what I'm trying to convey here is, so basically here we are not going to handle anything on formative logic. So here the logic is reflective in nature. So in the case of exploratory factor analysis, what is happening inside in the system is, so each and every items will be correlated with everything. On the basis of the correlation or covariance value, the items will be grouped into certain baskets or maybe certain components. This is what your EFA model. So in the EFA model, let us assume that I'm going to get two-factor solution. So once you get the two-factor solution, next what you can do is you can do the confirmatory factor analysis. So in the confirmatory factor analysis, I'm freezing my model as this is C2, this is C1, and C1 is measured using 3 items, and then C2 is measured using another 3 items. So here I have item 1, and then item 2, and then item 3, and then item 4, and then item 5, and then item 6. Here in CFA, that is under the CB SEM umbrella, CFA is a subfamily of SEM technique basically. So in CFA, what we are trying to do is, we are trying to estimate this lambda values. Lambda is nothing but loadings basically. After taking into account the measurement error, this is E1, this is E2, this is E3, this is E4, and then this is E5, this is E6. So basically, try to understand what is measurement error. According to classical test theory, I think up to 20 pages only I can create it. Let me open one more Jamboard. I'm lucky to have touchscreen based screen, so that's the reason I could able to write many things. I'm bored with taking the entire session through PPT, so that's the reason I'm writing many of the content through board. Sorry, my system is taking some more time. I'll take another 2 minutes and then we'll take the break. So in in CFA, what is happening is we are explicitly taking into account measurement error. So what is measurement error? According to classical test theory, your observed score will have some proportion of true score plus error. Some proportion of true score plus error. And this error can be further classified into two components. One is random sampling error and then systematic error. Fine. This error can be classified into random sampling error and then systematic error. Again, the systematic error can be classified into two types. One is coming from the respondent source. Another one is coming from the administrator source. This administrator source is nothing but the one who is collecting the data. Respondent source is nothing but the one who is giving the responses to the questionnaire. Able to understand, because we are handling the data collection process with the help of questionnaire. No, it's a, after all, perception based measurement only we are trying to use in terms of quantifying any of the construct. So again, this respondent error can be further classified into so many types like extremity bias, acquiescence bias, and then social disability bias. So these are all the certain biases that is coming under respondent side. With respect to administrator side, you have some of the biases like data processing error or maybe interviewer cheating, and then some form of administrative error. So those things will come under this administrative error. So at the end of the day, what will happen is your observed score will contain some proportion of true information about the construct or maybe about the item along with some proportion of error. For example, now let us assume that now the time is 11:40. I'm asking you to, let us assume that I'm running a survey and I'm sharing the link in the chat window and eagerly you are waiting to take a break. Now I'm forcing you to give your responses for the lengthy survey where I kept some 100 plus items in my survey, my key form. Do you think that you will be giving better responses? I don't think so. Are you getting my point? For example, Aarti ma'am, supervisor is also attending this meeting, and I'm just asking her, Madam, can you say something about the relationship between you and your supervisor? She will say, Sir, she is one of the greatest person I ever met in my life, and she is one of the knowledgeable person in my department, and she does good job in terms of guiding the scholars and so on. This is the kind of positive responses I'll get. Let us assume that I have some personal rapport with X person, and I mean, the concerned supervisor is not attending the meeting, and that point of time, I'm asking the same question. She may say, "Sir, she's good, but sometime I do face some issues. I'll be able to get the true impact. I mean, I'll be able to get the true response. Able to understand? So in the previous context, some level of biasness is created, right? That biasness is nothing but error. That error will sometime, I mean, the impact of error. You try to understand the impact of error. That particular error will sometime inflate your beta value or deflate your beta value or inflate your measurement loading or deflate your measurement loading. In turn, you may get into type 1 or type 2 sort of error. So this is how you can understand what is measurement error. Able to understand this logic? Make sense? For example, you had a great fight with your friend in the morning before attending the session. Now I'm asking Vishal to say something about how about your research experience and how about the research culture in your university where you are doing your research. He will say, no, sir, I'm fed up with my life. I'm fed up with everything, sir. This is the kind of response I'll get because something had happened in the recent past, maybe just before the session. Because of that reason, he is giving this kind of answer. So basically, it's a biased response. Why I'm getting biased response? The situation in which where he is staying or maybe living, the present mood condition of the respondent, everything will play a role here. Able to understand my point? So this is nothing but measurement error. So in any of the traditional analytical approaches, we don't have the liberty to explicitly estimate this measurement error. Whereas in CB SIM, we have this additional feature called explicitly you can estimate this measurement error. You can literally quantify what is E1 value, what is E2 value, what is E3 value for each and every item that is available in our questionnaire. Afterwards, you will be able to estimate the loadings. Then afterwards, in your SIM analysis, whatever may be the kind of relationship you have between your independent variable and dependent variable or independent variable and mediator and then mediator and outcome, it can be anything. Those estimates will be bias-free estimates. That's the reason in most of the journals, top tier journals, editors or reviewers used to ask us to apply SIM approach in terms of testing the hypothesis. Now able to understand the difference between your exploratory factor and then confirmatory factor analysis. So how do we estimate this E? Simple logic. 1 minus lambda square. This is a logic how you can estimate the standardized error value. So this 1 minus lambda is nothing but your loadings. You square your loading and then you direct it with 1, you will get some value. Maybe after running the analysis, I'll also show you how those estimates were computed from the system. So this is a way how you can quantify the error. So the advantage of quantifying error in CFA or SIM analysis is you will be able to do the bias-free estimation in terms of estimating your loadings as well as in terms of estimating your regression weights or maybe regression beta values. So that's the reason why we use CB-based SIM in terms of performing any sort of analysis. So the integrated version of this path analysis and then exploratory or confirmatory factor analysis is nothing but SIM. In typical SIM, for the same theoretical model which I have explained a little earlier in terms of understanding path analysis, for example, I have a construct called x1 and then I have another construct called x2, another construct called x3, and then y1 is another construct, y2 is another construct, So here I have the theoretical relationship or regression relationship among x1, x2, x3, y1 and y2. Along with this theoretical relationship, I'll be having items. This is y1 item 1, and then this is for y1 item 2, and then this is the item for y1 item 3. Here I'll be measuring my error also. Error 1, error 2, and then error 3. This is how your entire sim model will be looking. Able to understand this logic? So what I'm trying to do here is in sim analysis, simultaneously I'm trying to test my theoretical relationship among the construct along with the measurement values after taking into account measurement error. That is a unique advantage or unique feature of using sim. Whereas in multiple linear regression, what is happening is we take either the submitted score or maybe average score for each and every construct on the basis of the item loadings. And then what we are trying to do is basically we are trying to run the regression analysis where we'll get only the regression weights. There we are not taking into account the measurement error, or there we are not estimating the loadings for each and every items. Able to understand? So in same approach, this x1, x2, x3 are referred as exogenous construct. This y1 is referred as a endogenous construct for this x1, x2, x3. Again, this y1 will be referred as exogenous construct for this y2, and this y2 will be referred as a endogenous construct. So the simple logic of understanding exogenous, endogenous is very simple. Endogenous means that is dependent variable. Exogenous means that is nothing but independent variable. Logic is clear? Wherever a theoretical relationship arrow is ending, that particular entity is referred as endogenous construct. Wherever the arrow is starting, that particular entity will be referred as exogenous construct. And in same approach, whenever we use multiple items to measure any one of the construct, that particular construct will be referred as latent construct. So the theoretical meaning to understand latent construct is, anything is indirectly observed or indirectly measured, that is nothing but latent construct. Up to this clear? Able to understand? Sorry, I took a lot more time to give your break. It's almost 11:50. Shall we start the session by 12:20 or 12:15? Maybe we'll have 25 minutes break, 5 minutes before. Shall we start the session? So exactly at 12:15, we'll start the session. Fine. If you have any questions after 12:15, you can ask. I'll go to my canteen. I'll have some cup of tea or coffee, and then I'll come back. Yeah.
Okay.
Fine. Yeah. Thank you. Bye bye.
We will start our session by 12.
Sorry.
Yes, 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 I'm there.
Sir, can we start the session, sir?
Yeah, we can. Let me see how many of them are available. 46.
Okay, sir.
So any idea about the just before the break session participant rate?
Sir,
I think I
it
have
was
seen some
above 70,
60.
sir. It was
Above
above
70.
70.
Okay, they'll be joining.
Yes.
Okay, fine, no issues, no problem. Okay. So what we have done so far is I'm just giving the brief explanation to understand the notion of applying SEM in your research. Also, I'm trying to explain I mean, the integrated version of multiple regression as well as EFA, how your SEM model will look like. So that is what I'm trying to explain here. So in general, in research in general, what we are doing is one side we are trying to develop the theory, another side we are trying to test the theory basically. So in most of the cases for theory testing purpose, one can employ this structural equation modeling. So that is also another logic how you can understand the application of SEM in your research. And there are some whole lot of first generation and then second generation techniques are available. For example, in the morning session, we also discussed something on we also discussed about analysis of variance and then multiple regression. These are the two things we have discussed. And the integrated version of this multiple regression and then this factor analysis is nothing but this covariance based SEM. Covariance based SEM and then PLS SEM, both the approaches are coming under coming under second generation technique umbrella. So this is the way how you can understand this. Now you just look at this family tree of understanding SIM as well as path analysis. So this is the kind of explanation I have given just before the break. So basically what I have done here is I just explained what is regression and then how path analysis is created in the literature by substituting certain equations into or a single equation, whatever may be the kind of model you have. Even with the help of SPSS syntax procedure, you can run path analysis. That is very much possible because there also we are going to consider the construct level information, that is either average score or maybe summated score only we will be using in terms of running the path analysis. So if that is the case, even in path analysis also, even in Excel also you can run the path analysis if you know the estimation procedure mathematically. So that is very much possible. Per se, using any of the, whether my voice is audible?
Yes, sir.
We can
Sir,
hear, sir.
Okay, fine. No, somebody has messaged voice is not audible. Maybe you might be having some issue. Please check your internet connection. So, this is the main objective of this session. So, how the same technique is proposed in the literature. So, it's same is nothing but it's an integrated version of your multiple regression and factor analysis. So, this is the way how you can understand the same logic. And in the recent past, they have integrated ANOVA with the SEM approach. I think in 2018 or 19, there is a paper published in Organizational Research Method where even in experimentation context, one can employ SEM by keeping a notion of ANOVA as well as relationship among the latent constructs. That is also possible. That is also available. There is a technique available in the literature called SEM tree. So there what they have done is they just integrated decision tree algorithm along with the structural equation modeling. So this is how the methodologists are developing the particular domain of literature, whether it is related to SEM or whether it is related to regression, it can be anything. This is how the entire literature is, improved by adding some more features into the existing models or maybe existing approaches available in the literature. In econometrics, they use something called simultaneous equation modeling. Again, that simultaneous equation modeling is also similar to SEM only. I mean, similar to path analysis only, because they're not going to handle latent constructs, because everything is directly observed or maybe directly measured. And there also they try to simultaneously estimate the entire parameter values that is coming in their model. That is also possible. In economics papers, you can see some, I mean, you can get some references related to simultaneous equation modeling. But whereas in management and HR or OB or marketing literature, you can get a lot of references related to path analysis as well as SEM. This is a way how you can understand this particular logic. So in simple sense, structural equation modeling is nothing but it's a combination of statistical techniques such as exploratory factor analysis and multiple regression. Sometimes the SEM approach is also referred as causal modeling technique, linear structural relations, causal analysis, simultaneous equation modeling, analysis of covariance structures, path analysis, and confirmatory factor analysis. These are all the different names given in the literature in terms of referring SEM. And the last two, path analysis and confirmatory factor analysis, are like considered as two special cases of structural equation modeling. Now I'll show you some of the examples that is coming from the literature. Already I have given some brief explanation to understand why we are trying to use SEM. One of the great advantage of using CB SEM is we are trying to explicitly capture the measurement error. That is one of the advantage of using SEM, or why we use SEM. Second criteria why most of the people are using SEM is, one side we have the theoretical model, another side we have the data. We are trying to fit this theoretical model with the help of the collected information, and then we are trying to check whether the data is well fitting with the model and so on. Suppose if your data is well fitting with the model, means whatever maybe the expectations you had as far as your theoretical model relationships are concerned, same thing is happening in the given population. That's how you can make the conclusion. So this can be proved by comparing your observed covariance matrices with the estimated covariance matrix. Suppose if there exists a lot of difference between your observed and then estimated covariance matrix, which means that the model is not well fitting with the data. If you don't find a lot of difference between your observed and then estimated covariance matrix, which means that your data is well fitting with the model and so on. That can be tested with the help of chi-square test. Basically, chi-square test is a non-parametric test here that is applied in terms of understanding the differences between two different matrices basically. Now, again, another advantage of using SEM is you can also simultaneously estimate the equations. I mean, whatever may be the relationship available in the model, that can be tested with the help of SEM approach, and which nested model is giving better fit to the data, even that can be tested. And substantive theories can be tested as well as quantified, and the measurement error is explicitly taken into account in the case of SEM. And according to this Julia Pell citation 1998, Julia Pell is one of the computer science researchers from one of the US university, and he has written a book called Causal Inference. You can also just type Causal Inference by Julia Pell. You will get a whole lot of paper and book references related to the citation. So according to this citation, here we make an assumption stating that even in non-experimental condition, one can make causal inference, or one can make causal claim by applying this SEM. That is the reason why in most of the cases people are trying to apply SEM over some of the traditional techniques. So whenever you are trying to establish the causal relationship among the constructs, or whenever you want to make causal claim, you are supposed to fulfill three conditions. So the condition number one is concomitant covariation. Condition number two is temporal precedence. Temporal precedence is nothing but your X should happen before your Y. Concomitant covariation is nothing but there should be some covariation between your two different data points. And then the third principle is alternate explanation. Alternate explanation is nothing but there should not be any omitted variables which will explain your Y. All the possible causes should be controlled in your equation. So these are the three set of principles you need to fulfill. These three set of principles can be well established, well fulfilled in the case of randomized control trials, I mean experimental research. But in non-experimental designs, what we are doing is basically we are trying to collect everything on the basis of their perception based measurement, And here we tend to get some measurement error. Here we may not be able to fulfill all those three causality principles. And based on this Judy Appel 1998 citation, somehow we can make causal claim by applying SEM technique. That is also another advantage, major advantage or utility in terms of using SEM over other techniques. And some of the mediation models, some of the complex models can be tested with the help of SEM. That is also possible. There are certain examples from the literature. Just look at this paper. This paper is coming from Journal of Marketing, and you just tell me how many regressions are required to estimate the entire entire model coefficients. Can somebody tell me the answer? How many latent constructs are available here? Any idea? Let me look at the chat window. How many latent constructs are available here? Any idea? Six latent variables, 1, 2, 3, 4, 5, 6. Okay. And this job performance is a variable, directly measured one. That's the reason why they have used this rectangle, which means that job performance is quantified directly without using any items. They might be having some secondary data in their database in terms of quantifying job performance, the way in which how we quantify family income or maybe organizational performance and so on. Rest of the all other cases, all those constructs were measured using certain items. You could see MS1, MS2, MS3, that is measuring perceived management support for CSR, right? So those constructs are referred as latent construct basically. Okay, now tell me how many regressions we are supposed to run? Any idea? How many regressions we are supposed to run here? 18 regressions. Interesting. 9, 8, 6, 5, 4, 3, 2, 1, 0. Okay. The simple logic to understand this model is how many endogenous constructs are available. Organizational identification is one of the endogenous. Employee customer identification is another endogenous. Customer orientation is another endogenous. Job performance is another endogenous. So totally 4 endogenous constructs are available. So you are supposed to run 4 different regressions. Logic is clear? Fine. But in the case of SEM, we are trying to simultaneously estimate all those path coefficients. That is what we are trying to do it here. I'll show you one more example, great example from Academy of Management Journal. So AMG is considered as one of the top tier journal for management scholars. Just look at this model. Self-regulation of creativity at work, the role of feedback-seeking behavior in creative performance. That's the title of the paper. So here cognitive style is one of the exogenous construct. POS, that is perceived organizational support for creativity, is another exogenous construct. Feedback inquiry is one of the mediator. Feedback monitoring is another mediator. Creative performance is one of the outcome here. And the feedback inquiry, feedback monitoring, creative performances are acting as a endogenous construct here. So totally we are supposed to run 3 regressions here. If you look at this 0.35, if you look at this 0.35, 0.17, 0.21, 0.27, 0.32, 0.20, 0.06, 0.22. These are all nothing but the regression weights or regression coefficients or beta values between your x and y. How do you differentiate between endogenous and exogenous? Yeah, Kranti, endogenous are nothing but dependent variables. Wherever this arrow is ending, that is nothing but dependent variable. So in same approach, we refer those, dependent variables as a endogenous construct. Wherever the regression arrow is starting, that is referred as exogenous construct. Able to understand? That is nothing but independent variable. If you look at the items here, for example, this cognitive style latent construct is measured using C1, C2, C3. The C1, C2, C3 are nothing but item 1, item 2, item 3 to represent, measure this cognitive style latent construct. And here we do get some values, right? This 0.69, 0.75, 0.61 are nothing but the loadings. That is nothing but the lambda values. And then the delta values, that is the errors are represented here, 0.61, 0.41, 0.55 are nothing but the error values. Able to understand? So here we get R square value, we get regression weight along with the significance level, whether that particular path coefficient is significant or not, even that can be tested here. And we are also estimating the factor loadings for each and every item along with the measurement error. That is the unique advantage of using SEM over some of the other traditional approaches like regression or maybe exploratory factor analysis and so on. This logic is clear? This example is perfectly fine, right? In terms of understanding SEM. Look at this example. This paper is coming from Tourism Management 2022 recent paper. Using the health belief model to examine travelers' willingness to vaccinate and the support for vaccination requirements prior to travel. So here you just look at the kind of constructs, endogenous, exogenous constructs available, and then you imagine how many regressions we are supposed to run. 1, 2, 3, 4, 5, 6, close to 6 regressions we are supposed to run, but that can be done simultaneously in the same framework. That is also possible. Look at this paper. Again, this paper is coming from tourism management only. So one side we have place attachment as second order construct. Another advantage of using SEM approach is there are constructs available in the literature that is second order in nature. Second order in the sense, for example, service quality is a second order construct where service quality is measured using 5 dimensions: reliability, empathy, responsiveness, tangibility, and then one more dimension. Anybody is from service quality literature? So these are the 5 dimensions which is capturing the service quality construct. So each and every dimensions were measured using certain items. For example, work engagement, that is measured using 3 dimensions: vigor, absorption, and then dedication. Those 3 dimensions were again captured using some 6 or 5 items. It's a second order construct basically. So whenever I say second order construct, so in the second order construct we have the overall construct here, and that will be captured through some dimensions. This is dimension 1, this is dimension 2, this is dimension 3, and each dimension will be in turn measured by certain items: item 1, item 2, and then item 3, and each and every item will have their own respective errors. This is how your second order model will look like. This logic is clear. This is what second order construct. Whenever we say unidimensional construct, which means that, for example, job satisfaction is measured using 3 items, it's a unidimensional construct. We don't have any intermediary mechanism between our items and then the overall construct. So it's a unidimensional construct. So here I have job satisfaction item 1, job satisfaction item 2, and then job satisfaction item 3. These are the 3 items available in terms of measuring JS, and which will have E1, E2, and then E3 as error. This is unidimensional, this is multidimensional. This logic is clear? Makes sense? Look at one more example, not example, the comparison between multiple linear regression, path analysis, and then confirmatory factor analysis, and then structural equation modeling. So the first model, the left hand side block is MLRM model, that is multiple linear regression model. Second one is path model. The difference between MLRM and path model is in MLRM you can have only one dependent variable, but of course you can handle multiple IVs. Whereas in the path model you can have multiple number of IVs as well as multiple number of DVs, but simultaneously we are trying to capture or trying to test the entire relationship among the entities. That is what we are trying to do in the case of path analysis. Path analysis and the regression results are almost same, except the difference which we will be getting from this intention to behavior, because this coefficient will be impacted by the impact of this attitude, subjective norm, PBC, and intention. After that, what is the impact between intention and behavior? That is what we are trying to estimate. But without the impact of this attitude, subjective norm, PBC, you may get different coefficient here. But after the inclusion of these 3 IVs in your model, you may get different coefficient here. So that's the difference between your path analysis estimate and then your usual regression procedure estimate values. This is nothing but your CFA, that is confirmatory factor analysis, where we are trying to, I mean, in order to establish certain validities, certain types of validities, we are trying to run CFA. And here we basically establish majorly two types of validities. One is convergent validity, second one is discriminant validity. Convergent validity can be established with the help of by checking the factor loading. Each and every factor loading should be significant at some level, maybe 95% confidence limit or 99% confidence limit. And then you need to check the average variance extracted value. That AV value is nothing but you can compute it with the help of the factor loadings. So the AV formula is, I'll also give you some detailed explanation to understand all those components a little later. And then you have one more concept that is construct reliability. Here we compute something called McDonald omega value. That McDonald's omega value is nothing but construct reliability. That is something different from your Cronbach alpha value. In Cronbach alpha value estimation, we are not explicitly taking into account the measurement error, whereas in the construct reliability or composite reliability estimation process, we explicitly take into account the measurement error component. That's the unique advantage of presenting construct reliability value in the case of CFA analysis is concerned. And then we have something called the SEM model. In SEM model, what we are trying to do is we are trying to test the regression relationship between your exogenous and endogenous construct along with the item loadings, along with the errors. So this is the way how you can distinguish SEM from CFA path and then MLRO model. Any questions with respect to this slide? Make sense? Fine. I'll come back to this path analysis little later. Already we have discussed this concept, and I'm just skipping this slide. I'll also anyway share my slide. Probably after some point of time, you can go back and go through the slide content. Applying SEM is a two-step process according to Anderson and Getting 1981 citation is concerned. So first you establish the measurement validity. First you run the CFA analysis. Then after that you try to do the SEM analysis. So this is how we do the structural equation modeling analysis. So that's the reason we say it's a two-step process or two-stage process. Now we'll have some discussion about CFA. The summary of this two slide content is very simple. So in social science or management research, we measure latent construct using proxy measures. Basically, those proxy measures are referred as observed variables or manifest variables or items or questions that is sitting in your questionnaire. Basically, those items or manifest variables will help you to quantify the construct domain. That is what we are trying to do in the case of social science measurement process is concerned. And in the case of exploratory factor analysis, we try to group the items on the basis of the correlation values, whereas there the cross loadings are permitted, whereas in the CFA, cross loadings are not permitted because as per, as per our theory, CFA is a theory driven approach. Basically, here we are trying to confirm the theoretical structure of our latent constructs. Basically, that is what we are trying to do in the case of CFA. Now try to understand something about model identification. Already we had a lengthy discussion about this CTT theory logic. Observed score will have some level of true score along with the error. Already we had a lengthy discussion about this. I'm just skipping this. Now try to understand what is model identification. So this model identification is one of the important concepts you need to understand in SIM. Unless you are able to identify the model, you may not be able to estimate the required parameters. I'll give you some analogical example to understand what is model identification. You need to reach Chennai from Viluppuram. You need at least $200 in your pocket in terms of buying the bus ticket. If you're going by general quota, I don't know the exact price, maybe some 40 rupees or 50 rupees could be the price of the train ticket. If you have 200 rupees, let us assume the bus context, you have 200 rupees and you can buy the ticket, which means that you will be able to estimate the model. Whether you have sufficient information in your hand in terms of estimating the required parameter values. Are you able to understand? Make sense? For example, in our canteen, lemon chaya cost is 25 rupee. If I have only 15 rupees in my pocket, I can buy lemon chaya. If I have only 25 rupees, still I can buy it. That scenario is referred as just identified. I have equivalent amount of information in order to estimate equivalent number of parameters. So available information and the number of parameters to be estimated both are equivalent here. Both are same here. That is just identified. Lemon chaya cost is 25 rupee and I can buy the lemon chaya. I have 50 rupees in my pocket, but lemon chaya cost is only 25 rupee, which means that I have enough information in my hand to buy even two lemon chai also, which means that the available information is greater than the required amount of parameters to be estimated in my model. This scenario is referred as over-identified model. Now I'll give you practical explanation to understand this logic based on this picture. So I have a construct called job satisfaction that is measured using two items. So how do you, compute the sample moments? So this is a formula to compute the sample moments. P into P plus 1 divided by 2. I'll come back to this degrees of freedom formula a little later. Please wait for some time. So here the P is referring the number of items or number of information available in our hand. So here I have two items to measure job satisfaction. Let us assume that in your SIM model or maybe CFA model, you have only one construct that is nothing but job satisfaction. And how many parameters you are going to estimate? So here I need to estimate one of the loading, and here also I need to estimate another loading. Here I need to estimate error value. Here also I need to estimate error value. Are you getting my point? So totally 4 parameters need to be estimated here. But how many information you have? 2 information you have. 2 into 2 plus 1 divided by 2. This is the formula to compute your sample moment value. So 2 into 2 plus 1 divided by how much you are getting? 3 into 2, 6. 6 divided by 2, 3. So basically your number of parameters to be estimated is greater than the available information. Your available information is 3. Your number of parameters to be estimated is 4. So this scenario is referred as just identified model. I have only 20 rupees in my pocket, but lemon chaya cost is 25 rupee. This logic is clear? Able to understand? Now come to the second example, that is second scenario, that is just identified model. So here how many parameters you are supposed to estimate? 3 loadings plus 3 error values. So totally 6 parameters you are supposed to estimate. Here you substitute this 3 into this P into P plus 1 divided by 2 formula. So 3 into 3 plus 1 divided by 2. How much you are getting? 12 divided by 2, 6. So available information is 6 and number of parameters to be estimated is 6. This scenario is referred as just identified model. So I have 25 rupees in my pocket. I can buy 25 rupees worth of lemon chaya from my canteen. So this scenario is referred as just identified model. Able to understand? Make sense? Now come back to this over-identified model. So in the over-identified model scenario, I have 4 information. Here, how many parameters you are supposed to estimate? 4 loadings plus 4 error values. So 8 parameters need to be estimated here. And how many information you have? 4 information. 4 into 4 plus 1 divided by 2. What is the value you are getting? 20 divided by 2, 10. So you have 10 available information, but number of parameters to be estimated is 8. I have 30 rupees in my pocket, but lemon chaya cost is only 25 rupees. So this scenario is referred as over-identified case. So the reason why we are trying to understand just identified scenario and then over-identified and then under-identified scenario is whenever you are trying to apply SIM, before you go to the data collection stage, you try to apply this sample moment formula and then you identify the number of parameters to be estimated and then you match it with the available information. If it is not matching, which means that you may have to increase the number of items to be included in your questionnaire. Through that way, you will be able to estimate your required number of parameters. Otherwise, you may not be able to run the analysis. Able to understand my point? That's the reason in the same literature they say that when you have 50 items, when you have 50 items, for example, 10 different constructs are available. And if you are going to estimate, let us assume that some 30 parameters. So you just do the max, you will be able to understand whether you are getting just identified scenario or over identified scenario or under identified scenario and so on. In simple sense, in same literature, they say that for every latent construct, at least you keep bare minimum 3 items. If you go anything, if you have anything less than 3 items, which means that you may be having some trouble in terms of estimating the required number of parameters. Otherwise, you don't get into any issue. So this is a simple thumb rule I can give you here. Logic is clear. So in same approach, the degrees of freedom can be estimated. In same approach, the degrees of freedom can be estimated with the help of this particular formula, that is P into P plus 1 divided by 2. This P into P plus 1 divided by 2 logic is very simple. This P into P plus 1 divided by 2 minus K is very simple. So up to this we have seen, right? Minus K is nothing but number of parameters to be estimated. For this particular example, the number of parameters to be estimated is 8. Able to understand? The sample moment which we are getting is 10. 10 minus 8, you will get 2. 2 is the degrees of freedom for this particular model. That's the way how the system is computing the degrees of freedom value. Able to understand? Yeah, just identified and over identified models are enough in terms of continuing our analysis. Yes, Ashikali, you are fine. But there are some cases, if you are going to estimate at least 1 or 2 more parameters, that time you may be having some issue if you go with just identified case scenario. Are you getting my logic? Makes sense? Fine. So this is what we have discussed with respect to talking about this convergent validity, discriminant validity. So you can establish convergent validity by checking the factor loading significance. Your factor loading should be significant. And then the second way is you can compute the AVE value. This AVE value is nothing but average variance extracted. This can be computed with the help of this formula. That is sum of lambda square divided by n. Lambda is nothing but loadings. You just take the square of each and every loading and then divided it by number of n. You take the sum before that. Simple average mean computation formula. That's the logic. So with the help of this, you can compute the AV value. According to Hairbook citation, this AV value must be above 0.5. And you can compute the construct reliability value, that is nothing but McDonald's omega value. This can be computed using this formula, sum of lambda whole square divided by sum of lambda whole square plus sum of delta. This delta is nothing but sum of error. So with the help of this formula, you can compute the construct reliability value. I'll also manually show you how to estimate everything after running the analysis. Discriminant validity is another one of the important criteria in SEM. Whether you are going to use regression for testing the theoretical relationship or process macro based approach in terms of testing your mediation and moderation models, it doesn't matter. But before you do anything, you are supposed to establish certain types of validity. One of the important validity is convergent, and then the second important validity is discriminant validity. So in the literature, in most of the cases, people use this Furnell and Laker 1981 criterion. So here we take the square root of AV value, that is average variance extracted value. That particular value is compared with the correlation values. If the square root of AV values are greater than the construct correlation values, means we can say that the discriminant validity of the model is well established. Another way how we can establish the discriminant validity using this Furnell and Laker criterion is you consider the raw AV values and then you take the correlation squares. If the squared correlation values are less than the raw AV values, means still you can fulfill this criteria. In the traditional literature, people have used the MTMM approach. This MTMM approach is nothing but multi-trait, multi-method approach. This is one of the oldest approach where you can also still establish the discriminant validity. That is also another approach. In PLSM approach, they use HTMT approach, heterotrait, monotrait method. in terms of establishing the discriminant validity. There are multiple approaches are available. I don't have enough time to discuss everything. So these are some of the basic relationship we may be handling in the case of SEM. X to Y relationship, that is nothing but direct relationship. Second one is indirect effect. Third one is moderating effect, where the strength of the relationship between X and Y is moderated by M. In the previous case, X and Y relationship is mediated or transmitted through M. Basically, in this case, this M is nothing but mediator. Here this M is a moderator. Basically, to get more details about mediator and moderator, you can watch some of my videos, part of that SWAN course, or you can watch some of my videos from my own YouTube channel, or you can start your reading from Baron and Kenny 1986 paper. From there you can start your reading, and even I have given set of exclusive references to understand mediation and moderation even in my web page. So general guidelines for conducting SEM is, first you review the theory, the relevant theory as well as literature before you develop the theoretical model, and then you specify the model, and then you do this model identification, related analysis, not exactly analysis, manually you can do that before you go for the data collection. Then after that, you select the appropriate measures to quantify your latent construct. In most of the cases, what is happening is people tend to create their own items to measure certain constructs. What will happen is when you compute reliability, or when you do EFA, or when you do CFA, or when you do SIM, I don't think so you will get better results. Reason is, we are not creating homogeneous set of items to capture the construct domain. If you want to create your own questionnaire, follow the skill development process. Otherwise, you try to utilize the standard scales or standard measures that is available in the literature. Are you able to understand what I'm trying to say? For example, today I'm going to use a data set based on one of my past paper. So I'm going to use a data set based on this particular paper. So if you look at this paper, here I do have constructs like work-family balance, life satisfaction, job satisfaction, and then family satisfaction. And if you look at this particular paper, yeah, these are all the constructs I have. Yeah. If you look at the measurement section of this paper, you will be able to understand from where I have borrowed the items to measure my construct. Nothing I have developed. See, job satisfaction is measured using this particular citation. Family satisfaction was measured using this particular Edwards and Rothbard 1999 paper. Life satisfaction is measured using this Diner et al. Scale. It's a 5-item measure basically. This is the way how I have quantified each and every latent constructs which I have used in my theoretical model. Able to understand? Logic is clear. Often people are, having some issue in terms of, and there are some traditional supervisors, they used to say that unless you create your own set of items, unless you create some 10-page worth of questionnaire, I don't see any value in your research. PhD means it's a big work, so you should have lengthy questionnaire in your question. No, that is not the case. Even with the 25 items also, you can complete your questionnaire within a single page of instrument. That is possible. There are papers sitting in even top tier journals. Are you getting my point? With the help of even without collecting data also, you can complete your thesis. Still that is possible. But the value of your thesis output should be measured on the basis of your theoretical contribution. The contribution, what was your contribution with respect to literature as well as with respect to practice work? Whether are we making enough contribution to the existing body of literature over and above what is existing in the current knowledge base? So through this lens only, you should look at the quality or maybe weightage of your thesis work. Nothing to do with analysis. I have seen some theses where they have created or where they have submitted close to 600 pages worth of thesis content, and close to 400 pages are devoted only to run analysis, data analysis. They try to showcase their entire data analysis skill set by, starting from simple frequency analysis, bar chart, bar chart, and then mean some of the descriptive statistics, and then ANOVA. They used to apply entire ANOVA family of technique, and then they will go for regression, and then CFA, and then SIM, and then mediation, moderation. I don't know why they are applying all those techniques. Don't do that. So that's what I'm saying. No, the strength of the thesis should be assessed on the basis of your level of contribution, not on the basis of the pages which you are going to have. I have seen some thesis work submitted in University of South Florida. All those thesis work submitted to University of South Florida are freely available under the open license concept. You can also download and then you can look at the thesis chapter as well as the thesis content. I have seen some thesis work submitted within 49 pages, that too in 2-line spacing, and that too in psychology department for getting PhD degree. So nothing to do with your number of pages, nothing to do with your number of items that is available in your questionnaire, nothing to do with your questionnaire length. Make sense? Fine. Once you are done with this 4 steps, then you go to the field. Fifth stage is going to the field and then collect the data. You do the data entry. If you want, you can run the exploratory factor analysis. If you have some multidimensional construct, it's a good idea to perform exploratory factor analysis. Otherwise, straight away, you can go and do the confirmatory factor analysis. So here, one of the important factors is you need to provide some valid evidences. And for young scholars, please pay some close attention to common method bias literature. Janani, is the moderating effect is also calculated with the regression value? Yes, possible. In regression approach, you can do the moderation, that is possible. And you do the validity check, and then saying something about the common method bias is really essential in the recent past. Then you finally obtain the measurement model fit. Here we use certain model fit values in terms of assessing the fit of the model. Then after that, you go and do the structural model. You can also include the control variables. You can do mediation or moderation. Finally, you report your findings and then you tell your story. So there's a way how you can do the same analysis. And in terms of talking about your model fit values, there are some goodness of fit indices can be utilized by the researchers. Here we use GFA value. GFA is nothing but goodness of fit index. AGFA is nothing but adjusted goodness of fit index. NFA is nothing but normed fit index. CFA is nothing but comparative fit index. For everything, there are some formulas available. RMSE is nothing but root mean square error of approximation. With respect to goodness of fit values are concerned, that should be greater than 0.9. With respect to RMSA value is concerned, it should be less than 0.08 according to her book citation. Again, how do we estimate all those values? System will provide the values, but again, there are some formulas available. For example, if you want to estimate this RMSA value, the formula is very simple. I think square root of chi-square minus degrees of freedom divided by square root of degrees of freedom multiplied with n minus 1. That's the formula to compute RMSA value. So manually also you can estimate the RMSA value, but in most of the cases, softwares will give you those outputs. But only thing is you need to understand the interpretation of those values. For model comparison purpose, one can use AAC, BAC, and then CFA values. That is also possible. So in conclusion, SEM is used to confirm the theoretical structure. For theory testing purpose, one can use this. Arjun sir, could you please specify the appropriate sample size for multivariate analysis? Are there any citation? For each and every analytical approach, you have some respective sample size requirement. For example, in regression, they say that for each predictor variable, at least you should have 20 or 30 responses. If you have 4 independent variables, 4 into 20, so that is a bare minimum sample size required to run multiple regression. In SEM, the simple thumb rule is, for example, I have 40 questions in my questionnaire, excluding the demographics. 40 multiplied with 5, that is a bare minimum sample size. 40 into 10, that is sufficient sample size, which means that for each question, you should have at least 10 responses. Logic is clear, Arjun? And here free of measurement error because it has been estimated and removed, leaving only common variance. And very complex and multi-dimensional structures can be measured with the help of SEM. And the SEM programs allow calculation of modification indices which help researchers to fit the model to the data. We must also point out that SEM is based on covariances that are not stable when estimated from some smaller sample size. And again, there are some literature which says that even if you have really larger sample size, that will also deteriorate the power of your sample, power of your statistical test. That is also possible. So these are the few suggestions given in the literature. There are different softwares are available. For today's session, I'm going to use this R11 package. In RStudio, I'm going to use 11 package. There is a package called 11 package. With the help of that only, I'm going to do the analysis. There are other packages also available. Sim2 is another package. OpenMX is another package. In SPSS, Amos is one of the popular software in India. M Plus is again another very popular software across the globe. Equus is another coding based software. Literally is also another coding based software. And then SAS, Stata, Zamovi, JASP, Blue Sky Statistics, everywhere you can run the SEM analysis. Even there are other softwares also available in the literature. So if you are completely new to SEM, you start your reading from this book, Hair book. First, you start your reading from Hair book, last 2 or 3 chapters, and then you can move towards referring this particular exclusive book on structural equation modeling with Amos basic concepts, application, and programming. This book will give you a lot of clarity. Then after, you can also refer this Rexilin book. If you want to understand the mathematics behind SEM approach, you can refer structural equation modeling by David Kaplan book. That will give you the mathematics behind SEM. Even in Excel itself, you can do the SEM analysis. Only thing is you need to understand how to do the estimation using MLE technique. You need to have some background understanding on maximum likelihood estimation, and then you need to have certain knowledge on some level of understanding with respect to matrix multiplication, matrix transpose, and then how to, computing the inverse matrix and so on. So if you have matrix algebra logic, linear algebra, bit of linear algebra along with matrix algebra, then you can do the entire multivariate statistics using Excel itself. That is possible. Fine. Now, quickly, I'll show you how to do the analysis and then what are the things you are supposed to report it in your, result section. This is what I'm going to do now. So for this analysis purpose, I'm going to use a data set based on this paper. Already I have given some explanation related to this paper. So if you look at this paper, here I have some of the latent constructs. So for this analysis purpose, I'm going to consider this 4 latent construct: job satisfaction, family satisfaction, work family balance, and then life satisfaction. This paper is based on 2 different samples basically. One was collected from India, another one was collected from USA. From USA, I have close to 294 data points. From India, I have 492 data points. Using this 294 data points only, now I'm going to do the analysis. For this SEM analysis, the model which I'm going to test is, let me draw the model also in the XAMPP board. So this is a model I'm going to test. So I have a construct called work family balance, job satisfaction, family satisfaction, life satisfaction. So these are all the relationships. I'm going to test it here. Fine, able to understand? So here totally 1, 2, 3, 4, 6 relationships are available. So basically I'm going to estimate 6 regression path coefficients. And then each and every constructs were measured their respective items. Work family balance and life satisfaction was measured using 5 items each. And then JS and FS was measured using 3 items each. For this model, the corresponding CFA diagram will look like this: work family balance, JS, FS, LS, each and everything were measured using few items, and then this will have the covariances among each and every constructs. So totally how many covariances we have? Totally we have 6 covariances here. And then how many factor loadings we are going to estimate? Here I have 5 items, here also 5 items. In rest of the 2 cases, I have 2 items. So totally 16 loadings I'm going to estimate, 6 covariances I'm going to estimate, and then 16 error values I'm going to estimate. Totally how much you are getting? 38 is the value. Able to understand? Now you can estimate that sample moment value also, model identification logic also you can apply. How many items I have? 16 items. 16 into 16 plus 1 divided by 2. Can somebody tell me the quick answer for this? 16 into 17 divided by 2. How much we are getting? Any quick answer?
Repeat once.
130? 36. So basically our sample moment is 136. How many parameters you're going to estimate? 38 parameters, which means that we have really good amount of information, sample moments in our hand in terms of estimating those, required number of parameters. So degrees of freedom in SEM is P into P plus 1 divided by 2 minus K. This minus K is nothing but number of parameters to be estimated. So here the degrees of freedom value is 16 into 16 plus 1 divided by 2 minus 38. So if you solve this, you will get 136 minus 38. I think 98 is the answer. This is the degrees of freedom value. You will get it after running the CFA analysis. Are you getting my point? So this is the CFA model I'm going to run now, and there is the same model. I'm going to test it by running this analysis. And if you need some details about this Lavan package, you just type Lavan package in Google. You will get the Lavan project site. So this site will give you a lot of information about the tutorials, resources, and then how you can also create the syntax in our environment in terms of running the same analysis. This is very simple only. And for this, of course, you need to have some basic level of understanding in terms of using base R or maybe RStudio, but don't bother about that. I mean, easily you can pick up the skill set once you start doing some analysis using RStudio. Same analysis can be done even Python also. In 2020, there was a package launched in the literature called SemPy, I think. Using SemPy package, even in Python also, you can do the CFA as well as same path analysis. That is also possible. Fine. Now what I'm going to do is I need to install the Lavan package. Whatever may be the kind of analysis you're going to do in R, first you need to load that particular package, associated package in your current R environment. So already I have installed this Lavan package. Simply let me activate this library, and I'm going to import the data set that is coming from this particular source. So my data is available in CSV file format. This is the data set I'm going to import it to my R environment. There are multiple ways are available in terms of importing the data set into R. You can set the working directory and then simply you call the data file name that will be integrated in your current R environment. That is one way. Second way is this is the data I'm going to import. Second way is you go to file and then click import data set. Whether you're going to import CSV file format or text file format or base R file format or Excel file format or SPSS or SAS or Strata format, anything you can use it. For example, here I'm going to import this read R file format, that is CSV file format. So you just copy paste this particular file path location over there. You replace this backslashes with the forward slashes with the backslashes. Otherwise you will get error. And to import this data, you need a read R package. So let me activate this read R. Now let me download this data. So here I'm defining this data set as a USA data. Run it. This is the data I'm going to use here. So my job satisfaction construct is measured using 3 items. Those item level information is available here. Family satisfaction is measured using 3 items. Even those item level information is available here. And then life satisfaction is measured using another 5 items. Similarly, work family balance is measured using 5 items. So all those item level information is available in my data set. Now, how do we create the CFA model? This is the syntax associated with creating the CFA model. Before that, let me give you some explanation to understand the syntax logic. For example, if you go to this Lavan project site, so here they are giving some explanation to understand this operator. If you use equal with the tilde, what we are trying to do is we are trying to define our latent variable. We are trying to define our latent variable with respect to those items. There we need to use this equal with the tilde. This tilde symbol will be available just above your tab key in your keyboard. Fine. When you press shift and then just above the tab key button, you will get this tilde symbol. For regression relationship, don't keep equal, but just keep the tilde. When you want to covary some of the error values, there you can use double tilde. When you want to constrain certain relationship, like 1 or keeping 0, there you can use this tilde and then you can fix the parameter value. These are the few syntax you need to understand here. For example, I'll create the entire syntax manually with respect to running this CFA analysis. I know that in work family balance, I have how many items? 5 items, in JS 3 items, FS 3 items, and then life satisfaction 3 items. The syntax will look like this. So first, let me create the syntax for work family balance. I'm defining work family balance as WFBAL equal tilde work family balance item 1 plus work family balance item 2 plus work family balance item 3 plus similarly up to work family balance item 4 plus work family balance item 5. This is the first line of syntax. And then job satisfaction is measured using equal to tilde JS1 plus JS2 plus JS3. Family satisfaction is measured using equal to tilde FS1 plus FS2 plus FS3. And then life satisfaction is measured using equal to tilde LS1 plus LS2 plus LS3 plus LS4 plus LS5. You just close the syntax with the single quote or double quote. Also, you start with single quote or double quote. This is the syntax you need to create in R in terms of constructing the CFA model, CFA diagram in your software. Same thing only here I have done, and I'm labeling this particular analysis as CFA analysis. Now able to understand? See, here job satisfaction is measured using JS1, JS2, JS3. Family satisfaction is defined using FS1, FS2, FS3. Similarly for rest of the two constructs. Able to understand? Now let me run the syntax. And then you try to fit the model. After activating the Lavan package, the CFA is the command, that is confirmatory factor analysis command associated with this package, Lavan package. Data is USA data. When I run the syntax, I'll be able to get the outputs here. Look at the output. Already we have estimated the degrees of freedom, right? How much we got from the manual calculation? We got 98, right? This chi-square value is nothing but this chi-square value, p value, will tells us something about the differences between observed covariance matrix and estimated covariance matrix. Basically, according to this p value, only in some case we expect not significant p value. If the p value is significant, which means that there exists a difference between our observed covariance matrix and estimated covariance matrix. But again, there are some questions raised in the literature in terms of depending on the chi-square based model evaluation. That's the reason why we are also referring GFI, CFI, and other sort of values here. Clear? Now, to get the regression weights and then factor loadings, you can use this summary fit syntax. You will be able to get them. Just look at this result. For job satisfaction, these are the 3 items I have used. The standardized loadings are available here. This 0.877, 0.855 are nothing but the factor loadings. Factor loading is nothing but the regression weight that is reflecting the relationship between your item and then your latent construct. Make sense? Able to understand? Fine. All of my loadings are statistically significant. That much only I can say here. Now look at these covariances. These covariances are nothing but the correlation between the constructs. That is also significant. Everywhere I'm getting p-value less than 0.05. Somebody's mic is on. Sheila ma'am, can you mute? Yeah. For example, if you look at this variances values, so here we get some standard all, right? This is nothing but the standardized error values. For example, if you want to compute this 0.230, you take the loading value for job satisfaction, 0.877. You compute them 0.877 multiplied with, I'm just estimating the loadings, I mean square. This is 0.769. 1 minus 0.769, you will get 0.231. This is what your error value. This is how the system is also calculating the, I mean estimating the error value and SEM. Able to understand? Now we look at the fit values. So I'm asking the system to produce certain fit values. GFA values above 0.9, NFA values above 0.9, CFA values above 0.9, TLA is above 0.9, RMSA is less than 0.08. So as far as the model fit values are concerned, I could fulfill the condition. So there are no issues here. Now quickly I'll show you how to estimate the AV value and then construct reliability value based on this results. For that, I'm going to use one more syntax. I'll use this inspect command. So here I'll be able to get the loadings. These are all my loadings. Let me copy this loadings. I'll open an Excel file. I'll paste it here. This will be in text format. Now I'll go to data menu, convert this text into columns. Now I'll copy paste this loadings over here. This over here, and then this over here. So this is nothing but my item loadings. I don't need this 3 column. Now I need to compute the AV values. How do we estimate the AV value? The formula is sum of lambda square divided by n. So now let me compute the loadings square value equal to this value cap 2. I'll be able to get the squared loadings. Now I'll estimate the AV value. AV formula is you just take the mean for the squared loadings. Formula is sum of lambda square divided by n. N is nothing but number of items. So here equal to, there is an average function available in Excel. Use the average function. Select this 3. This is the AV value for job satisfaction. I'll copy paste this over here. This is the AV value for family satisfaction. I'll also copy paste the same thing over here. I need to expand, include this 2 more squared loadings. This is the AV value for work family balance. And then this is the AV value for life satisfaction. Logic is clear? Now I need to compute the construct reliability. So let me get the error values. So again, error values are nothing but 1 minus lambda square. Already we have the lambda square value here equal to 1 minus this lambda square. So I'll be able to get the error. So these error values are exactly similar to the error values which we have obtained here, 0.230, 0.269, 0.395, 0.129 and so on. Logic is clear? Now let me compute the sum of loading square equal to sum of this loadings, close the bracket, include the cap and 2. This is nothing but sum of loading square for job satisfaction. This is a sum of loading square for family satisfaction. This is a sum of loading square for work family balance. This is the sum of loading square for life satisfaction. Now let me compute the sum of error values equal to sum of this 3, sum of this 3, sum of this 5 errors, and then sum of this 5 errors. So now I got the sum of error values. Now let me compute the construct reliability values equal to, formula is sum of loading whole square divided by sum of loading whole square plus sum of error. Sum of loading whole square is here divided by sum of loading whole square is here plus sum of error is here. This is your construct reliability value for this work family balance and life satisfaction. Now we have estimated the AV value and then CR value. For reporting purpose, you are supposed to show only this AV value and then CR values in the paper along with this loading and then the LP value. That's it. Now let me show you how to perform discriminant validity test using Funnel and Laker criterion. Let me open another sheet. So here we have a table called psi table. This is nothing but the correlation table among the constructs that is available in our CFA model. Let me copy this. I'll paste it here. This will be in text format. Let me convert this text into columns. So this is what my job satisfaction and job satisfaction correlation, job satisfaction and family satisfaction correlation. This is how you have, right? Now here I'll compute the square root of AV. My square root of AV for job satisfaction is available in this sheet. So here is my job satisfaction square root of AV. This is what my square root of AV for JS. Now let me compute the square root of AV for family satisfaction. Family satisfaction AV is available here. Equal to square root of AV for work family balance. Equal to square root of AV for life satisfaction. You can bold this font also. So this bold fonts are nothing but the square root of AV values. And then now you compare the square root of AVs with the construct correlations. Everything is less than the square root of AVs. Now the conclusion is the discriminant validity of the model is well established here. This is the way how we present this discriminant validity table. Now I'll show you practically the way in which how we have presented our discriminant validity table and then convergent validity effect values in one of our recent paper. Let me open this paper. This paper is purely based on one of the MBA project work. Basically, we could able to publish this paper in I think ABDCC category with the Scopus indexed. My role is only taking care of the data analysis part. Apart from that, nothing I have done part of this paper. So this is a model we have tested. We have 3 X's, 1 mediator, and then 1 outcome. And if you look at the results section of this paper, so this is the descriptive table. By default, you are supposed to present your construct mean, standard deviation, along with the construct correlation values. And then here we have presented the factor loadings, Cronbach alpha, construct reliability, and then AV value for each and every constructs available in our model. Here we have presented the mediation effect values, and discriminant validity was discussed in the result section of the paper without explicitly presenting the constant correlation and discriminant validity values. But I'll show you one more paper where I have, this is my own paper before my thesis work, just for publication sake, I did this paper. Here, if you look at the model, this is a model I have tested, and look at the discriminant validity table. See, this is what the funnel and Necker discriminant validity table. This diagonal values are nothing but square root of AVE. This is all nothing but the correlation values. This is how you can present your convergent and discriminant validity evidences in your paper. Fine. And your CFA result, I mean, model fit values need to be described or discussed in the result section of your paper. Now, now we are satisfied with the CFA. We have computed the factor loading, AVE, CR, everything. And even we are also done with one more component, important component, that is nothing but discriminant validity. So we are satisfied with everything. Now what we can do is we can run the same analysis. So if you look at the same syntax, so here what I'm trying to do is I'm trying to add my regression equations along with the CFA syntax. That is what I'm trying to do here. For example, for this same model, how my regression, I mean, syntax will look like. Here my regression, sorry, this is a model, right? So here my regression equations will be, I'll start from JS tilde work family balance. This is one of the regression equation. FS tilde JS plus work family balance. LS tilde JS plus FS plus work family balance. These are the three syntax I have added along with my CFA model. Able to understand? Now run this SEM and then you feed this SEM model. You will be able to get the entire result. Now, if you look at the result section of this model, see, here we get degrees of freedom, because here also we have 6 regression equation. So degrees of freedom is same across CFA as well as same model. This is nothing but your item level loading, and then the significant values. This is nothing but your regression relationship between your exogenous and endogenous. So the beta value is 0.377, that is significant. Work family balance to job satisfaction, that is significant. Here work family balance on family satisfaction, that is also significant. Here job satisfaction and family satisfaction, that is also significant. Work family balance on life satisfaction, that is also significant. Job satisfaction on life satisfaction, that is also significant. Family satisfaction on life satisfaction, that is also significant. This is a way how you can conclude this particular result. So almost all of my hypotheses were supported at 99% confidence limit, except this is also significant at 95% confidence limit. Now look at the fit values here. As far as the fit values are concerned, just look at here. I'm getting almost a similar result to my CFA. So I'm pretty much, pretty happy about the fit values, whatever may be the fit values I have obtained here. So GFA, NFA, CFA, TLA are above 0.9, RMSA is also above 0.6. Now you can also create the plot, SEM plot, by using this package called SEM plot package. Now let me show you the SEM diagram for this particular analysis. Just wait for a few seconds. Still it is running. Yeah, this is what your SEM model basically. So here I have work family balance as one of the exogenous construct. Their loadings are represented here. Their error values also represented here. And then work family balance on JS, work family balance on LS, work family balance on FS, JS and FS, JS and LS, and then FS and LS. All those path coefficients, factor loadings, error values, everything is available here. This is how we run structural equation modeling using Lavan package. The same thing can be done with the help of JAS software also. Due to lack of time, I'm not showing that, but you can visit my YouTube channel. There you have the video. Let me show you CFA and SEM using JSP. So this is the lengthy video where I have integrated CFA as well as SEM, including the computation. I mean calculation of your AV value, CR value, even those things also included in this video. For more details, here also I have used the same data set. You just visit this video and then you will be able to get more details about how you can also run the analysis using JASP. Similarly, you can also do the same thing using Amos software. If you have the access to Amos software, there is a video available here. See, confirmatory factor analysis using Amos and then SEM using Amos. Again, this is also my own video. Using R also, I have created a video and then that is also available in my YouTube channel. You visit this page, confirmatory factor analysis using RStudio and SEM using RStudio. There also I have used the same model. There also I have tested the same hypothesis. So whether you use Lavan package or JASP or Amos or R, it doesn't matter. Estimation, I mean, whatever maybe the coefficients you're going to get, everything will be same across the softwares. People sometimes tend to say that I'm using R software for running the analysis. So what? Whether I'm using red color shirt or blue color shirt, it doesn't matter to me. Today I'm using Lavan, tomorrow I'll use JASP, day after tomorrow I may be using Amos. It depends. There are some advantages and disadvantages over different softwares. That's it. Whether unless you change the estimation technique, the results will be same across the entire platform. So with that, I'm closing my session presentation. And finally, I would like to make one more disclaimer statement. I mean, two statements here. One of the key disclaimer statement is you consider this session as a eye-opening session in terms of learning path analysis as well as CFA and SEM on your own. Maybe in the near future, probably you can also attend some of the other workshops related to this nature in terms of strengthening your knowledge on SEM and CFA. And in India, another disclaimer statement is in India, they think that if I know the analysis using some software, I have better mastery over that particular statistical approach. No, that is not the case. That is not the case. Up to scholar level, that is fine. But when you're going to do the teaching, especially at PhD level, people may be asking, how do we estimate beta value? Unless you know the mathematics behind estimating the beta value, you may not be in the position to say that software is giving beta value, this is how you can infer the result. If I say that, I don't think so I'll get good respect from my participants, course participants. So in order to strengthen your mathematics, you refer some of the textbooks. Through that way only you can strengthen your theoretical aspect of understanding any of the data analysis approach. Don't stop your learning by learning some of the software based programming or maybe software based analysis. Beyond that, you may have to do some more thing. So that's the second disclaimer statement I'm giving here. Third point is my own personal experience. I did my UG in one of the self-finance college, PG in again one of the Anna University affiliated college, and then PhD in Anna University, one of the state university. And with the help of publication, with the help of strengthening your knowledge on various things, subjects as well as research work, you can aim better job. If you get better job, your standard of family income will be raised. Your next generation education quality will be improved so that you can also develop your family, as well as once everyone is going to get better job, better placement, better family income, the entire community or entire society will be improved. So with that, with this note, I'm concluding everything. So if you have any questions, feel free to approach me through my WhatsApp. Don't try to make a phone call, or you can approach me through email. My email is murugan@iamshillong.ac.in. My number is 9791374600. And close to 5 to 6 years, I was with, sorry, 5 years I was with the self-finance college. I started my lecturing job with one of the self-finance arts and science college, and then I moved to one of the self-finance engineering college, and then I got luckily contractual position at NIT Trichy. There I worked for 3 years. Then after that I got one more position in one of the industry. Then after that I got permanent job from University of Hyderabad. I took 1 year lean, and then I thought of exploring what is there in IIM Shillong. That's the reason now I'm sitting at IIM Shillong. So this is how I have developed my career. So please read as many as possible literature papers are concerned. Through that way, you can sharpen your knowledge and research as well as your teaching. Definitely, by doing a better research, you can do a better justice to your teaching process, whether it is PG level teaching or PhD level teaching. With this, I'm saying bye-bye to everyone. 2 o'clock, I have another commitment. So between this 25 minutes, I have to complete my lunch. So yeah, if you have any questions, I mean, feel free to share it through WhatsApp, or maybe feel free to share it through email. Thanks to Velmurugan sir, and thanks to organizing committee in terms of managing this show in a better manner without any hurdles. I mean, after a long time, I'm feeling that I took some offline session, even though the entire session was happened through online platform. But I feel that, I mean, this crowd is really better crowd. Reason is keep on they're also interacting, keep on they're also responding. Even by seeing your face also, I could sense something. So thanks for your wonderful and lovely participation. Thank you so much. Yeah,
So,
shall I
Murugan,
leave?
I know that you are in a hurry. Can I ask one quick question? I am Mallikarjunappa from Central University of Kerala. Last time when I saw you, you were in Hyderabad.
Okay, fine, sir. Fine,
I
professor.
know.
Please, sir.
Yeah.
Please, sir.
One quick question. I have several questions. Maybe some other occasion. You know,
Yeah,
this
fine.
when we are using chi-square to test whether the data fits the model that we have assumed.
Yeah,
Invariably, in most of the cases, I have seen the chi-square value is too high, and therefore
yes,
we reject that the model is not a good fit. But then there is a
yes,
wire medium suggested chi-square divided by degrees of freedom.
yes,
Only
yes,
in some I have seen this type of a policy where chi-square divided by degrees of freedom is taken. But when the
yeah,
model is tested elsewhere, goodness of fit is tested elsewhere, it is just the chi-square. And then the
yeah.
p-value, then we compare
Yeah.
the table value and then these things. But why this type of a deviation in SEM?
Sir, there are two answers for your question. With respect to the first part of your question, chi-square value is highly inflated due to your sample size. If you have larger sample size, obviously you are, sorry, if you have more number of parameters to be estimated, or if you have more information in your hand as well as along with larger sample size, obviously your chi-square value will be estimated. If you go and look at the, testing the differences using chi-square test formula, you will be able to understand this logic. That's the reason in the literature they were also suggesting that either we can follow chi-square ratio test, it should be less than 3, but I won't recommend you to follow even chi-square ratio test or maybe chi-square value. There are better metrics are available in the literature, like following GFA value or CFA value, NFA value, and then RMSA value. And even there are some questions about GFA value also. And people again, they're saying that if you have larger sample size, again, that will also deflate your GFA value. Suppose if some of your path relationships are producing non-significant result, again, your GFA value of the model will go down if you still keep those paths in your model. That's the reason recently in the 8th edition of Handbook, there was a metric proposed by comparing your CFA result as well as SEM result, even that can be utilized. For your quick reference, I'll also show you one more reference, Professor. I don't know whether I'll be able to locate that reference properly. Let me do some trial and error basis location. This paper is from Journal of Academy of Marketing Science, and I completely forgot the citation actually. Recent paper. There, here they are questioning some of the traditional measures, and then they are proposing some of the new metrics in terms of checking the fit values. Let me try to locate it. Yeah, this is the paper, sir. Flexible cutoff values for fit indices in the evaluation of structural equation models. You please go through this paper, and you also have a site. Yeah, I'll share the paper reference. I mean the link of the reference, professor, the chat window.
That's the link you.
So here they are questioning chi-square value as well as GFA value, and here you have some web-based tutorial where you can determine your expected fit value for your model by feeding the number of observation available in your model, theoretical model, and then number of samples you have in your model. See, these are all the input values you have to give, and then it will provide the expected fit values. Here they are not asking us to report GFA values. Reporting SRMR, CFA, TLA, RMSA values are sufficient according to this citation. This is one of the recent citation, Professor, 2018 paper.
Okay, fine, thank you. You have put it on the chart, yes.
Yeah. Anything
Thank you,
else?
thank you.
No, if it is a day-long session, because I used to run 5 days program on SIM alone. If it is a 5 days program, there I would have discussed testing multidimensional constructs in CFA framework, running common method bias testing, using this flexible fit criteria value. Those components might have been included in the session, but part of this 2-hour session, I don't think so. I'll be able to include everything. Yeah. Any other quick question? If there are no questions, shall I leave?
Participants, you can ask. If you have any queries, you can ask. Otherwise, we shall conclude. Okay. Thank you, sir, for your wonderful session. We feel blessed to have you at our research methodology course. Thank you for sharing your knowledge and also sharing the various sources within the time constraint. I would also like to thank on behalf of course director, Department of Commerce, Central University of Tamil Nadu. And from the participant side, if anyone have feedback, you can share it. Thank you. Thank you, sir. Thank you once again.
Thank you so much. Thanks for your valuable support as well as wonderful participation, and thanks to some of the senior faculty members, those who are attending this program, like Professor Mallikarjuna sir and so on. I thought that this program is only for scholars, but there are some professors also attending, so it's really surprising. Thank you so much. Thanks. Bye-bye.
Session is so interesting. Every time I hear, I get new knowledge, and therefore I would love to hear.
You are from QSET, sir?
No, I am from Central University of Kerala.
Oh, okay. So you might be knowing Professor Thiago. I know him personally.
Yes. I was in one of the sessions where Thiago conducted.
Oh,
So
okay.
you were in Central University of Hyderabad at that time.
Oh, okay, fine, sir. Fine, sir.
Yeah,
I think,
joined
yeah,
this
I can
course.
remember, sir. I think I did some session for Central University of Kerala at that point of time.
Yes.
You also raised a similar kind of questions. I can remember. Yeah.
Joshit and Thiago, both of them.
Yeah. Thank you. Thank you so much, Professor. Bye-bye. Bye.
Wonderful session.
Yeah. Bye-bye. Bye.
Participants are requested to fill the feedback form in the chat box. Thank you. We'll have our next session at 2:30, and we'll be having afternoon. Thank you.
Could you please repeat the last statement?
We are having 2 sessions today, one at 2:30 and one at 4:30. Schedule for today. Hello, am I clear?
Yes, thanks. Clear, sir.
Thank you. Thank you, ma'am.
Yes, clear. Good afternoon, sir.
Hi, Amal. Good afternoon.
Yes, sir.
How are
Sir,
you?
yes, sir, I'm good, sir.
How are you? Good.
Sir, we will start the session by 2:30.
Yeah, sure. I'm ready. Yeah. So good that finally the things is now set. Net
Yeah,
here, Wi-Fi it's working.
yeah, morning here also there was no power.
Yeah. Since morning we had a problem. Maybe we can announce. In between if something happens, I will join in 2-3 minutes time. We'll
Yes, sir.
arrange alternative connection. If nothing works, we'll connect our mobile phones.
Okay, sir.
Yeah,
It's fine.
there's a fluctuation here since morning.
Mm.
Yeah.
Sir, I will inform them in WhatsApp group also.
Yeah, sure. Yeah. So we'll have about 1 hour 30 minutes for the session.
Yes, sir. It's
Okay.
scheduled up to 4.
Okay. All right.
Actually, we are having 4 sessions today. One more session is left today.
Okay. All right. So up to 4 we can
Yes, sir.
continue. Okay. So we have only around 20 participants. I hope they would be joining. They might
Yes,
have
sir.
gone for lunch today.
Last session, it went around 145 or something. So,
All right. So Amal, in between, to make it more clarity, I may mute my video. Okay.
yes, sir, it's fine, sir. It's all up to you.
It will fluctuate sometime if it is video. Maybe you can inform others, they can mute their videos as well as
Yes,
audio.
okay.
But in between, there will be a lot of sharing. In that time, they should unmute and speak.
Yes, we have the co-host position.
Then only it will be interesting.
Yes, sir.
It has to be on hands-on training rather than just a lecture mode. So, in total, how many disciplines are there, Amal?
Um, sir, there are messages from management, commerce, economics, yoga, and also.
Okay, around 7, 8.
Yeah.
Okay, all right. Amal, just I made a minor change in the title, okay?
Yes, sir.
It's actually tools only, tools and methods. We can't separate these two together.
Okay.
So research tools and methods.
Yes, sir. Sir, can we start? I think other participants will be joining after.
Sure, but no problem. Yeah, we can start. Yeah.
Good afternoon, everyone. Today, we have Dr. Sikamani Penny with us to deal with the topic, research tools in social science research. Dr. Sikamani is a professor and head Department of Social Work, Central University of Tamil Nadu, and coordinator of Center of Happiness. He has worked at various eminent universities like University of Minnesota, USA, Jishou University, China, Tianjin University of Finance and Economics, Tianjin. He has authored articles and books of national and international repute published by Sage, Spengler, Wiley, Elsevier, Taylor and Francis, etc. We are extremely happy to host you for the ICSR research methodology course. Session is all yours, sir.
Thank you, Amal. Thank you. Thank you. Good afternoon, everyone. I hope you all had lunch. No response. That's a problem with online teaching. No? Wait. So Let me take this opportunity to thank Dr. Velmurugan sir. He was the former Dean School of Commerce and Management, former Head Department of Commerce, for the wonderful opportunity to be part of this workshop. So they asked me to share my experience on two themes, tool and writing skills. So day after tomorrow, I'm going to discuss the writing skills, especially the manuscripts, project proposals, research networking and collaborations. But today's discussions, I'm going to share my own experience on tool construction. Tool we can understand in two perspectives. Number one, the instruments can be used for research. That's otherwise called as tool or instruments. There's another perspectives we can use tool, statistical tools. I hope it is clear. It's not about the statistical tools. It's about tool construction for research. Okay, so tools and methods in social science research. That's a topic for today's discussion. So here, what I'm going to do here in this, so I'm going to share my own experience on designing and devising research tools. So far I had conducted 4 major research projects, several supervisions, including postdoc supervision, PhD supervisions, and also being part of multiple research projects as subject experts. So here, what I'm going to do, I'm going to bring out the detailed in-depth analysis or detailed description on do's and don'ts while devising research tools for today's lecture. Am I audible, Amal?
Yes, sir.
Video PPT is clear?
Yes, sir. It's clear.
Okay, great. So in research, I always used to remember this David Edward Deming on two aspects. Number one, he was the one who presented a work on data, relevance of data. He says, without data, if you are presenting something, you will be called as a person with an opinion, not as an evidence. And the other thing, what he says, another platform, he said, it is not enough to do your best. You first have to know what to do and then do your best. Which means, he says, like, we must learn the process first. So 100% concentration on learning the process. It suits well in our research, especially in social science research. Therefore, the tool construction in social science research. So I'm sure you all might have already read a lot about interviews, questionnaire, participants' observation, and so on. Now, what is new? What we should learn in this today's lecture? So I'm going to bring a different perspective, especially looking at these 5 objectives of my talk. So today's lecture is based on these objectives. Number one, to provide the researchers the various steps involved in social science research. So when we are constructing tool, we can't see things in isolation. Before tool construction, during tool construction, after tool construction. Therefore, I am going to link the entire research process so that we can prevent future problem. In research, it's social science research, there is something called, always it's called, unpleasant surprises might happen in future. You may write my words. If you are using a wrong method or model or tool, you will face unpleasant surprises. Unpleasant surprises means you will not be comfortable in continuing further. Therefore, to prevent such kind of unpleasant surprises in our research, therefore, I'm going to bring a perspective on the process, the research process by understanding tools and methods of data collection. Therefore, pre, during, and after. That's number one. Number two, to understand the relevance of sources of data and the developing research tool. Without knowing the sources of data, for instance, primary sources and secondary sources, it would be difficult to construct a tool. Therefore, we need to understand the data sources, primary sources as well as the secondary sources, and then only we can develop the tool. Therefore, the second objective is that. The third one, fundamental issues in tool construction. Very important. So fundamental tool, which means fundamental issues, especially to learn the basic rule. There are certain basic rules we need to learn. That's what I'm going to share. The fourth one, the tool construction itself, development of a research tool, it's a process. So how we can initiate the tool construction process? I'll give you an example. So before you start with the tool construction process, first we should know two things. What kind of data we need from the field, like data required from the field, number one. Number two, data required from the secondary sources, both primary sources and secondary sources. So two things we'll have to finalize first before we construct the tool. Number one, first, what kind of data we needed from the field, and source, how we'll get the data from where. So the kind of data sets we require from the field, and then the sources. For instance, a study on health impact on air pollution, or air pollution its health impact. You can get the data from various sources, like visiting hospitals, like patients met with like certain component, like you can have data from patients, number one. Number two, data from doctors, data from the traffic personnel, data from the government officials. Therefore, before we get into the tool construction, we should have the answers for these two things: the kind of data required from the field, and then the respondent. So that we'll get through pilot study. I'm also going to bring the relevance of pilot study and tool pre-test, because these things also involves while constructing tool. That's the fourth objective. The last objective, in fact, we can't call it as a fifth objective, to learn do's and don'ts to prevent unpleasant surprises in research. So unpleasant surprises always happen because of some minor mistakes. If we prevent such kind of minor error and mistake, certainly we can prevent that kind of unpleasant surprises. So that's what the objectives for today's lecture. So the learning outcome of these lectures today, the take-home lessons. The take-home lessons of today's lectures to the heart of learning, designing research tools for social sciences research. That's what we'll have to learn from the lectures today. When you go out of this today's lecture, at least I wish you should learn 2-3 major points in addition to whatever you would be knowing already. Okay. Now, social science research tool relevance. Across the globe, the argument among the researchers on the relevance of tool. Can we conduct research without tool? I need your responses. Can we conduct research without having a tool? Any response? You can unmute your audio and speak. Can we conduct research without having a tool? Tool means structured or unstructured. Can we conduct research without a tool? Okay, it's a debatable question. Somebody should answer it. So yeah, yes sir, no.
No,
There are
sir.
mixed responses are there. But it's a debatable issue in social sciences research. Okay, we'll answer it later. Number one. Number two, tool used in both theoretical and empirical studies. That is my assumption. Across the available literatures, most of the researchers are agreeing with this particular argument. What they say is, we can use tool for both theoretical research as well as empirical research. Therefore, it is most relevant. Like subjects like philosophy, subjects like language, like English studies, humanities. There are a lot of studies based on theories. There are also, people are using certain set of questions to extract data. I'll give you an example. Historian, a person with history background, you want to understand the role of certain groups during freedom struggle. Okay, certain religious groups during freedom struggle. See the source of data, what he or she can do at that time. They can go back to the library's archives. They can look at the published newspapers during that period, during the freedom struggle. It's all preserved in the libraries. They can extract the published news articles from the newspapers, magazines, journals. Then they can extract informations based on the research, like the particular the research based on the proposed research, like theoretical studies. Even for the theoretical studies, we need set of questions, set of instruments. Tool instruments are interchangeably used. Please, you may write it. Okay, it's not different. It's all same. Interchangeably, you can use the term tool or instrument. Number 3, the numbering. I'm not following this numbering. Number 1, that's what my first question. Like without even tool, we can conduct research. Yes or no? Second, about theoretical and empirical studies, we can use tool. Primary and secondary sources. That's the start point. Without knowing the primary and secondary sources, we can't construct a research tool. Therefore, as a researcher, as a beginner, or a young career or mid-career professional, before you conduct a research, after completion of your project proposal, we must know the various aspects of the sources, primary sources and secondary sources. In addition to primary sources and secondary sources, there is another additional points we must know. Primary sources, what kind of data we needed, and then where we'll get the data. Like, data category and respondent category. Respondents groups, people who involved in the work, like directly or indirectly. That's it. Second. Third, methods. Very nice. So it's also a very important point. Methods includes multiple methods. I would like to share 3 methods: observation methods, interview methods, and questionnaire. Okay. So all these methods, what is the prerequisite? Without tool, you can't conduct observations. Without tool, you can't conduct interview. Without tool, you can't have a questionnaire. Tool is the base. That's a base. It's like a lifeblood of your research. Without tool, you can't do anything about these methods. Therefore, it's the 2 sides of the research, tool and methods. So therefore, we must understand the relevance of tool in conducting such kind of methods, like observation studies, interviews, and questionnaire, including home visits. Last one, tool development is an important part of research. In research process, like there are 3 steps in research process. Before before proposal construction, and the main study. Then the tool constructions plays a major role. Anyway, I'm going to explain. We have enough time to discuss the entire research process and then the relevance of tool, so that we can prevent unpleasant surprises in future. Okay, shall we continue? Shall we proceed? Yeah, except nobody is responding. There's an absolute silent. Okay, I am assuming that I'm in the class. Everybody is looking at me.
So there's a request in chat box actually.
Yes, ma'am.
Can you raise your voice with 3 weeks?
Can you please come again?
Someone, sir, voice is very low. Can you increase it? Someone is asking.
Yeah, sure, I'll do that. Yeah, thank you. Sometimes, yeah, its full volume is there. I don't know.
Okay, sir.
Its full volume is there. Okay. Now, emerging trends in social science research. The next set of argument. Emerging trends in social sciences research. So why I am presenting these dimensions, these are all very important aspects we need to understand before we construct a tool. So the emerging trends are paradigm shift in social sciences research. Once after knowing the paradigm shift in social sciences research, then only we can do a good job in research. Now, so it's a golden age of social science, 20th and 21st century. The golden age of social science research. Do you know why? Most of the funding agencies across the globe, whether it's for PhD funding in US, UK, Canada, Germany, and other parts of the world, PhD program, it is fully funded. Okay, so especially in science and social sciences, applied social sciences discipline, there's a lot of funding is available, and also there's a lot of transdisciplinary research aspects are there in social sciences research. That's why I can call it as a golden age of social science research. Then the emergence of data science and computational social sciences in research. So computational biology in health sciences, but late 80s and 90s, early 90s, There's another field emerged in social sciences research called computational social sciences. The computational social sciences is an application of advanced statistical methods in social sciences research. When you are applying the advanced methods in statistical methods of statistics in your work, what is needed? You need to have a strong tool. Once if you are having a strong tool, then you will have a good quality data. After having a good quality data, you can adapt certain methods for data analysis. So everything depends upon the quality of data. Again, the quality of data depends upon the tool. The arise in interdisciplinary approach and interdisciplinary team. Both transdisciplinary and interdisciplinary is common in these days. Evidence-based public policy and practices. So every research, especially in social sciences research, that should lead to two things: scope for future research and also policy directions. Again, the quality of inputs depends upon the data. Again, that goes back to the tool. Debate on data without research. Can we conduct research without data? There's again another debate going on. Especially anthropological studies, epistemological studies. There's a data without research. So in research process, there is always a debate. Research methods versus research tools. Sometimes there will be a lot of confusions on the application of research methods and research tools. Therefore, at the end of today's lecture, we need to know the relevance of all these aspects. Okay. So understanding the information needs of social scientists, very important. So before you construct your research tool, you need to prepare a kind of checklist for your own research. Okay. So what is your understanding on data or information related to your topic? Prepare a checklist and what kind of data you needed from multiple sources. Let me present you around 14 aspects of data needs of a social scientist these days. It's also called as the current phases of social sciences research across the globe. The current phases of social sciences research, it includes literature review, research data, measurement instrument, support for data analysis, support for data collection, variables in research data, software support, networking, collaborations, mixed methods, multiple authorship, open access publishing, inadequate funding, research and practice gap. So, as a researcher, you may be the beginner of research, in social sciences research. What you need to know, but before you construct your research tool, you understand the complexities in your work and also understand the various aspects of data source and understand after collecting data what you would be doing, what would be the outcome. Once after having the holistic view of your research, then you can develop a wonderful tool. That's what the current phase is. Let's have an exercise, 2 minutes exercise. I would request everyone to participate in this exercise. Self-assessment and expected outcome of this today's lecture. So the self-assessment of the today's lecture session. So please take a blank sheet. Think of a published research project or published research paper or published book that you have already read. Can you identify research process, including theories, hypotheses, tool, methods, observations, study limitations, and empirical generalizations? Let me repeat. Based on your earlier experience, based on your readings related to your topic, please identify two things: research process and then the tool. A 2-minute exercise, because my entire session is going to be based on your feedback on this question. Like, think of a published paper or work that you have read. Identify research process. It could be based on your memory, okay? So no need to go back exactly. Just remember that and you write, mention those points. Is there any link with theories, hypotheses, tools, methods, observations, and results? Is there any link? Like you have read a paper that you identified these aspects based on your own analysis. Is there any link? Yes. There are many responses are there coming up in the chat box. This says yes, there is a link. Usually in the peer review, and even those who are in the review, editorial board of those journals or project team, they will always look at the kind of link, the logical link you are drawing from the work, like the connection, theories connected with hypothesis. Hypotheses are connected with tools, tools are connected with methods, methods are connected with observations, observations are connected with the generalization of the study. Therefore, here, so the two things we'll have to understand. We'll have to understand the process as well as the logical flow, the connectivity. So research, usually it's, we always understand research in this perspective. A methodology involves prescribing or presenting rule of procedure or certain basic rules of procedure. Therefore, in tool constructions also, there's a rules of procedures we need to understand before, during, and after. So research is one of the best ways of collecting accurate, sound, and reliable information. Let me repeat. So ways of collecting accurate, sound, and reliable information. This is a definition of research. In the definition itself, they are insisting the importance of research tool. Without having a proper tool, you can't go for accurate data collection. The accurate data collection depends upon the tool you would be using. And sound and reliable information. For that, we need to have validated tool, reliable tool, usable tool. Let me repeat. To collect sound and reliable information, you need to have a tool with validated, reliable, and usable tool. It's all about diligent search and studious inquiry or investigation or experimentation aimed at the discovery of new facts and findings. So without tool, it is not possible. So revision of existing theories or laws in the light of new facts or practical ideas. So here I'm talking about the kind of checklist we must use it even for analyzing the available literature review, secondary sources. So the application of research, it's all about a way of thinking, including logical, rational, and critical examination, not only a set of skills. Set of skills and competencies. It's all about competencies. It's all about administering the tool, an integral part of your professional practice, greatly influencing the practice procedures and outcomes. A way to gather evidence for your practice delivery of service based upon research evidence. It's always required for good professional practices. Practice development and policy formulations. Every research must lead to policy formulation or developing practice. So research is undertaken in order to enhance our knowledge. So what we already know, to extend our knowledge about aspects of the world of which we know either very little or nothing at all, to enable us to better understand the world we live in. The point here is that, so before you construct the main tool, you must have the checklist, like data required from the field. There you come with the draft after draft after draft, where you would need to provide an answer for all these questions. Then only you will get the right kind of data. Otherwise, what would happen? Otherwise, you will get something there. You won't get solid data for the main study. Therefore, we must prepare the answers for all these questions even before tool construction. So the scientific methods consist of systematic observation, classification and interpretation of data to answer research questions. So three things are directly connected. Statement of your research problems, research questions, study objectives, and then your tool. So these are all the base foundations for constructing your research tool. Without knowing or without having a clarity on the statement of your research problem, without having a clarity on the study objectives, without having clarity on the research questions, you can't construct a research tool. Therefore, that's an essential, or maybe we can call it as prerequisites for tool construction. Therefore, social science research is the systematic analysis of research questions by using empirical methods. For example, you may refer the psychology, sociology theory, great study of suicide, like asking, observing, analyzing data. Asking and observing itself Without tool, you can't do it. Otherwise, what would happen? The purpose would be lost. Without having tool, no, you can't have the focus. Contented. That will bring, the tool will bring, that will help you to focus more on deep research, like asking, observing, analyzing data, etc. It aims just to make empirically grounded statements that can be generalized or to test such statements. For social sciences research, the major tasks about knowledge production or production of knowledge is prioritized. Or practice-oriented research, practice of field or for the solutions to the problem in practice, or it always helps, basis for theoretical and practical decision making. So once after completion of your findings, or once submission of your research report, or once submission of your research paper, what the reviewers will look at it, they will look at it, the novelty of your work. When I say the novelty of work, uniqueness of your research, applicability of your research, usability of your research, in these aspects, knowledge production, whether you are adding, you are giving something new to the field of business administration or commerce or economics, what is new in your study? Okay. Otherwise, what would happen? The reviewers will give a comments like this: your paper has been rejected based on you presented only the existing facts or existing arguments. So it depends upon the quality of the tool. It depends upon the kind of understanding you have made as part of the literature review, practice oriented and basis for political decision making. So every research must lead to these findings, outcomes. Exploring issues in deep, discover new relationship, testing the theories, effect of interventions, and providing a knowledge base. For all these, tool is the base. Again, I'm going back to the relevance of your research tool. The journey of research process. Like, it depends upon the authors. They can have 4 phases or 5 or 6. So according to few literatures, I would like to refer 3 phases. Phase A, phase B, and phase C. Phase A, deciding what to research. Phase 2, planning a research study. Phase 3, conducting a research study. So the 3 process before, during, and after tool construction. Data collection is an important part of research. Nobody can deny this particular argument. Without data, like you are a person with an opinion, according to David Deming, the data scientist from United States. This without data, you are a person with an opinion. Nobody is going to accept your views. Therefore, data collection is an important phase in research. For data collection, what you need a tool. Relevance of appropriate tools and use suitable measurements techniques. Complete the whole process. So research process, deciding what to research, phase 1. That's one considerable time we need to spend it for formulation of the research questions as part of the tool construction. Like selection of research problems, systematic searching of the literature, formulation of the tool, formulation of hypothesis, and then operational testing. Phase 2, it's about the actual study phase, developing a project plan, proposal development, sampling, and selecting appropriate methods and tools. Please remember, the first phase, again the tool part comes there. Second phase, selecting the appropriate methods. In the proposal itself, you would be writing a subsection on sources of data and the tools and also its application. Writing a research proposal, data required from the field. Constructing an instruments for data collection. Third phase, last phase, it's about conducting a study. It's about access to the research site, data collection with relevant tool. There is an argument. You already got the ethical clearance and approval from your supervisor. During the data collection, can you modify your tool? It's a question for you. You need to answer it. Will you modify your tool during data collection, even after getting the approval from the ethical clearance and your supervisor approved it? But based on your interview, based on the first few interviews, you felt there is a changing trend in data. Can you modify your tool at this stage? Great. There are some responses. Yes, sir, we can modify. There are certain procedures we'll have to follow. We'll have to make a written justification for these small slight modifications. Inform your supervisor and incorporate. Therefore, the tool constructions there in all 3 phases. phase A, phase B, and phase 3. Okay. No, so let's look at in detail for a few minutes. Okay. So deciding what to research. It's all about selection of a research problem, because this research problem, it is directly connected with your tool. Without knowing the statement of your research problem, you can't construct a research tool. Every research project, whether it's a PhD project or master's level project or PD, a postdoctoral fellowship project or a minor project or major project, all these projects starts with identification and selection of a research problem. Potential sources of research problem, a broad idea that you want to explore. So the starting points again, empirical evidences recounts many examples of how ideas of research have emerged and have developed into research questions. So we need to understand the free phase of tool construction now. Like for instance, how a community changes in response to absolute poverty. It's a statement. Maybe we can call it as a broader area of your work. Questions, formulate research questions concerning the attitude of the populations towards absolute poverty. That should be the start, beginning of your tool preparation. Social consequences of poverty. Further, let me explain. Characteristics of research questions we need to understand before you construct the tool. Then only we can have a structured tool, like pre-phase of tool development. What type is it? What is its structure? How frequent is it? What are the causes? What are its processes? What are its consequences? And what are people's strategies? Okay. Therefore, having a response to these questions, then you can design the tool. Formulating a research problem. In search, and we begin with the problem formulation, the identification and the destination before understanding the journey. This determines the subsequent stages and steps in research. So if you want to make a strong base in tool, then we need to understand the importance and also specific focus of concepts, methods, statement, objectives, and so on. So it is the reference point in deciding the general research strategy as well as specific designs. Formulation of research problem. This again, there are several steps used in formulating a statement of your research problem. Identify a broad field of subject area. Dissect the broader area into subsets. Select what is most important. Raise research questions, formulate objectives, access your objectives, check, double check. Here the step 3, very important. Select what is most important. Raise research questions. Step 3 and 4 is necessary part for pre-preparation of your tool. Once if you are having an answers for these 2 questions, certainly you can develop a tool in quick manner without wasting much time, and you can have a proper tool that can be validated and reliable tool. So we'll have an exercise, maybe 30 seconds exercise. You may write it in your notebook. Identify 3 potential research questions, tools related to your research. Let me repeat. Based on your research, please identify potential research questions and also the relevant tool related to your research. Let me further explain more. Does your study have a research question? Yes or no? You must answer this question. How many research questions has your study? Can your research questions be answered? Very important. Do's and don'ts. You know, you can't ask certain questions where you won't find answers. You can't ask your respondent to make oil from stone. You can't ask anybody to make oil from stone. Therefore, can your research questions be answered? Therefore, the tool, you will have to make it as a clear-cut, contented, focused, that the respondent should answer. Therefore, pilot study and pre-test. Based on the pilot study, you can develop the preliminary tool. Then after having a detailed discussion with your supervisors, with a lot of meetings, discussions, and then some more readings, literature review, you can finalize your tool. After finalizing your tool, you can go for tool pre-test. Tool pre-test only will come to know exactly, the difficult questions. Usually the tool pre-test, I'm sure the other speakers might have discussed the pilot study and tool pre-test. Here I would like to refer only one point, tool pre-test. Only after having the tool pre-test, then only you will understand the feasibility. You can understand the complexities, you can understand the problems faced by your respondents. as well as you can have data, you can have sufficient information for your research methodology section. Please mark my points. Without a pilot study and pre-test, you can't write a methodology chapter. Make sure that in your methodology chapter in your PhD work, make sure that there is a column, there's a subsection called pilot study, tool pre-test, and then the study limitations. So there you can link the tool. Can your research questions be answered empirically? Then only you can develop your tool. If you have the answer yes, like who can provide insight for that? Can your research, can you reach these people? Where can you find such kind of people? Which situation can give you insight for answering your research questions, and are these situations are accessible? How clearly is your research questions formulated? Very important. Each and every questions in your tool has to be specific and clear. Make sure that you will use simple sentence, not complex ones, not long ones, short ones, and clear ones, not like difficult to understand. What are the methodological consequences of research questions? You need to understand. You can't simply write all questions related to your research. There should be kind of checks and balances, filtering, inclusion and exclusion criteria while getting the information, filtering. Because a tool, if it is a structured tool, it would be difficult to justify later stage. That's what I said in the beginning. It would be, you will have a problem of what? Unpleasant surprises. For example, domestic violence, systemic framework, how can develop the tool? Domestic violence study, like profiling the victims, profiling the families, profiling the perpetrators, reasons for domestic violence, extents and types of domestic violence, its impact, impacts on families, impacts on children, services available for the victims, services available for the children, effectiveness of the service, extent of DV in the community health impact. The point I'm trying to make, you might have studied systems theory in management, commerce, economics. Usually in systems theory, what we see here, main systems and subsystems. Each things are connected. Each subsystems are connected with the main system. Therefore, in tool constructions, we need to understand every level, who will give the response and what kind of responses we needed in order to have a holistic understanding, in order to have a broader framework. Similarly, with even policy studies, we should have such kind of framework. Problem recognition, without having a clear understanding of problem recognitions, you can't construct a tool. So problem recognition means a research problem must be identified and defined without any ambiguity. The research problem should be clearly defined. In computer science, you might have studied, all of us, when we learned first time computers, our teachers might have taught, garbage in and garbage out. The same principles applicable here also. If you're not clear about your this problem, then you will end up with unpleasant surprises. Variables, very important. List of variables. Before you construct the final tool, you must have set of variables. Like variables might be of text such as age. Could you please unmute Lakshmi? Yeah. So if you're speaking, you can unmute. You may mute your audio. So variables. So the free tool designing phase, you already prepared the list of variables. That means data required from the field. So identify directly and indirectly related variables and then list it. And also prepare another list like where you will get and who will give this data. So variable must be a factor such as age, gender, social education level, religion. Tool construction, there is a basic rule. There are certain aspects, actual information. You need to have exact question. For example, what is your age? What is your height? What is your weight? These are all the direct statement. You can have direct responses in your tool. To express research aims in terms of variable is to some extent adapt a realistic position. So every question in your tool must have this particular aspects. Variable each. Again, variable, there are two types, independent variable and dependent variable. You can have like hypothetical questions, you can have a mixture of both independent variable and dependent variable. But other questions you can have simply variable. So independent and dependent variables, to understand their meaning and purposes, For example, when you are drafting a like scaling, a Richter scale, 4-point scale, 5-point scale, there you can have such kind of mixture way of questions. So once a population is fixed, we can then we then want to study a characteristic of individuals in the population. For instance, height, weight, income, dietary habits, etc. The variable classifications like could be qualitative and quantitative. The qualitative variables could be like gender, height, color, nationality, ethnic origin, etc. Quantitative age, blood. It's like measurable variables and non-measurable variables. So you can have mixed aspects in your tool. So systematic searching of the literatures. So what is the point? Why do we need to understand this relevance of systematic searching of literatures for tool construction now? That's a very important aspect. So we need to again think and understand. So theoretically relevant literatures we are looking at as part of the literature review are the studies about these are similar issues to establish the link between what we are going to propose, what we are proposing to examine and what has already been studied. Very important. For example, a study on health and safety of women workers in construction industry. Okay, that's what your primary study. There are several studies has been already conducted. So you read several papers, you read several books. You came up with research gaps in the that particular subject area. So based on the research gaps, then you can add more questions. So therefore, you are justifying your work. My study is going to fulfill or fill those gaps. Therefore, indeed, it's necessary to understand the literature review and also not only the literature review, gaps in the literature review. Therefore, in your methodology chapter, again, there will be another section called gaps in the literature review. Otherwise, simply they will write one line. Okay, so nothing new in your study, therefore, this may be rejected for further process. Okay. So it depends upon the gaps, how your study is going to fill the gaps. So overviews of the relevant literatures on research methods in general or in specific methods. So systematic searching of the literatures. I'm sure some of these sessions you might have already discussed. I'll just skip few slides and then we'll take up the other issues. But of course, it is necessary to understand the art of doing a systematic literature review, because this will give you more insights. In fact, this will give you an idea of preventing repeated questions, preventing duplications, preventing unnecessary irrelevant questions in your tool. Therefore, it is necessary to follow this kind of procedures like searching for the existing literatures on your study area, reviewing the selected literatures, developing a theoretical and conceptual framework. The theoretical and conceptual framework will be the base for your tool. The outcome of the review, definitely it will bring clarity and focus on your research problem, improve research methodology, broaden your knowledge base in your research area. That's what the tool path plays, contextualizing your findings. So the next activity is related to literature review. These are all the activities for pre-tool construction, what is already known in the area. Okay, so even after having the data on the known factors in the field area, still you are adding those questions means it will not make any difference or it won't make any sense. Therefore, kindly avoid such kind of questions like what was already known in the field. Remove it. You add the unknown areas. What is not known? That's what gaps in the existing body of knowledge. Your tool should be based on only this point. What is not known? Gaps in the existing body of knowledge. For instance, a study on employee engagement, or a study on stress management, or a study on improving the productivity, or a study on sales performance. You can't go back to the previous questions or the already has been conducted. You will have to have a novel, a new set of questions. What questions have remained unanswered? Very important. That's the reason you should do a thorough review of literature. What theories have been put forward? What suggestions have been made for future research? Excellent. Scope for future research in those papers. And in fact, in your own research report, you should write a subsection in your methodology chapter called Scope for Future Research. What research strategies have been employed by others undertaking similar kind of research. Okay. Any doubt so far? Any doubt so far? Great, thank you. So the review of literature's output framework. This was the structure. Even in your PhD thesis, you will be having a chapter on literature review. The literature review itself, there's a research question subsection where that will lead the base for tool construction. So formulation of research questions, research problems versus the research questions. So it's all about to decide on a specific research questions to formulate in detail and all to narrow it down like base, and then hypothesis. Hypothesis also very important, okay? But having hypothesis in social science research, it is not mandate. But subjects like OB and HR, psychology, okay? So this having hypothesis, of course, it has become a mandatory part. What is its link with tool construction? Once if you are having hypothesis in your tool or in your proposal, it is necessary or it is a kind of mandate that you should have set up questions will get and set up questions should address these hypotheses. Okay, like sometimes you can have scaling techniques, attitude measurement, satisfaction level measurement, suggestions based on ratios or based on methods, based on assessment. So hypothesis brings clarity, specificity, and focus on a research problem, but it's not essential for every study. Hypothesis formulate relations in a way that can be tested. Therefore, you can, if you are having hypothesis, you can sufficient number of research questions in your tool, like formulate assumption, collect the required data. How you will collect the relevant data based on relevant set of questions. So phase 2 about design. Again, design also plays a major role while tool construction. Let me skip few aspects. Okay. So again here, when we are looking at the research design, it's like the study populations, universe, sampling and sampling techniques. Okay. So there, the data collection process plays a vital role. So data collection process depends upon the quality of your data, and the quality of your data depends upon the tool that you would be using. So selecting an appropriate tool, that's a spelling mistake, I'm sorry about that. Methods, tools and methods for collecting and analyzing data. There are three alternatives there for tool construction. In every research, okay, three options are available. Select one of the existing methods or select one of the existing tools for your study. You may need to get a written permission from the person who developed the tool, or you may use a questionnaire which has been applied successfully by the other researchers by getting a written permission. Second option could be often you will have to modify an existing method. You may skip some questions and add new ones. Third, to develop your own method. You can have altogether a fresh tool, new questionnaire, that new methodology or new form of interviewing. Okay, so the tool method, kind of tool, either you can use the already available tool or you can slightly modify. But for number 1 and 2, you need written permission. You need to have an approval by the person who developed the tool. Third, with your supervisor's inputs, you can have your own tool based on the literature review and based on whatever we have discussed earlier. So writing a research proposal, again, there should be a separate section on methodology, and that methodology would be discussing the research tools and techniques. That's the question, sir. What about using theory? Of course, you can use that. Okay, it is all there. You can use the relevant theories, the approval by your supervisor. So the methodology section again, since I'm sure the other speakers might have discussed many of these aspects. I took to focus only on 8.4, that's the research tools and techniques, where that you would be understanding the detailed process of tool construction, construction on instrument for data collection. Usually, it involves 4 levels. Level 1, specific objectives, research questions and hypotheses. That's what we have discussed so far. And what informations do you require? Like data required from the field. Identify the required variables. Next stage. Then formulate research questions. Formulate, that will become your tool. Okay, these 4 basic steps involved in tool construction. So we discussed in detail all these number 1, number 2, and number 3. Number 4 about the formulation of the exact questions. Now, so the Kalk Benner from UK, he developed a framework called the measures approach for instrument development, the measure approach for tool development. Let me just read out for you. Okay, so the measure means make the purpose or rationale clear, establish empirical framework, articulate theoretical blueprint, synthesize content and scale development, use experts reviewers, recruit participants, evaluate validity and reliability. This is a basic framework they have presented for developing a tool, appropriate tool. Then the concept of research data, we need to understand in the tool itself the data. So please remember data, information, facts, these are all the conceptual meaning we must understand. Okay, so there is a question, sir, if we are, we'll come back to those questions at the end. Okay, let's finish up the whole presentation first. Yeah, there are a couple of questions, I'll answer it later now. So the concept of research data. So data versus information. You need to understand the difference between these two. Gathering and gathering and the classification of research data. So facts have to be collected on in fulfillment of objectives. Very important. Third point is a very important. Okay. So you must have sufficient number of questions to answer those objectives. Qualitative and quantitative are a mixed form. Facts gathered through various sources and methods. So therefore, so having a clear understanding on these aspects, which will give you directions to develop a systematic tool. Types of data management plan, like observational, experimental, simulation, so derived or compiled, reference or canonical. So here, the types of data management plan, again, the quality of these aspects depends upon the data, and that depends upon the tool. Therefore, whichever method you adapt, go back to the basic framework of tool construction and then come with the right kind of tool. Classification of research data, like here the positivity research data sources, primary data sources and secondary data sources that we already discussed, like the primary sources like field survey, which includes questionnaires, attitude surveys, lifestyle surveys, field studies, observational studies, personal interviews, focus group interviews, so videotaping or audio recording, experiments, laboratory experiments, field experiments. What is common here in all these, whether it's a field survey or field studies or experimental studies? It all depends upon your tool. So the ethical board, institutional ethical board, they will clear your proposal based on answering specific questions related to the source of data and then the tool. I'm sure many of the other speakers might have discussed the importance of questionnaire, interview schedule, observational state. So rather than discussing the basic framework, maybe we can look at the logical flow and then how we can improvise our tool. So tool could be a structured tool or unstructured tool, okay? Or it could be a checklist or a pre-designed checklist. So what is needed here that we need to have a full-fledged tool without having any gap. That is what the primary sources of data. The secondary data sources, which includes organization internal reports, organizational invoice and accounts payable records, registered voter list, voter records, production of service records. These are a bunch of records. That's what the website Journal of Political Science article, they published 2 page on the sources of data and the relevance of research tools in social sciences research. So post-positive data sources, which includes like existing documents, books, periodicals, published reports, films, unpublished literatures, local, state, and federal government document like a policy document, college or university documents, consultant reports, minutes of the meeting, commercial databases, and others. I'll give you an example. A study on public-private partnerships, understanding the economic viability of public-private partnerships in road projects. You can even use the memorandum of understanding. You can use the minutes of their meetings. You can use the reports published. You can use the reports based on RTI reports as part of the sources of data. For that, you will have to develop a set of questions. What kind of data you are looking for and what are the sources? The identifying sources, you can have all these are the sources like internal records, including email content, memorandum of understanding, policy papers, reports and other documents, external sources, which includes interviews, life stories, case studies, observations of participants' observations, etc. Now, the nature and tools of empiricalism, so basic tools for data collection involves surveys and questionnaires, interviews, focused group discussions, field observations, experimentation, photos and videos, case studies, and stories of change or existing data. These are the methods. The methods, if you want to have an excellent base, like you need to have a set up tool to get the right kind of information from these methods. Types of tools and their usages. A questionnaire could be open-ended or close-ended. Open-ended, like it's, there are options are there, wider options. The way they think they can respond. Close-ended, you are drawing certain, limit. So they will have to answers within that. For example, yes, no type. Yes, no type, it is like a close-ended. Do you understand or not? Or do you know do you have a sufficient information on this? Yes or no, or do not know. That is close-ended. Open-ended, it's like, what is your suggestion on this? So questionnaire and interview schedule. Okay. Questionnaire and interview schedule, we use the same set of tool. Like questionnaire, you are actually posting or sending email to ask them to fill it. Interview schedule, you are like you are actually taking the same set of tool and asking them to fill it. Either you or on your behalf. Some of the field investigators are going for data collection. Okay. The tool is the same, but the methods are varying. Interviews or the questionnaire. Could be open-ended or close-ended. So rating scales, like descriptive varying degrees, attitude scales, that's the measures of attitude. Rating scales and attitude scales you can use, like a Richter scale, test quality or genuineness. So therefore, the tool process can have a structured or unstructured tools based on the study, based on your own research. There's another dimensions we need to understand, research ethics. Okay, so research ethics, very important to another aspect while developing your tool. So the research aspects, questions to be avoided. When you are developing your tool, you must avoid questions related to leading questions. There is a time constraint. You can't ask everything. You can't ask leading questions. Can you tell us about the history of this? Can you tell us about the genesis? Those questions is not going to give you any, like solid evidence. You must avoid, while designing the questionnaire. Leading questions, threatening questions. Okay, so putting them in a kind of uncomfort situation, you won't get response. So please avoid such kind of questions. Okay, so maintaining confidentiality. The tool should reflect, in the tool, that's the framework of your tool. First page should be the cover page where you will be writing your declaration as a researcher. This is what your commitment towards the respondent. Page 1. Page 2 about declaration by the investigators and then the respondent. This is called informed consent. Okay. In the informed consent in your tool itself, you must reflect that the confidentiality would be maintained. Okay. So ethical and legal dilemmas which arises out of the competing obligations or conflicts of interest. Very important. It's like biasness of a researcher that should not reflect in your tool. Okay. Kindly avoid having questions related to certain amount of biasness. Obligations to which members should normally adhere as principles of guiding their conduct or avoiding the kind of misconduct. Relations which with the responsibilities towards sponsors or funder. Again, most of your projects might be funded by UGC or ICMR or ICSSR or some other funding agencies. Classifying the obligations, roles and rights. Especially it is applicable to the mid-career professionals or those who are conducting research projects, preempting outcome of negotiation about research. It's about maintaining such kind of commitment, maintaining confidentiality as well as the commitments towards your respondent as well as the funding agencies. Okay. Phase 3, it's about conducting the actual study. Like, so once you collected the preliminary information, then you developed your tool, then you've gone for tool pre-test. Now the final tool is ready for main data collection. So here, what we need to understand here, the access to the research sites involves to organize access to the institution as a whole, to gain access to institutions or institution as a whole, to respondents would be participating, to clarify the issues of permission, To protect participants from any misuse of the data and anonymity have to be answered. Therefore, it is your due responsibility to maintain such kind of thing. So data collection, of course, there are 2-3 alternatives are available there. So you may do a survey in one form or another with your questionnaire or interview schedule. You may also have to do an observations to analyze existing documents. Now, summary of whatever we discussed so far. Tools and methods of data collection. As we discussed, the relevance of primary sources, secondary sources. Primary sources involves observations, interviewing, questionnaire. Then observations involves participants' observation and non-participants' observations. Interviewing, again, structured interview and unstructured. Questionnaire, mailed questionnaire, collective questionnaire, online questionnaire, and so on. Secondary sources, documents, reports, earlier research, and other reports. So therefore, here the base is your tool. So everything would be depends upon your tool, including your literature review. Once after having a checklist for collecting the literatures and compiling, there's something called data synthesis in the literature review. Secondary sources. Okay, that we didn't discuss in the earlier slides. Okay, secondary sources. Secondary sources you can have data synthesis. Okay, so data synthesis depends upon the checklist that you need to develop after having read few research papers. Based on just preliminary framework, you can develop what kind of information you can extract from the literature reviews. After extracting the relevant information, then you can develop data synthesis. In advanced level, this method is called as a systematic reviews, or this method is called as meta-analysis. So systematic reviews or meta-analysis it is known as application of advanced statistical techniques to extract data from the published work. So with that, you can apply statistics and then develop an analysis, okay, analysis and interpretation. Therefore, the tools and methods of data collection is an important in research. So characteristics of a good tool, there are certain other additional arguments we need to understand: validity, reliability, sensitivity and appropriateness, objectivity, economy, practicability, interest, and usability. Most of these points we already discussed. I would like to discuss some more examples related to validity and invalidity. Validity and invalidity. Validity refers to the best available approximation to the truth or falsification of propositions. So tools always require you to do the validity and reliability. So used both in primary and secondary data. Example, 3 types of reliability are pertinent to content analysis. The secondary, again, helps to understand the stability, reproducibility, accuracy. So before you go for the tool pre-test, okay, you must do the reliability test, validity, usability. Stability refers to stability can be determined when the same content is coded more than once at the same order. There you can avoid repetition, duplication, reproducibility, also known as intercoder reliability, refers to the extent to which content classifications produces the same results. I mean here the reproducibility, we can avoid duplication or can prevent unnecessary use of certain data. Accuracy refers to the extent to which the classification of text correspondent to the standard or norm. It's about again having accurate information on this. Usability, third. Usability of a tool depends upon its objectivity, cost effectiveness, the time and effort required to administer the tool. Very important. Without usability assessment, you can't even adapt a tool for data collection. So tool construction procedure, very important. This again we discussed earlier. Introduction and instructions, very important. Your first page and second page of your tool should have introduction as well as instructions to the investigators as well as your respondent. Personal data information, background data, consent, end with an thanking note for your participants. Please remember that. If you have not done the tool for construction so far, please follow this template. Page 1 in your tool, a brief instruction, and then guidelines. Second page, It's about the informed consent, then the background of data, consent. Last page, end with an acknowledgements for the participants. Thank them. Okay, it's very important. This is what the procedure we need to adapt while developing a tool. So data editing and documentations. So this part is there in our day after tomorrow lecture, documentations. But still we need to understand while structuring tool, these are all the other aspects we need to take it into account. Like we'll have an influence on the contents of the quality of data, to edit the data, coding, preparation of code sheet and code books, coding for open-ended questions, standardization of data and procedures. There is one point we need to remember. Every day after data collection, it's like every day you have fixed time for 5 respondents. You come back home, go through the tool, collected tool, understand each and every questions. Please make an assessment of the data trend, then come with the gaps, and now you can improve on it. Therefore, that will give you a good feel good factor, I can call it as, or it will prevent unpleasant surprises in the future. Therefore, at that stage itself, you need to have a systematic assessment about the data analysis. So filling responses into categories defined into advances or allocation of numerical values, statistical. These are all, you would be doing it with other sessions, but still the tool plays a vital role for such kind of things. Okay. Data interpretation. So what it's all about, after analysis, you would be writing what, why, and how as answers. So interpretations related to the data and then its links and so on. So discussions and findings and their interpretation section. Again, the argument, the quality of argument will be depending on the data. The data again goes back to your tool. Okay. So the final aspects, the evaluation and generalization of the work assessment is the data analysis interpretation should be doing a thorough assessment. So need assessment study. Exactly, when you are looking at the real needs and felt needs and what is needed, you need to identify the root cause. The tool, the one you would be developing, that should have an in-depth focus on what you would be studying. Okay, otherwise you won't get the exact response. The results of need assessment studies, like the causes, consequences, implications. And so look at the causes, presentation of the results on the studies, so summarizing the study and its main results, and then writing report. Writing reports there in the next session, day after tomorrow. Manage to make the process of the study transparent to the readers. Even for the tool, you can have that kind of transparent. Using the results, formulating implications or recommendations, to develop suggestions to prepare policy briefs and so on. Developing a new research questions, exactly. You developed a tool, you collected the data, analyze it. Based on that, you can have a section called Scope for Future Research, where you can present few research questions even later. And that should lead to a new study. A new research questions may lead to another study. So the research process, like the mixed methods, you can now in the tool itself you can now like quantitative as well as the qualitative data, or multi-method research in the mixed methods. You can now even in your research team experts from statistics. Then only then you can have more views, and also you can have experts on the case study models. And then I'm sure most of the universities we have like a research advisory board. So research advisory board, you will have subject experts, methodology experts, and then you will have experts based on the practice. Therefore, the 3 experts can contribute substantially for the tool construction, where you can adapt that kind of innovative methods and models. Usually, I always propose that using the mixed methods in research, especially you can now set up questions based on the qualitative aspects. Set up questions, we can focus on the quantitative aspects. So myths and realities, very important in research. You should decide whether the study is carried out and adapting qualitative or quantitative methods. Good researchers need to have both set of skills. Then only you can develop a good tool. Relevance of mixed methods in research. At the end, I'd like to conclude my work by highlighting, try to focus step by step learning process. understand its relevance. The PhD research or postdoc research is nothing but learning the research process. Concept test, focus groups, internet panels, like various methods and models, very important. Of course, every research must contribute to the social, economic, and political development of a nation. Okay, so therefore, like based on the relevance of research tool, the whole research depends. The quality of paper, the quality of the content depends upon your tool. Okay? With that, let me conclude my presentation by highlighting what is quote on: knowing is not enough, we must apply. Willing is not enough, we must do. I'm sure many of you must be knowing the whole concepts of it. Try to apply, learn the research process. Okay, thank you.
The participant.
Can
If you are
take
having any
questions.
problems, then you can unmute and ask questions.
Already we have few questions. We can start with those questions. So Amal, could you please read those questions or please check the chat box?
Yes, sir. I would read.
Was it okay? Whatever we discussed today.
Yes, sir.
Participants, you may speak now. We have 10-15 minutes time to discuss and share. Okay? It's an important area in research process. Tool construction. So there are several books, basic books on tool construction. You can read what is questionnaire, what is observation
Sir,
methods,
good
participant
afternoon,
knowledge
sir.
assessment. Good afternoon, Pan.
Sir, my name is Savio. I'm doing my research in the field of human resource, sir.
Okay.
Okay, sir. Sir, so you told about the tool techniques and selection of tools and all those things, sir. So my question is to if we are assessing the cognitive aspects of an individual.
Okay, but your voice is not audible by breaking in between. Could you please
Sir,
type? Could
sir,
you please type? Post your
yes,
questions
sir.
on the chat box.
Sir, it's
Is,
posted.
sir, is my voice audible now?
Now it's fine, but now it's audible.
Yes, sir. So, sir, so if we are assessing the cognitive aspects of an individual, sir. So, if you are in our research, we have incorporated the cognitive aspects. So, if I am assessing this in the cognitive aspects, so what kind of tool would be appropriate to get the inputs from the respondents, sir?
Very good. It's a good question. You can use like measurement tools, scaling.
Okay, sir.
Highly satisfied, not
Mhm.
decided, unsatisfied, highly dissatisfied.
Okay, okay, sir.
Okay, that could be one option.
Okay, sir.
And I don't know exactly your major subject area in
Sir,
HR. What is
HR,
your
it's into like, sir. So the main, I mean, like the broad area is HR, sir. So like I'm in
what topic?
specific into. Sir, can you hear my voice, sir?
Yes, pa. What topic
Uh,
specific?
yes, sir. I'm specifying into this a diversity kind of aspect, sir. So hello.
Diversity in terms of like region or in terms of managing a bigger team or complex organizations and
No, sir.
what?
No, sir. Actually, see, the basic, I mean, the overall title is into diversity, sir. So my in-depth study will be into some of the cognitive abilities,
Great.
some of the diversity aspects which are not visible, sir.
It's
So
like
which can
emotional intelligent or emotional
exactly.
quotient EQ aspects.
Exactly, sir. That is these are aspects which you can't see or feel, but you can get the response
Great.
once you interact with the individual, sir. So
Please use
from a
measurement tools.
yes, sir. Yes, sir.
Okay. There are
Yes, sir.
scaling, well established scaling is available now.
Okay, sir. Okay, sir.
You can use those, like measurements techniques so that, you can get to know exactly the EQ level now.
Okay, sir.
Yeah, EQ or
Okay.
emotional intelligent, EI, EQ or EI. Yeah,
Okay, sir. Oh,
great,
yes, sir. So we are assessing some behavioral patterns, some
great,
mood which is exhibited
perfect,
in an organization, and
perfect,
the emotional quotient from an individual point of view, and
perfect.
also some
Yeah,
cognitive abilities, sir.
So, like these are the aspects we have been taken into consideration.
So great one.
So,
Now, my suggestion here, identify the respondent category.
okay, sir.
One set may be exposed more.
Okay, sir.
One set might be, like in the implementation stage. You
Mm-hmm.
can't use the same kind of tool for both the groups, okay?
Okay, sir.
Those who exposed more, there you can use, like assessment tool, measurement
Mm-hmm.
tool. And those who are into supervisory level, you can use, case studies.
Okay, sir.
Okay. So now
Okay,
you
sir.
can use the case studies as a supporting documents for writing your report. But the main
Okay,
here,
sir.
the scaling technique, measurement
Scaling
tools,
techniques. Okay, sir. That is fine, sir. So, what
measurement
kind of?
tools.
Okay,
Yes,
sir.
ma'am.
Okay, so what? So, what kind of instruments can I use? Can I go ahead with the questionnaire type of thing, or you want me to prepare some case scenario-based questionnaires or something like that, sir?
Mixture of both.
Okay. Okay.
Use interview method or questionnaire. Both are okay with this. Okay.
Okay,
It
sir.
depends upon your respondent. It depends upon the feasibility.
Okay, sir. Okay, sir.
Okay. If either you
Okay,
can
sir.
use questionnaire or interview schedule.
Okay,
Whichever
sir.
you use, the tool should have mixture of both.
Okay, sir.
Measurement techniques as well as case studies, open-ended, closed-ended questions. Always use mixture of everything. This is my suggestion for everyone now. Like
Okay.
profile of the respondent, and then yes no type questions like open-ended questions, closed-ended questions, and scaling techniques.
Okay,
Please
sir.
use mixed methods for your research, mixed set of questions,
Okay,
so
sir.
that you will get response from all angle. Okay.
Okay,
So
sir.
when you're developing the data main analysis chapter, I'm sure you will have a lot of data, quality data for uh, preparing a good chapter. Ultimately,
Okay.
that will lead to a good publication. Okay.
Okay, sir. Sir, my
Yeah.
final question, sir.
Yes, ma'am.
Sir, you told about both, incorporating both the qualitative and quantitative in research will be of more, valid, or it will be like, valued more than other thesis or other research, sir. So my question is, how can I correlate both, sir, qualitative and quantitative? How can I correlate and bring it in the result form, sir?
Very good. That's a good question. Okay. Now, you can use the results based on the statistics as for in
Okay.
writing the interpretation. Okay.
Okay.
In order to substantiate your arguments, you can
Exactly.
use case studies as an additional set of data.
Okay, sir.
Substantiate your quantitative data, you can use case studies.
Okay, sir.
Okay.
Okay, sir.
Like the same page, you are writing a statistical data like this many percent, or like the cross tabulation. This is what the results.
Okay.
Then create a small table,
Okay, sir.
and use that case illustrations. There you can
Okay,
have
sir.
the numbers. Okay.
Okay.
Case studies. It's called case 1, case 2, case 3. All right.
Okay, sir.
To substantiate your quantitative data, you can use qualitative information like case
Okay.
studies. Okay.
Okay, sir. Okay, sir.
Yeah.
Okay, sir.
This again my common suggestion for everyone. Thanks to Mr. Savio for having asked this kind of questions. So to make it more effective, you can use both quantitative as well as qualitative data. Okay. If your
Okay, sir.
study is qualitative, you can use quantitative as the additional set of data for substantiating your qualitative data. If it is a quantitative database study, you can use case studies as an additional set of documents for quantitative. Okay. I'm not confusing. I'm making my point very clear.
Okay, okay,
It
sir.
will add to the quality. That's it. Okay.
Okay, sir.
Yeah.
Fine. Thank you, sir.
Great. Thank you for those wonderful questions. Amal, could you please read? But there are a few questions in the chat box.
Rahis
In
Sahur,
between the session, we had few questions. Could you please read?
yes, Rahis Sahur has posted a question. He says his tool has developed by National Institute. Do he need a permission for using it in his PhD research?
Wow, that's a great question. Definitely you need a permission, okay? So it's part of your ethical clearance, okay? Ethical consideration of your study. Every level you need permission, at individual level, institution level, group level. It could be a written permission or unwritten permission. Make it happen that written permission should work, okay? It is mandate. You must get the permission, written permission. Okay. So there is a procedure for getting written permission. Please be in touch with your supervisor. They can guide you. There are various steps used in getting the written permission for research at individual level, group level, institutional level, government level. Okay. Without the permission, please don't do any research. Permission, it is mandate for your research. Even the publisher, journals will ask you whether you have received permission, prior permission for conducting this study. You must say no. If you are saying no means they will not accept. You must have an answer of yes. Yes, I've got a permission, written permission from my respondent. I got written permission from my group. I got written permission from my community. I got written permission from my institution, industry, organizations, and so on. So it is mandate. Okay. Next question, please.
Bharaneshwari asks, after pilot study, only is only reliability test enough to validate the questionnaire?
Could you please read it slowly?
After pilot study, is only reliability test is enough to validate the questionnaire too?
Wow, great. That's a very good question. Okay. Validating your research question, pilot study or pre-test is not sufficient. Okay. So validating your research questions, of course, these two things will add more value or in helping you to thoroughly validate your questions. Prior to that, prior going for even tool pre-test, please identify 2-3 experts working in your area. Okay. Circulate your web tool or share your tool with the experts. Let them give their opinion. Let them give their suggestions on your tool. Incorporate their suggestions. You please ask for critical comments, critical feedback on your tool. Based on their suggestions, incorporate it. Then go for tool pre-test. There you will understand the exact relevance of your tool. There only you will understand the feasibility. There only you will understand the exact meaning of those questions. See, as a researchers, before even going to the field, we must be thinking, everything is fine and perfect. But once we ask the respondent, once we ask your manager about the problem, intervention techniques and strategies, then only you will come to know exactly the complexities and problems related to that particular question. Therefore, to validate and check the reliability, you will have to check on both the lines, expert's opinion on your tool, and then actual field experience, and accordingly slightly modify and have an in-depth discussion with your supervisor, and then modify your tool. That's how we can finalize your tool. Okay. Of course, every research will have constraints and limitations. Okay. We can't achieve 100% perfection. In research, there is no word called perfection. Even perfection also can be improved. Okay. So that will become your limitations of the study. Okay. So don't think that, oh my God, what happened to my research? No, nothing happened. You did a good job. Whatever has not happened, that would be the scope of the future research or the limitations of your study. Am I correct? Okay. Next question, please. We have 5 more minutes.
Reliability analysis, are we only checking the tool or are we also checking the data, sir?
Excellent. That's a wonderful question. Okay. In the reliability analysis, again, checking the tool for most important dimension, number one. Number two, again, understanding the data aspects as well. Both are necessary, but the checking the tool is the most important aspect. Okay. It's like, prevent, as I said earlier, unpleasant surprises in research. It always happens in social sciences research, whether you use SPSS or STATA or any other statistical tool, we'll always find unpleasant surprises in future. Similarly, in research, validity and reliability plays a major role. It is not just only checking the tool, it's also checking the kind of the data you would be expecting from the field. Okay, it's also necessary. Therefore, your supervisor role plays a major role. The mentors and the committee members, the research committee members will give you enough inputs on that aspects. Okay, great. Thank you. Those were all really brilliant questions.
Thank you.
Sir, one more question, sir.
Yes, ma'am.
From my side, sir. Sir, since the topic was on research tools, sir, So my question is, literature is one of the main tool for carrying out a research or to define a research problem or something like that. So what is the difference of review of literature and literature review, sir?
Review of literature and literature review, these are interchangeably used. Both are, there is no difference, both are the same. So,
Okay.
but developing a tool, why we need to consider literature review? In order to identify gaps in the literature review.
Okay. Okay.
So once after having the knowledge about the gaps, then only you can prepare a new set of questions, isn't it? Otherwise, you will be replicating the same.
Okay. Okay.
Ultimately, your thesis examiner, no, PhD examiner, they will write, what is new in this area? Please repeat one semester again.
Okay. Okay.
What is new in this area? Therefore,
Okay.
there's a direct link. We must do a thorough check on the
Okay.
available sources and come with the specific listing. Gaps in
Okay.
the literature review. Based on the gaps in the literature review, then you develop your tool.
Okay, sir.
Okay, literature review and review of literature is all the same, interchangeably used. Okay, there's no difference between these two terminologies.
Okay. Okay, sir.
I'm
Okay, sir.
sure I'm sure other speakers might have given enough inputs on these aspects, isn't it? What is it, how it is done, the relevance, do's and don'ts on those aspects. But here we need to understand the link in those. Okay,
Okay.
great. Good
Thank you,
question.
sir.
Yes, thank you, thank you.
So there's one more question from Ranis. It's asking, if sample size is almost more than 300, how many case studies will be better for his research?
Wow, that's a great, wonderful question. There is no limit. I will tell you. There is no limit, however. Okay. However, sometimes what happens, if you are having more than 10 case studies or more than 15 case studies, your data would be almost the same. I'm sure those who have studied economics in this group, you can understand the diminishing marginal utility theory. Diminishing marginal utility theory, isn't it? First, apple, I at level of satisfaction. Second, high level. Third, very high level. Fourth, marginal declining. Fifth, declining. Fifth, declining. Similarly, in case studies, okay, so there is no numbers, but try to minimize it. Use limited number of case studies so that the things will not be diluted or overrated. Okay, for that you need to take your supervisory guidance. They can guide you well. Okay, it depends upon your research as well. For example, studies related to behavioral sciences studies like stress management, working with HIV/AIDS patients, working with diabetic patients, working with cardiovascular patients. Their use of number of case studies depends upon your study. Okay, like palliative care patients, just 5 case studies you can finish your entire PhD. 5 case studies. Okay, like conflict resolution, decision making in a bigger organizations, complex organizations. There you can use 10 case studies. Like managerial decision making model, like case from Hyundai, case from other manufacturing units, 5, 6 cases. There you can analyze and you can prepare a case synthesis. There you can use 5 case studies, 10 case studies, 3 case studies. This entirely depends upon your research. Okay.
So there's one question from Sobi Chaudhary. While developing the questionnaire, minimum how many statements are required in single dimension of any variable?
Wow, great. So there is no limit. It depends upon your study objectives. Okay. As long as if you're not feeling comfortable that you would be missing the major portion, then you can have more questions. It depends upon your study objectives. Okay. And also your guides or respective supervisors can advise you. All right. There is no limit. It depends. Okay. Thank you. It was a good question.
If
Next.
possible. If you have any more queries, you can unmute or ask or post in chat
I'll
box.
I'll come back to you day after tomorrow again for another session. Firstly, you may write your questions. Come back with some of those additional questions. We'll discuss if it is interesting.
Okay, sir.
Right?
So I guess we can wind up this session for now. Can we,
Yes.
sir?
Yeah.
Thank you. Thank you for the interactive session, sir. Thank you for teaching us about the research tools in such a beautiful manner. And thank you for explaining all these questions in such a wonderful way. I'm quite sure that all the participants here have benefited from this session, and they could use it in their research. Thank you so much, sir. Thank you.
Thank you everyone. All the best for your work. Let's meet day after tomorrow. Good day. Bye-bye.
And participants, today we are having one more session by 4:30. I know this is a quite long day, but I hope you will be attending the session. Thank you.
அத யூஸ் பண்ணிட்டேன். அது இதுக்கு முன்னாடி யூஸ் பண்ணேன்.
Rajashekar sir, can we start the session?
Yes, madam. Yes, please.
Yes, sir. Good evening, one and all. Welcome to the fourth session of the day. Now we have with us an eminent resource person who has a commendable track record in the field of higher education and is associated with the School of Management Studies since 1999. He is none other than Professor B. Rajashekar, Dean School of Management Studies, Director and Member Secretary of IPSC, University of Hyderabad. Sir obtained his bachelor's degree in civil engineering, 3 master's degree in business administration, psychology and education, 2 postgraduate diplomas in computer science, personal management and industrial relations. Sir has been awarded 2 doctorate degrees in business management and psychology. Sir's primary area of interest includes service quality, quantitative techniques, operational management, industrial and organizational psychology, and research methodology. Sir is actively engaged in research and is a visiting faculty in various training institutes. Sir has published more than 75 research papers in reputed international and national journals and conference proceedings. Sir is the author, editor, co-editor of books in the area of consumer protection, supply chain management, quality management. Beside his academic activities, he served various administrative positions in the university, ranging from chief warden to the registrar. I wholeheartedly welcome Professor Rajashekar sir to this session. Sir, welcome. Sir,
Yeah, thank you very much, Arunima. Very good afternoon to all the participants. Yeah, I know this is the fourth session of the day, almost the last session, that to be online session, if not physical session. And the topic what we are going to discuss is something to do with the inferences, the inference, and also speaking about estimation, point estimate and interval estimate. That is the topic we are going to deal with. So some statistical inference dealing with point and interval estimate. So before we get into the topic, let us have some understanding that you know sampling. Yes, no. You know sampling? I think from the schedule I could see that somebody has already covered sampling. Yes, no.
Yes.
Okay, right. So assuming that you have idea about sampling, various types of samplings, sampling techniques, various types of sampling techniques. Say for example, probabilistic sampling, non-probabilistic sampling, right? And under probabilistic sampling we have simple random sampling, then stratified random sampling, cluster random sampling, systematic random sampling, multi-stage random sampling. Under non-probabilistic sampling techniques, convenient sampling, quota sampling, judgment sampling, then snowball sampling. Okay, what is the purpose of sampling? What is the purpose of sampling? Unmute yourself, whoever is speaking. What is the purpose of sampling?
It's not possible to address the entire population.
Okay,
We
fine.
collect a representation of the sample, population.
Population. So you get a sample. Then when you get the sample, what are we trying to do with the sample?
Generalize the population.
Yes, please.
Generalize it to the population findings.
Yeah, but what do you generalize?
The results.
What do you generalize?
The
Yes,
findings
please.
of the result.
Yeah, result. What is the result you have? Take an example and tell me. Take one example of population.
Yeah,
Example of
smoking
sample.
causes cancer
Hmm.
among whatever age group.
Okay.
If the finding shows that it is causing cancer, there is a probability that those who smoke more than 15-20 cigarettes per day, possibility of getting cancer is high.
Okay, fine. So can I say that the same 15 is applicable for the population, or there it is going to be different? When I am speaking about the population, can I say same 15 or something else I am going to say? You say from the sample 15 and above, 15 or above. But for population also, can I say 15 or can I say something else? Yes, please. Okay, I will take another example. What is the strength of this class?
Around 75.
75. I wanted to know your average weight of 75. Average weight of 75 people. So what I am supposed to do?
If possible, correct the entire classroom or collect from 20-30 people.
Okay, sample. So let me say I am taking 25 sample, 1/3 of the population. So population is 75. My sample is 25. Okay, 75 and 25. So for 25 students, I have taken 25 students weights. 25 students weights. I have 25 students weights. So once I have 25 students weights and I have calculated the average weight.
Yes.
Calculated the average weight. So once I calculate the average weight, so for example, I got 60 kgs as my average weight. So now my next question is, what would be the population average?
Yeah, it will be somewhere near to 60 only.
Okay. So nearly 60. You are not saying exactly 60.
It may not be possible exact 60, more or less, plus or minus. Yeah.
Okay. So this is now you are bringing something called plus or minus. I am asking about exactly 60, but you are saying it is plus or minus 60. Right?
Yeah.
So exact 60 is a point estimate. Plus or minus something to 60 is called interval estimate. This is what I wanted to communicate.
Yeah, got it, sir.
Yeah. So right now we are going to discuss about those two things, point estimate and interval estimate. Okay. Fine. Now, let me just open my OneNote. I'm going to open OneNote. Yes. Are you able to see the screen? Yes, no. Are you able to see the screen now, white screen?
Yes, sir.
Fine.
Yes, sir.
Yes, please. So now, what now I'm trying to say, capital N is equal to 75, small n is equal to 25. X bar is equal to 60, mu is equal to how much? So what is capital N? Population size. Small n, sample size. X bar, sample mean. Mu, population mean. So one option is mu is equal to X bar. This is called point estimate. Or you can say mu is equal to X bar plus or minus something. This is called confidential, sorry, interval estimate, not confidence level, interval estimate. Okay, the next question is, what is the gap between population mean and sample mean? If at all I am supposed to get population mean by getting from everybody, that is mu, and X bar is the sample mean. What is the gap between these two? Any idea? Sampling error. Sampling error. So from the above, what we can say now? Mu is equal to X bar plus or minus sampling error. Can I say that?
Yes, sir.
Yeah. This is what, but now what is this sampling error? This is the next question. I think, hope you know normal distribution. Normal distribution. What is normal distribution? What is normal distribution? Yes, please. You've already done testing of hypothesis. My class is supposed to happen on Sunday. It is postponed to Tuesday. So by this time, you are supposed to complete all your testing of hypothesis. So what is the normal distribution?
Symmetric data distribution.
Symmetric distribution. Okay.
Uniformly
Symmetric.
distributed.
Not uniform. Uniform distribution looks like this. This is uniform
Symmetrical distribution.
This is uniform distribution. But whereas the normal distribution is, this is not normal distribution, it's a bell-shaped distribution. Bell-shaped distribution. What are the properties of normal curve?
Symmetricity.
Bell shape,
Symmetrical.
Symmetric to y-axis. Then asymptotic to x-axis. What is asymptotic? Bell shape, looking like a bell. Symmetric, it's symmetric to y-axis. Symmetric to y-axis. It's symmetric to y-axis. That means y-axis is making that curve into two equal halves. Asymptotic to x-axis. What do you mean by that?
But it means both of the tails will not touch x-axis on either ways.
Correct. The fourth property. Median is equal to mode. Fifth property. Skewness is equal to 0. Sixth property. Kurtosis is equal to 0. These are the properties of normal curve. Yes, no?
Yes.
Yes? Okay, good. So from here, now I would like to know, take our earlier example. Say 65 is the mean weight of the class, for example. And 65 to 70. What percentage of the population? How many number of students are lying in between 65 to 70? This question I require. This answer I require. I say 65 is the mean. Now I am asking about 65 to 70. How many people are lying in between these two? What do you require to find out that? Yes, please. What do we require? Mean is equal to 65. X is equal to 70. I require what is the percentage? Percentage of the population lying in between these two. What else I require? Mu value 65, X value 70. What is that you require? One more variable, one more value. Sigma.
The
What is
standard
the sigma?
deviation.
Standard deviation. Right, you are right. Standard deviation is 5. Now I have given you these three values. I have given you mean, I have given you X value, I have given you standard deviation. Now you tell me what is the area under the normal curve lies in between 65 to 70. Yes, please.
One standard deviation, sir.
Yes, no, that is what. How did you get that one standard deviation?
There's some
How
formula.
did you get? Okay, what is that formula? Z is equal X minus mu by sigma. This is the formula. Actually, my idea is to drive to all of you to this formula. Z is equal to X minus mu by sigma. So here 70 minus 65 by 5 is equal to 1. For Z value 1, what is Z value? What is Z value? What is Z value?
It's one, sir. Z value is one.
No, what is Z? What Z indicates? Standard normal variate. Standard normal variate. That means instead of 65, it is 0 and 1 is the standard deviation. If you wanted to transform this particular curve to 0 mean and 1 standard deviation, so then the standard normal curve, this point is 1 standard deviation away from the mean. 1 sigma. So for 1 sigma, what is the area under the normal curve? What we have to do? We have to go to normal distribution table. Yes, no? Have you seen normal distribution table earlier? Have you seen normal distribution table? Have you seen normal distribution table?
Yes, sir, but I remember 3 standard deviation value, that is 99.73, but not 1 and 2. I didn't remember.
Okay, good. So now let me show you normal distribution table. Z table, that is known as Z table. Z table. Z table. Are you able to see the Z table?
No, sir, the board is visible.
Okay. Now, are you able to see the table? Okay. This is the Z table. Z table. It is not visible. Let us go for another table. Normal distribution table. Are you able to see the table now?
Yes, sir.
Yeah. So take Z is equal to 1. Z is equal to 1. What is the area? 0.8413. 0.8413. Right? Z is equal to 1. 0.8413. So when I say it is 0.8413. But you know the area under the normal curve. What is the area under the normal curve? Total area under the normal curve? Yes. What is it? What is the total area under the
99.73.
99.
99.73.
No, 1. Total area under the normal curve is 1. Now, are you able to see the normal curve, whiteboard? Are you able to see the whiteboard?
Yes, sir.
Okay. Yes. So this is 1. But then 50% of it is here, 0.5. It is 0.5. This part. 0.5. But it is 0.8413. That means this is 50%. From here to here, it is cumulative. 84.13. But minus 50. So it is 0.3413. So now I can say 34.13% of the students or people are there in between 65 to 70. Is it clear now? Is it clear?
Yes, sir.
Yeah, 34.13. Even otherwise also you know from normal distribution table, mean plus or minus 1 sigma is 68.26%. Mean plus or minus 2 sigma, 95.44%. Mean plus or minus 3 sigma, 99.72%. So if I take a plus or minus 1 sigma, 68.26%, that means we take the normal distribution table. It is 65. It is 70 plus 5. It is minus 5, 60. So if I take this area, this is 68.26%. But if you take this area, 34.13 because of symmetry. Got it now? The same answer we got now from the table. Right? Yes or no? Is it clear now? Yes, no. So what is the formula I said? Z is equal to x bar minus mu by sigma. But if instead of x, if it is x bar, x is a variable, x bar is the mean, then the x bar also will come here. X bar also will come here. What is this sigma x bar? Is standard error. What is standard error? What is standard error? Yes, please. What is standard error?
Standard deviation of the sample, sir.
Up to some extent you are right. SD of sample means. That means if I take capital N is the population. From here, you are taking multiple samples. N1, N2, N3, N4, and so on. So every time you are getting one sample mean. And what is the mean of the means? X double bar. Mean of the means. Mean of the means. We are taking multiple samples, and multiple sample means average of the averages is X double bar. What is the formula for standard deviation? Square root of sigma x minus x bar whole square by n. So if I wanted to take the standard error, so instead of x I am taking x bar, instead of x bar I am taking x double bar. Treating x bar as a x double bar as x bar. So x bar minus x double bar whole square by n under root sigma x bar minus x double bar whole square by n. This is known as standard error. Is it clear now? Yes, please respond. You are not sure whether you are following it or not. It is not like an offline class. Is it okay now? Standard error. Standard error is nothing but standard deviation of sampling means. So sigma x bar is equal to square root of sigma x minus x bar minus x double bar whole square by n. Is it okay? Yes, no. Is it clear?
Yes, sir.
Yes, sir. Yes, sir.
Fine, fine. So from here, now I am taking a clue. What is that clue here? Z is equal to x bar minus mu by standard error. X bar minus mu is equal to Z into standard error. Mu is equal to x bar plus or minus Z into standard error. This is called confident interval estimate, and it is confidence interval. In interval estimate, we have this confidence interval. So mu is equal to x bar plus or minus z into standard error. But in our earlier class example, I have taken only one sample. I am unable to take multiple samples. So then theoretically that was the formula, standard deviation of sampling means. But here what we are trying to say is nothing but sigma by square root of n. Theoretically, standard error is calculated as sigma is the population standard deviation by square root of n. But somebody can say, I don't have population standard deviation, then you can use sample standard deviation. S by square root of n. That is, so that means now you can say mu is equal to x bar plus or minus z into s by square root of n. So x bar is sample mean plus or minus z into s by square root of n. N is the sample size. You know, in our earlier example, x bar is equal to 65, n is equal to 25. N is equal to 25. So S value we don't know, but standard deviation of the population we know. So then you can consider if population standard deviation is not there, you can consider as S as a population standard deviation, but we are keeping a cap above this. It is called sigma estimated from sample standard deviation. So x bar is given. So x bar is given. S is given. N is given. So you require Z value. What is Z now? What is Z? Normal variate, standard normal variate, for which you have to look at confidence level 90%, 95%, 99%. So that means once you make the interval, 90% of the time your population mean lies in that interval. 95% confidence level means if you make an interval estimate, 95% of the time your population mean lies in that interval. 99% confidence level means 99% of the times that interval whatever you have developed out of 99% confidence level, then out of 100, 99 times your population mean lies in that. So in social sciences, by default, we take 95% the confidence level. This is nothing but, alpha is equal to 0.05. This is called level of significance. So that means this is a maximum kind of a chance that, the maximum possible error is 5%. So this is 1 minus alpha is equal to 0.95. This is my 95% confidence level. So for 95% confidence level, what is the Z value? That is 1.96. For 90%, 1.65. For 99%, 2.58. 2.5. 95%. So the first one is for 90%. It is for 95%. This is for 99%. So how did I get these numbers? 1.65, 1.96, 2.58. Yes, please. Yes, how did I get them? 1.65, 1.96, 2.58.
Is that score, sir, from the table? Is that
From the table. Okay, now I will show you for 95% how did I arrive. So this is the normal curve. This is the x bar plus z into standard error. Z into standard error. So it is 5%, but 5% into 2 halves, 2.5, it is 2.5%. So it is 45%, it is 45%. So if I wanted to know this value, from here to here, 97.5 is 0.9750. So go to normal distribution table, 0.9750. 9750. Are you able to see this 9750? Are you able to see this?
Sir.
This is 1.9 here. If you go to the top, 1.96. This is how we are going to calculate the Z value. Okay, we are going to calculate the Z value. So now I can say Z is equal to 1.96. Is it clear now? Is it clear up to now?
Yes, sir.
It is clear. This is all kind of a theoretical background, theoretical and mathematical background about estimation. Now I will take an Excel sheet with a data set and I will demonstrate what it is. So let me again share content. Are you able to see the Excel sheet now?
Yes, sir.
Yes, sir.
Okay, fine. This is the Excel sheet and now I'm going to discuss about the practical application of whatever I have discussed so far. So just I will demonstrate with this Excel sheet. So if I select this column, you can see how many items are there, numerical count, 5,000. 5,000. If I select this, it is 5,000. That means my capital N is equal to 5,000. My capital N is equal to 5,000. Now let me take a sample, small sample of 100. 100. Okay. So now earlier I was saying about the weight. Now it is age. It is age. So now I would like to take a sample of 100. How do I take a simple random sample of 100? Land between 1 comma 5,000. So you drag this up to 100. This is my random sample. But only problem with this rand between function. This is the function name is rand between. So, but the problem is whatever operation I do on the sheet, these numbers keep on changing. To avoid that problem, copy, paste as values. Paste as values. So now even if you type, it is not going to change. It has become static. Okay. If I wanted to sort them, this is the sample. 356, 63, 117, 146, 162, 24978. This is my sample. Now I wanted to calculate sample mean. Sample mean is nothing but X bar. Sample mean I wanted to get. Sample mean. This is X bar. X bar. So this is equal to VLOOKUP. Now I am trying to know what is the age of ID number 3. It is 61. Lookup value 3. Look at table array A12 D5001. Column index. First column, second column, third column, fourth column. Age in fourth column. Exact match. Because ID number and age should match. But here it is going to be locked because if I drag this, A1 become A2. but it should be log. If I click here 16, you can see now 16. Like that, if I double click this 56, 65, go to 56, 65, 56, 65, 63, 65, 63, 65. So that is how you have extracted. Select this column, average is given 61.76. Select this, it says 61.76. Now I want mu, that is population mean. Is it clear now? Is it clear?
Yes, sir, it's clear. It's there in the chat box.
Yeah, n is 5000. N is equal to capital N is 5000. Small n is equal to 100. Sample mean is 61.76. What is the population mean? See, actually, since if you have all 5000 data with you, I can straight away calculate. That's a different story. I can straight away calculate the population mean. But the reality, I do not have the population mean. I have only 5000 people. I go to these ID numbers. This is my sample. I collect the data from them, and each one of them has have given their age 61, 65, 65, 62. Then I got it. But now my question is, what is mu? For which I need to calculate the standard deviation. Is equal to STDEV, standard deviation. G1 to G100. G1 to G100. This is standard deviation. What is your level of significance? 5%. Your confidence level? Confidence level 95%. Then what is your Z value? 1.96. It is standard. What is your standard error? Standard error sigma by square root of 100 sample size. Sigma by square root of n. Now we have formula is mu is equal to x bar plus or minus z into standard error. Is this a formula we said? Mu is equal to x bar plus or minus z into standard error. So what is mu now? X bar, this, plus z into standard error. The similar way, x bar minus z into standard error. So now what I can conclude now? My population mean lies in between these two. Are you sure? I can only say 95% of the time. 95% of the time. 95% of the time. It lies in between. But let me really check the average. Select this. You can see here average is 61.73. 61.73. See, simply now I have selected this column and it is said 61.729. 61.729. So 73. So is 61.73 lying in this interval or not? Is it lying there?
Yes, sir.
So now this is what it is. This is what it is. If 10%, 90%, 1.65, standard error, same. Okay. What is the interval? Sample mean plus Z into standard error. Z into standard error. Here, standard sampling mean minus Z into standard error. So if you compare these two, 62.75 is 90%. 61.76, 10%. It is 10%. If it is 99%, you can see 99%. Level of significance is 1%. Your level of significance is 10%. It is 2.58. This is another interval. So now let me say this 61.96 plus 2.58 into that is equal to sample mean minus 2.58 okay. So the 61.73 lies in all the three. Is it lying between all of them? Yes or no? Yes or no? Is 61.73 is lying in all the three intervals? Yes, please.
Yes, sir.
So if you look at this, you know what exactly happening is the least is here. Copy. Okay, this is for 10%. Then this is for 5%. Okay. This is for 5%. This is for 1%. So what is that you have noticed out of these three? Yes, please look at the gap between these two. 1.59, 1.89, 2.49. As you are increasing the interval percentage, this is becoming narrow. The reason is You take the normal curve. It is mu. This is 99%, 0.05. So this is the interval, 99%. So here, 95%. So this is 2.5. It is 90. It is 5%. It is 5%. So this is the least 90%. So 99% means interval is increasing. 90% means interval is shrinking. Got the logic? Why this width is reducing? Why width is increasing? Have you got the logic now? Yes, please.
Yes, sir.
Is it clear now, or is it becoming more technical?
It is clear, sir.
Yeah, I know, little technical, little mathematical, but it is inevitable. So we need to have idea about it. So that is how you can make the generalization of sampling results to the population, or you can make the estimation of the population based on the sample, whether it is sample mean or whatever. Okay. So now I'm going to do one more interesting exercise here.
Sir, what is VLOOKUP used for, sir?
What is
VLOOKUp? You have used the function
VLOOKUP is out of this 5,000 values, whichever value I want, I'm going to take. For example, your board results, 10th plus 2 results. About lakhs of people have appeared for the exam. All the results are at one place. So whenever you type your hall ticket number, you are going to get your score, for which we use this VLOOKUP function. V for vertical. The data is arranged in the vertical manner. We use this function VLOOKUP.
Okay.
Now, when you enter your hall ticket number, you get your rank, you get your score. This is the function they use, not necessarily this, but similar to this.
So from the randomly selected samples, you have taken for VLOOKUP.
Yeah, I have taken their actual ages, whatever age belong to that ID number.
Age. Okay, sir. Thank you, sir.
Now, I would like to say, for example, as I told you, X1 bar. Instead of one sample, I am taking multiple samples. X2 bar. So like that, I would like to take some 10 samples. X1, X2, X3, X3, 4, 5, 6, 7, 8, 9, 10. I will take 10 samples now. 10 samples and try to calculate standard error by using our regular method, not the approximated value. For which, so here the mean is 61.76. 61.76. So here I'm using the function called rand between. Now I'm using this dynamic nature of this function. Now I got a different set of random numbers. If I select this, it is 61.94. 61.94. By the time I type out 61.94, I press enter, my sample will change. You can see I got a different sample. So select this 62.58. Press enter. I got another sample. 61.21. Press enter. I got another sample. 61.09. I got another sample. 62.03. I got another sample, 62.04. 61.58. 61.64. 61.14. 61.14. So like that, I have taken 10 samples. So this is sample mean. What is sampling error? What is the mean? 61.73. If you select this 61.73. So 61.73 is actual population mean. If I get an opportunity to know, it is 61.73. So I wanted to know the sampling error. Sampling error is this minus this. Let's say F4 log 0.03. So you can see that error 0.03, 0.21, 0.85, 0.52, 0.64, 0.3, 0.31, 0.15, 0.09, 0.59. So what is that interesting part is the error is very small. It is because of random sample. This is what I wanted to say. So if you take random sample, your sampling error is very, very small. As I told you, sampling error is nothing but the difference between population mean and sample mean. Is it clear? Is it clear now?
Yes, sir.
Yeah, good. Now I wanted to calculate the standard error. Standard error is equal standard deviation of this sample means 0.44765, 0.448. So how I got it? 0.448 by taking the standard deviation of sample means. But if you look at our earlier standard error, 0.482, almost we are there. 0.482, 0.482, 0.482, 0.482. Okay. Or if you are able to get the population standard deviation, that is sigma population standard deviation, STDEV dot P, that is population. P means population. D22, D5001. This is the standard deviation of the population. So standard deviation of the population. Standard error is equal to this divided by square root of 100, 10. So it is also almost there, 0.477. So if you use the population standard deviation, 0.477. If you use the sample standard deviation, 0.482. If you use the standard deviation of sampling means, it's 0.448. 482, 477, 448. So you take the sample standard deviation and square root of n, population standard deviation square root of n. The difference is very narrow. This minus this 0.005. That is the reason why even if the population standard deviation is not available, you are taking the sample standard deviation. Interesting? Okay. Okay. Is it okay? Clear now? So this is how you are going to make the interval estimate.
Sir,
So
can you
once
explain again the standard deviation part, sir? Last part.
here, standard deviation of the population, I'm taking all 5,000, that is sigma. Sample standard deviation is S. It is sigma. So this is your standard error. This is S by square root of n. S by square root of n. Whereas this is sigma by square root of n. That is the difference. You got the difference now? S by square root of n, sigma by square root of n. Both are almost same.
Okay,
But this 448 is standard deviation of sampling means. These are the sampling means. But maybe theoretically on Excel sheet I can do, but in real life, whenever we are doing our research, we do our research with only single sample. We are not going to do research with 10 samples or 20 samples. So that means in reality, even whenever you have the standard deviation and the sample means, sample mean and sample standard deviation, you can get one set of standard error for that particular thing. Because sample size you know, standard deviation you know. But the sample means are almost the same. Even the sample standard deviations also will be almost same. If I wanted to calculate the standard deviation, for example here, STDEV of sample, now it is for sample, G1 to G100. You can see now standard deviation 4.10. 4.10. So it was earlier 4.77. 4.77. If I type one number, whatever, so you got 4.8. It is 4.8 to 4.77, 4.8. If I type another number, another sample, 4.75. Another number, 4.57. They're all comparable. They're not going to be very, very far off because we are taking random samples. We are taking simple random samples. So when you take simple random sample, so obviously the values are mostly comparable. See, almost all your means are comparable. So if you wanted to take the error here, this 200 divided by 61.73. This is the percentage. You can see how small it is. 0.3, 1.3, 0.8, 1.0. This is the error, 1%. Very, very small error we are getting. This is almost negligible. This is the error. This is error. This is error percentage. Error percentage. Okay. This is error percentage. This is error percentage. Error percentage. These are the means. They are means. So they are means. This is sample number. Sample. Yeah. This is how it is. Sample mean, error, percentage of error. This is actually population mean. Population mean. From population mean, you are getting these errors. And this is all exercise I have done for 100. I can do the same exercise for 200 also. I can do the same exercise for 200 also. 300 sample size, 400 sample size. The next important question is, how do we determine the sample size? This is always a very important question. Here randomly I have taken 100. But how do I determine the sample size? So this is the next important question. So how do we determine the sample size? So we determine the sample size by using the same approach. Let us take the formula. The formula is mu is equal to x bar plus or minus z into standard error. So z into standard error is equal to mu minus x bar. So z into standard error is equal root of n is equal to e. So square root of n is equal to z into sigma by e. So n is equal to z square sigma square by e square. N is equal to z square into sigma square by e square. Z is, that Z value from the table for a given level of significance or confidence level. Sigma is the standard deviation of the population. If standard deviation of the population is not available, you take a pilot sample. From a pilot sample, you can get the standard deviation. So then the formula becomes N is equal to Z square S square by E square. Instead of sigma, you take a pilot sample. From pilot sample, if you are from earlier studies, if you know the population standard deviation, you substitute sigma. If it is not there, you can use S. A small sample you can take as a pilot sample, from where you can calculate S, then N is equal to Z square into S square by E square. So you know Z value 1.65, 1.96, 2.58. Error, how much you are going to tolerate? That error. How much error you can tolerate? That means, for example, 65 is the mean. So one error I can tolerate, 64, 67, 60, 63, 62, whatever difference. That is the error you can tolerate. S is the standard deviation of the population. If the population is not available, pilot sample. Substitute those values, you get N value. Interesting thing is there is no capital N in the formula. There is no capital N in the formula. That means sample size is independent of population size. Sample size is independent of population size because there is no capital N in the formula. But if S is more, N is more. That means standard deviation is more, sample size is more. If Z is more, N is more. Your confidence level is more, then N will be more. That means you wanted to have more confidence. 99%, you need to be very close to your value. Then N should be large. And the error you tolerate less, then sample size is more. More error you can tolerate. E is more in the denominator. N will be small. So I can tolerate more error. Sample size can be small. For example, you take your own class of 75. I wanted to have more accurate value. I require larger sample like 30, 40. Even 4 or 5 error is fine. I can have only 5. So that is how the sample size is going to be determined. More error you can tolerate, less sample size. Less error you can tolerate, more sample size. So that is how we are going to look into that. So with this formula, I'm going to use an Excel sheet here. Excel sheet. From here, I would like to calculate the values. Z value, E value, sigma value. These are the values I require. And I wanted to calculate N value. Z is equal to 1.96. Error. What is your mean? 61.73. 61.73. And I am now looking at 0.2 error I can tolerate. 0.2 error I can tolerate. Standard deviation of the population. Sigma here. This is sigma of the population D2 to D5001. This population, 5000 values. So 4.77. 4.77. So what is our n value? Z square into sigma square. Z square into sigma square by E square. So if you wanted to tolerate 0.2 error, you require 2185. You can tolerate 187. Tolerate 0.5, 350. Error. Tolerate 0.4, 546. Tolerate 0.6, 243. Tolerate 0.7, 170. This is how you are going to get the sample size. How much error you are going to tolerate. That is going to decide your sample size. If, for example, I can tolerate error 2, when 22 sample is fine. 22 sample is fine. So let me take 22 sample and find out what's going to happen. This is my population mean. This is my mu. This is my mu, right? This is my mu. Mu is equal to this 61.73. Now I can tolerate error 2, but it is 22 sample is sufficient. So here, let me take sample size. Up to 22. So I'm deleting the rest of the things. So how many items are there? 22 items. What is the mean? 61.86. You can see 61.86. Mean. Sample mean. 61.86. The interesting thing is with the 22 sample also we are almost there. Almost there. The error is 0.13 because I can tolerate error up to 2. I can tolerate error up to 2. So fine, 61.86 is almost. So earlier unnecessarily I have taken 100 sample. With the 22 sample I would have managed the show. The 22 sample also I would have managed. If it is 61.86, what's going to happen now? 61.86 plus Z into sigma by square root of 22. Square root of 22 is 63.85. In the similar way, this mean minus Z into sigma by square root of n. What is the difference you can see now? Almost 2 plus 2, 4. When I say I can tolerate error 2 plus 2 minus 2, it is 3.99. Got the logic? And this 61.73 very much lies into this. But even it is 95%, remember. It is only 95%. 95% confidence level. 95% confidence level. If I am making 99%, what will happen? It is 2.58. So what is the sample size you require? 38. Go to 38. 38. It's 38. Double click, automatically the values are calculated. So what is the mean? You select this 61.84. 61.84. The difference is very narrow. The error is 0.11. Then here, it is not 22. Can make this so that automatically it will compute. The difference is again 4. 63, 59, and obviously the 61 very much lies in between. So with this kind of a technique, you are going to get the sample size. And once you get the sample size, you are going to make the estimation. You are going to make the estimation of the population mean, but giving one single number is called point estimate. Giving the interval is called interval estimate. So this interval is called confidence interval. As you are increasing, for example, if I say 90%, I can tolerate 90%. So here it is 1.65. So even 15 sample is fine. But only thing is 90% of the time only this interval will contain the population mean. That is the logic. So 10% of the time your population mean is out of this interval. So if I take 15, here 15, delete this. So you type something, yes. We got, these are only 15 values now. Count 15 values. The mean is 62.27. 62.27. The error is increased 0.54. But still it is 62, 64, it is 4. And still it contains. But maybe 10% of the time it may not contain. So because the interval, when you are using it, there is no change in the interval. You see that same interval, but sample size is less. So then without knowing this unnecessarily, I have gone for 100 sample last time. So when I am going for random sample, when I am able to tolerate error 2, for example, I am able to tolerate 1.5 error. 28 is fine. 1.5. See 1.5 plus 1.5, 3. This is 28 items. So 28 items. Some numbers I am typing, whatever. Yeah. So if you see this 28, count 100. 62.36. 62.36. This is 0.63. 28 sample size, 63.86, 60.86, 61.73. This error is 3. So by changing the error, your sample size is changing. By changing the Z value, your sample size is changing. By changing the sigma, your sample size will change. For example, I have been using 4.77 population standard deviation, but I don't have that information. I take a sample, some sample. Sample standard deviation is 4.82. So I type this 4.82. This is my sample. So you will stay 28 because the difference is negligible. 4.82. But I want to tolerate the error 2. 16 is fine. 1, 63. If I wanted to tolerate 1, 63. So go to 63. 63. It is 63. Okay. Now you take that. $60.89. 60.89. 60.89. 60.89. Error in 0.84, 61.889, 59.89. But plus or minus 1 is 2. So n is equal to 63. So this is one interesting formula. So n is equal to z square into sigma square by e square, L square. So remember, n is directly proportional to z square. So z is increasing, n value will increase. Sigma is increasing, n value will increase. E is increasing, n value will decrease. So for a comparison purpose, now here I can show you 90%, 99.5%. I would like to make a comparison. 95%, 99%. So it is 1.96, 2.58. 1.6 general, 1.96. So error I would like to tolerate same. The only I'm changing this sigma I would like to keep same. So if you look at this, so what is happening as confidence interval is increased, 90 confidence level is increased, 90%, 95%, 99%. Sample size is increasing. So more confidence level, more sample. That means 99% of the time you expect your population mean should lie in that estimation. So it is 155. This is one. The next one is I keep all of them same. So I'll keep 2 and 3. All other things are same. So what happens you see now? 90%, 90%, 90%. Sorry. So what happened you see? I kept same Z value and the same sigma value. I changed the error. So when the error is increasing, sample size is decreasing. 63, 16, 7. Clear? Now I'll keep all of them same. 1, 1, 1. Here it is 4.82. It is 5. It is 5.5. I only changed the standard deviation. 4.8, 5, 5.5. D2 square into D4 square by D3 square. Why I am getting 82? It's fine. It is fine. D2 square into E square by sigma square. Sigma square. 4.8 to 5 and 5.5. Should not be 82, no? Should not be 82. How it is increasing? D2 into D2 square to D4 square by error. Yeah, you are right. So when the error is increasing, for example, yeah, you are right. 4.8 to 5.5 and 6.5, for example. So when the standard deviation is increasing, sample size increases, right? Homogeneity, heterogeneity. More the heterogeneity, more the sample size. 4.8 to 5.5, and standard deviation is only 1, for example. N is equal to 3. 3 sample is also sufficient. So if sigma is small, it is 2. 11 sample is also fine. If it is 3, 25 sample is fine. But more sigma, that means data is more heterogeneous. Data is more heterogeneous, I need a large sample. When sigma is small, data is close to homogeneous. Sample size, for example, here sigma is equal to 0. So there is no need to study the sample. Only one item is sufficient. Study one item, like when you are cooking rice, one rice grain is sufficient enough to know whether rice is cooked or not, because rice is homogeneous. One, for example, sigma is 0.1, 0, 0.15, 0, 0.5, 0, 1. So when the standard deviation is very small, even a very, very small sample also can be sufficient. The standard deviation is close to 0, then even one sample is also going to tell about everything. Like one blood drop is going to say about everything about your body, because whole blood is homogeneous. So one drop is sufficient enough to know the properties of the whole blood. So that is how we can understand this interval estimate, point estimate, confidence level, and margin of error, standard error, sampling error, sample size determination, sample standard deviation, population standard deviation, and level of significance, confidence level. So this is what is the discussion, and this is how it is. So now it is 5:58. If you have any quick questions, I'll answer before I wind up.
Sir, this error value, we can give it, sir, or there is any specific value should be given for the E value? E value, sir, error value.
Error value, it all depends. For example, it is gold, 1 milligram. If it is iron, 4 kgs also fine. See, it all depends on the nature of the product, nature of the situation. See, if it is age, 62 or 63, not going to make much difference for me. Then I can keep 1. But if it is a medicine, even 1 cc is also going to make the difference. So this is all depends on the situation and context. It is not very generalizable. Or maybe for particular product or particular segment, I think they are predetermined. So this kind of error can be tolerated.
So there is any other method for sample size determination, sir, other than this?
Yeah, this is very popular. There are several methods, but they are not very popular.
Okay.
This method is very popular, and there is Kresis and Morgan. They have a table, 1971 paper published in Educational Psychology. So they have given a population size, and they have given some sample size. So finally, what they said is it's more than 10 lakh population, 384 sample is required. 384. That is the reason why, if you look at that old generation PhD thesis, everybody takes 400 sample size, because the 384 from where it has got. And there are 2 or 3 other formulas are there, but they are not very popular. So this is the most popular kind of a formula. That is where I have discussed it.
Thank you, sir.
Yeah, but only one caution is your sampling technique should be random to determine this. That is what is very, very important. That is where, if you look at all my class, the error is very, very small, because after all, they are all sample. If all of them are like, sample, random samples. That is the reason why, your mean is almost same. But it may not be true with your convenient samples or quota samples. Okay. With this, I think, now it is 6:01. I'll stop here. Thank you very much. I know this is a little technical, but it's very interesting.
Social sciences, in what situation we will have to decide whether to use point or interval estimates, sir?
No, point estimate, I think, when the sampling is homogeneous, population is homogeneous, then only you can go for point estimate. See, for example, if you wanted to go for fishing, when do you use this hook or when do you use the net? Which is more preferable, net or hook? Fishing rod. Fishing rod is better or net is better?
Net is better.
So net is confidence interval. Fishing rod is point estimate.
Got it.
Yeah. But the very important thing is your net size is also very optimal. You cannot have too much of net. For example, somebody writes the exam, how many marks you secure? That fellow says 0 to 100. That will not make any sense. Or somebody may say 60 to 62. That may not also make any sense. So interval should not be too narrow, too wide. Got it?
Yes, sir. Thank you.
Yeah. Yes, please.
If you have any queries, kindly ask. With this, the session comes to an end. I request one of the participants to share feedback for the session. Kindly share your experience, one of the participants. Okay. So it was a very informative session. Even in your busy schedule, you accepted our invitation and in the same manner, the participants, even in the fourth session, are really waiting for the resource person. So thank you so much. So, on behalf of the entire department farmers and group director, I would like to thank the resource person, Shigar sir, and all the participants for sharing a valuable time with us. Thank you so much.
Okay then. Thank you and all the best. See you then. Bye.
Thank you, sir.
Should we wait for the feedback form?
Dear participants, there is a small group for sharing the feedback form. It will be shared in the WhatsApp group. Kindly fill it. Today's feedback, the sessions. Thank you so much.
Thank you.